Hello, my dear students. I welcome you to this amazing platform of PhysicsWallah English. Guys, in today's session, we are going to cover vector and 3D geometry. Now, if we talk about weightage of this chapter in JEE Main, 3 questions, 2 to 3 questions are for sure going to be there in your exam, in any shift. It has to be there at least 2 or 3. Okay, so sometimes questions are lengthy, sometimes questions are extremely easy, but never difficult. See, I'm using the term lengthy because there are some questions in 3D geometry whose calculations can be huge, but there is not a single difficult problem you will see from vector 3D in your JEE Main exam. If I make a chart or make a sequence of easy chapters, okay, like the easiest first, and then it will descend to tough. The first chapter will be vector in 3D, right? Vector in 3D, and I'm talking about the chapters which are mainstream. Let's not talk about this mathematical reasoning. Okay, that is the easiest. But if you talk about mainstream chapters, vector 3D is the easiest section of class 12th, even easier than limits. Okay, there is not much theory. Okay, there are fixed types of problem getting asked in exam. So in today's session, we are going to cover vector first and then 3D, and then you will see we have to like the type of PYQs. All relevant PYQs have been taken in this session from 2020, 2019, 2018, 2021, and you will see the kind of question they're asking is like it's nothing. It's not a big deal to solve these problems with 100% accuracy. Okay, so let's start the session. Starting with vector first, I'll explain all the basic thing behind vector. Now, talking about definition of vector, vector is a quantity which has magnitude and direction both. So, vector is a quantity which has magnitude and direction both, right? So, when you represent a vector, suppose this is a vector quantity. So, AB, this is a vector. So, this is called initial point, and this is called final point. Right, or this is initial, or this terminal point. Okay, this is called the terminal point. This is called terminal point, right? So this is vector AB. Now every vector has some support, or you can say the line from which it is derived. Okay, basically vector is what? Vector is a line segment, directed line segment. This is basically a directed line segment. Vector is directed line segment. So from any line which is there in the plane, you can cut some part, you can give it some direction, that will be called a vector quantity. So the line from which that segment is taken, this is called support. This is called support for that vector. Right? These are very basic things. I don't need to discuss them in detail. So let's keep moving forward with the types. Now the types of vector. If you talk about types of the vector, for the types, the first one is null vector, right? Null vector, also represented by O. So when we have if we have a point, now that point will be a null vector because it does not have any direction. Okay, the magnitude is 0. It will not have any direction. It will have magnitude 0, right? Magnitude is 0. This magnitude will be 0, but there will be it will not have any fixed direction, right? So the first one is null vector, and second is unit vector. So if you have to define a unit vector, what is it? Vector which is having unit magnitude in the given direction of a vector. So suppose this is some vector A, this is some vector A. So I need only the part which is of length 1. So the unit vector A cap is given by A by mod of A. So if you divide by its magnitude, it will be unit vector. Okay, in the same direction. So the third one, null vector, unit vector, then we can define what? We can define co-initial vectors. Or co-terminal also. So co-initial vectors. So when we have more than 2 or more vectors, if they are originating from same point, they are called co-initial vectors. Okay, Then similarly we can define coterminus also. This is co-initial, and suppose we have to define coterminus. If we have to define coterminus vector, so if their terminal point is similar, so like if we have a set of vectors which is terminating at the same point, so that will be called coterminus vector. Then in the types, the most important type that we talk about is like, or let's say parallel vector. Parallel vectors. So if vectors having same support, this is definition, vectors having same support, having same or parallel support, same or parallel support, right? Vectors having same or parallel support will be called parallel vectors. Also we call them collinear, parallel or collinear vectors. Same thing, parallel vectors or collinear vectors, vectors having same or parallel support. So for example, suppose we have vector A here, okay, then this is vector B, and let's say this is vector C. So you can see all these vectors have their supports parallel, okay, and all of these are parallel to each other. So here you see vector A and vector B are what? These are parallel vectors. A, B, C are parallel vectors, but A and B are like vectors. You see, when they have same direction, A, B, these are like vectors because they have same direction. And here this B and C, as per the diagram, B and C are unlike vectors. Unlike vectors because they have opposite direction. So here you need to remember one thing here, a very important point, that when vectors are collinear, you see, suppose this is some support, or let's do it like this. Suppose if vectors are given this way, this is some vector A, and on the same support we have another vector B. Here we have, this is vector A and this is vector B. So you can see vector A and vector B, they have same initial point, they are parallel vector or collinear vector. So in this case I can write, that if A and B are collinear, right? If A and B are collinear, then A will be equal to something lambda times B. I can write that because these two will have only one, the only thing required to make them equal is some constant value. If they are in the same direction, that lambda will be positive, and if they are in opposite direction, suppose in this case, suppose this is vector A and this is vector B. So in this case also these two are parallel, but this time for this case lambda will be positive and for this case lambda will be negative, because these two are in same direction but only magnitude needs to be adjusted. Okay, if magnitude is adjusted, we'll have the value. So if A and B are collinear vector, then A will be written as something, A is equal to lambda times B. Very important point. But what if A and B are non-collinear? What will happen in that case? See, if A and B are non-collinear, what will happen in that case? So we don't have that much space. So let me add a page here. What if A and B are non-collinear? Copy, paste. Now this is very, very important. So when we don't have vectors collinear, still, okay, suppose if it is given that if vector A, B are non-collinear, right? Vector A and B are non-collinear, and it's given that something x vector A plus y vector B is 0. In this case, this will always mean that x is 0 and y is 0. These scalars value x and y will be always 0. It's true only if vectors are non-collinear. Why? Because see, if vectors are non-collinear and you still have been given that xa plus yb is 0, now this will have some different meaning then. Then we can write xa is equal to minus yb. So vector A will be equal to minus y by x times vector B. So here A becomes equal to lambda B. Now this is not possible, right? Because you just said that vectors are non-collinear and you have got A equal to lambda B. A equal to lambda b we get when vectors are what? Collinear. That is totally wrong. So we have to make coefficients equal to 0. So x equal to 0, y equal to 0, where a and b are non-collinear. And this result you are going to see a lot in many number of cases, right? So if you talk about some other type, then we have coplanar vectors. Now what do we mean by coplanar vectors? So if we have vectors lying in the same plane, right? If we have vectors lying in the same plane, these all are coplanar vectors. And two vectors are always coplanar. Two vectors are always coplanar because these two will form a plane. Two vectors will be always coplanar. More than two cannot be said. More than two can form a space also. But if you are given only with two vectors, these all will be coplanar. And we are only going to deal with free vectors. If vector is given, we can translate it without rotating. Right? We can, all these cases where whatever thing we are doing in mathematics, we will be dealing with only free vectors. We are allowed to translate that vector without changing its direction. Cool. Moving on to next point. Triangle law, parallelogram law. So triangle law. What is triangle law? Triangle law says that, so if we have this as vector A and this as vector B, then the resultant is given by the closing side. This is C, right? The resultant is given by closing side. So here we have like vector A plus vector B is equal to vector C. The resultant is closing side. Resultant vector C is closing side of the polygon. Is closing side of polygon. And this can be generalized for a polygon also, not just for triangle. If you draw a shape where we have 5 sides, 6 sides, so the final resultant, okay, that will be the closing side of that polygon. Okay, then this is a triangle law, right? In triangle law you can see one more thing, like in this triangle, guys, if I reverse the direction of C, right, if I reverse direction of C, then what will happen? This is vector A, okay, this is vector B. Now this was C, so now what is this? What is this? This will be minus C, right? When you multiply by negative sign, the direction of that vector will change. Now here, if I slightly like rewrite this result, A plus B minus C is equal to 0. What is it here? A plus B plus minus vector C equal to null vector. So can you see that A, B and minus C are forming a closed loop? A, B and minus C are forming a closed loop. So whenever a closed loop gets formed, the sum of vectors will be 0. The direction may be cyclic, or like it can be like clockwise or anti-clockwise. So this is an important thing here, that if vectors form closed loop, it can be of any order. It can be anti-clockwise or clockwise. If vectors are forming closed loop, in that case, resultant will be 0. The final resultant will be null vector. Like here, A, B and minus C. So A plus B plus minus C will be equal to null vector. So this is about triangle law that we should know. In case of parallelogram, you know that if we have two sides of parallelogram known, so the diagonals, like this is vector A, this is vector B. So this is a parallelogram formed. So for this parallelogram, okay, the diagonals will be the resultant. So suppose this is D1, and this is D2. So what will be D1? Vector A plus vector B will be equal to vector D1. This is the resultant. D1 is the resultant, and we get this by triangle law, that you already know. What about D2? Now you can see that A plus D2 is B vector. You can see here that this is vector A plus D2 is vector B. So A plus D2 vector is equal to vector B. So what is it with D2? D2 vector will be equal to vector B minus vector A. Right? This is what? This is the resultant. This is the second diagonal, D2. So D1 is simple, A plus B equal to D1, and this is D2. Clear? I hope these things are clear to everyone. Then talking about position vector and section formula. So see, if we talk about position vector, so suppose there is one vector A whose there is a point A whose position with respect to origin is A. There is some point B whose position with origin, right? When we say position vector, that position is defined with respect to some fixed point. That fixed point is known as origin. Okay, when you say that position vector of point A is A, so that means that the position of that point with respect to origin is A. So this vector will be A vector. So OA vector will be A vector and OB vector will be B vector. So now in this OA vector and OB vector, like this, these are position of A, right? This is position of A. These are position vectors. So with help of position vectors, we can always define a vector, right? We can define a free vector here. Like suppose if I join this. Now what is this? In this system, we have vector OB plus vector BA is equal to vector OA, right? So what is vector BA, guys? Vector BA comes out to be equal to vector OA minus vector OB. So if position vectors are known, we can find out that vector which is framed using those position vectors, right? It's always final minus initial, right? BA, A is final, B is initial, so it's final minus initial with respect to origin, right? We are writing basically vector AB in terms of position vectors, clear? Using simple triangle law. So this is about position vector. Then section formula, guys, we can suppose there lies 3 points. So position of A is vector A. There is some point B whose position is B, and there is one point R, one position vector R, which divides this into internally ratio m is to n. There is some point, let's say R, whose position vector is R vector, and let's say origin is somewhere here. Okay. So now obviously if I am writing A, B and R as a position vector, I am writing with respect to origin. So you can consider origin anywhere. So with respect to these origin, position vectors are given. So what is this will be R? Since this is internal division, it will be MB vector plus NA vector divided by M plus N, right? If it was external, it will be MB minus NA, just like you remember in coordinate geometry. Also like here, in general case, if R is midpoint, if that R is midpoint, then position vector R will be equal to B plus A divided by 2. B plus A divided by 2 will be position vector. Clear? I hope, guys, that all these points are clear. Now, if I write a vector in terms of, guys, in terms of x, y, z, I hope you should be able to, you have the idea that what is modulus, how to find out distance between two vectors, right? When you find out distance between two position vectors, you are basically finding its modulus, right? When you, in terms of position vector. So suppose if we have any vector P given as xi cap plus yj cap plus zk cap. So what is magnitude of P? It will be root over x square, y square, z square, right? And what is this x? This x is component of P on x-axis. This y is component of P on y-axis, component of z is on z-axis, right? So I have these all informations are quite basic. I assume that you are skipping these because almost everyone knows, right? So now let's talk the real deal. Let's do some questions. Question says that vector has a component 3p and one with respect to rectangular Cartesian system. This system is rotated through a certain angle. Okay. So see, components is given 3p and 1, right? Components means we just talked about that. Like when you write a vector as xi cap, yj cap, the component on x-axis is x, component of y-axis is y. So here, can I write this vector r is equal to 3p I cap plus j cap, right? So this vector r here is what? Is rotated through a certain angle about the origin in the counterclockwise sense. Okay. If A has component p plus root 10, then if with respect to new system, okay. So see, this r, and after rotation of angle theta, we got r1. And you see this r1 vector is also given. What is it? What is r1 vector? It is p plus 1 and root 10. So r1 vector after rotation is p plus 1 I cap plus root 10 j cap. Then value of p is equal to. So what did you observe? What is not changing? Magnitude is not changing. You see, they have not mentioned anything about magnitude. So what we assume that mod of vector r will be equal to r1 ka magnitude. So what is mod of r? It is 3p square plus 1 is equal to p plus 1 whole square plus 10. It's simplified. This is 9p square plus 1 is equal to p square plus 2p plus 10 plus 1 11. So guys, this will be 8p square and minus 2p and minus 10 equal to 0. So see which will be satisfying. If you put p equal to minus 1, so this is 8 plus 2 10. This is satisfying. Got the point? Clear? So this type of question was asked 2-3 times in the same 2021. Right? Don't get confused with the component. They just simply write the vector. Component Cartesian system. What do we mean by rectangle Cartesian system? It's our xy axis. So for r and r1, the components were known. It's pretty simple to write. It's pretty simple to write the vectors. What is not changing? Their magnitude. Equate them. You got that. Clear? Then let's move to next question. If vectors a1 and a2 are collinear, then a possible unit vector parallel to the vector. Okay, these vectors are collinear. So when we say that two vectors are collinear, then what will happen? We'll write that a equal to lambda b. So when you say that a equal to lambda b, that means let me write like a general result, guys. Like a vector p, let's say this is x I cap plus y j cap plus z k cap. Okay, and a vector q, which is x1 I cap, y1 j cap, z1 k cap. So if p and q are collinear, if we say that p, q are collinear, then remember p will be equal to lambda q, or the better way to remember it is that the coefficients of ijk will be in proportion. The coefficients of ijk will be in proportion. If you have any confusion, just remember it. Okay, vectors are collinear. So in the same case here, you see if we are saying that a1 and a2 are collinear, so we can compare the coefficients. So what is it? X upon 1 will be equal to, this is minus 1 upon y is equal to this is 1 upon z, and let's say this is equal to some constant lambda, right? So we have x equal to lambda, y equal to minus 1 by lambda, and z equal to 1 upon lambda, right? Now we'll use it. Possible unit vector parallel to the vector. Unit vector parallel to the vector. So what is, let's say this is some vector p. This is some vector p. This is vector p. So we want a vector, unit vector, which is parallel to this. So we want p cap. So what will be p cap? It will be xi, right? Let's write everything in terms of lambda. So what is it? If I write everything in terms of lambda, so x is lambda, lambda I cap, y is minus 1 by lambda, j cap, z is 1 upon lambda, k cap. So p cap is vector p by its magnitude. So under root of lambda square plus 1 by lambda square plus 1 by lambda square. Something like this, correct? Something like this. So and since we don't have idea about direction, right? We want just a parallel vectors. It could be p cap or minus p cap, same thing, right? So this is what, if you calculate it, how much we are going to get it? This lambda, right? Here from here also, if you take lambda square here, so this is going to be equal to plus minus lambda square I cap minus j cap plus k cap and divide by, you see, lambda power 4. This will come out here, lambda power 4, and 1 by lambda will be cancelled out, because so this will be under root of lambda power 4 plus 2. That's it, right? Now see, lambda could be any real value, so we need to check from options. So if I put lambda equal to 1, so I cap minus j cap plus k cap divided by 1 plus 2 3, this I am getting it, right? You see, you can put lambda any real value, And from options, you can clearly see that if you want root 3, you have to put lambda equal to 1. If you want root 2, you'll put lambda equal to 0. If you put lambda equal to 0, this will be minus j plus k, but it is I minus j. It will not satisfy the other one also. If you put lambda equal to 0, right? If you put lambda equal to 0 here, but can lambda be 0? You see, you cannot put lambda equal to 0. Guys, why? Because if you put lambda equal to 0, here y and z will be something, what? Y and z are real values, and it won't be holding true. So you have to put lambda equal to 1. This will be correct. I hope you have understood it. Quite simple logic, coefficient comparison. Moving to next problem. Alpha, beta be two given vectors where vectors A and B are non-collinear. A and B are non-collinear. Okay. Okay, this is the problem. Every time the vector sign is missing, and this is this, right? So alpha and beta be two given vectors where vectors A and B are vectors A and B are non-collinear. The value of lambda for which vectors alpha and beta are collinear. Okay, since they are mentioning vectors, so I think I can skip sign, right? Let A equal to vectors A and B are non-collinear. Fine. The value of lambda for which vectors alpha. So alpha and beta are collinear. Now same thing. See, when we say I cap, j cap, k cap, that is also the same system because those are non-collinear. The same thing here, same logic. So you will write lambda minus 2 divided by 4 lambda minus 2. Make coefficient in proportion. So 1 divided by 3. That's it. Lambda minus 2 divided by this is equal to 1 divided by 3. So this is 3 lambda minus 6 is equal to 4 lambda minus 2. We have lambda equal to minus 4. That is the answer. How simple funda is this? Collinear, if they are collinear, compare their coefficients, write them in proportion. Root 3i, root 3 j respectively be the position vector of the point ABC with respect to the origin. Fine, right? If the distance of C from the bisector of the acute angle between O and OB is 3 by root 2, then sum of possible values of beta is okay. Now bisector of acute angle, you see, if you draw this, guys, you see the position. You see the position, the triangle here, the triangle which has been said, see, the triangle which has been said here. So this one is origin. I think we can do it without vectors also. You see. So this is O. Okay. Position vector point A and B. A, B. So what is A? A is root 3 comma 1. And B is 1 comma root 3. Right. So distance of C from the bisector of acute angle between O and OB. Right. So clearly we have a triangle here, right? We have all the vertices known and we want acute angle bisector, right? So what is this side length? What is side OB? Root 3 square 1 square 2 and this is 2. Side length is 2, correct? So we know the property bisector that it divides them equally. So since this is isosceles, so this will be at right angle also. This will be at right angle and this will be midpoint, correct? So it will be root 3 plus 1 by 2. Comma root 3 plus 1 by 2. Right? There is no need of vector here. So what do you want? What do you want? Distance of C from the bisector of the acute angle between O and OB is 3 by root 2. Now I can write equation of this line. So this will fall into y equal to x. Right? What is the equation here? Equation this line will be, you see, y equal to x. So you are finding perpendicular distance of this from this point, beta comma 1 minus beta. So let's say here is some point. Beta comma 1 minus beta. This is vertex C, right? This is vertex C. So this distance from y equal to x is given 3 by root 2, right? Right? Is it clear, guys? See, y equal to, because y and x are equal here. So distance of C, bisector of the acute, sum of possible is beta. This is root 2. So find it. What is it? Y minus x. So 1 minus beta divided by root 2 is equal to 3 by root 2. So this we can write that 2 beta minus 1 is equal to 3 or minus 3. So from here beta will be equal to 2 or this will be, right, 3 plus 1 4 by 2 2, or if it is minus 3 this is minus 1. So beta can be 2 or minus 1, right? What is the answer? Neither of these two. What I've seen here, sum of us. Okay, they are asking sum of possible values, guys. So 2 plus minus 1, answer will be 1. That is the answer. So without use of vector, it was pretty simple because vertices were known. So there was no need of vectors. See, this is also kind of a thing which you should learn. It's not always about like going into this triangle rule, finding bisectors. Finding bisector is a tedious job in vectors. Okay, but if we have vertices known of the triangle, it's nothing. So this approach should be also clear to you. Okay, moving to next question. Okay, next part, which is scalar product. You see, scalar product or also dot product. So suppose there is a vector A and there is a vector B, and let's say the angle between them is theta. So what do we say? That A dot B vector is equal to mod of A into mod of B cos theta. This A dot B is called dot product or scalar product, where theta is the angle between vectors. What we have to keep in mind, that this theta is taken when they are co-initial or coterminous. It's very important. See here, angle between A and B. Here angle between A and B is theta. But if I draw a new diagram, suppose if I draw a diagram here, suppose we have this is vector A and this is vector B, and this is theta. This is theta. Now here angle between A and B is not theta. Remember, when we take angle between two vectors, it is always tail to tail or head to head. So here we have to shift, we have to translate this vector A. We have to translate this vector A. So this is vector B and we'll translate vector A. So A has been translated now so that they can be co-initial. So if this was given theta, what is this angle? Pi minus theta. So the actual angle between A and B here, A and B here will be pi minus theta, right? And what is the range of theta? Theta can be from 0 to pi. The range of theta can be between 0 to pi. This is the range of theta. You can consider theta between 0 to pi. So if someone asks that what is A dot B maximum? So if this is maximum, cos theta has to be at max, which is equal to 1. So it will be equal to mod of A into mod of B. And if you have to find minima, so A dot B minima will be equal to minus of mod of A into mod of B. Right? So all these informations are important related to dot product. Okay. Now in dot product, there is one important logic of projection and component. Okay. So let's say this is vector A here and this is vector B. Drop a perpendicular. So this is O, A, B, and let it be M. So this OM length is what? Projection of OB on OA. Okay, this length OM, right? This length OM is projection of B on A. This is projection of vector B on vector A, right? This OM length is projection of B on A. When we say projection, it means length, right? When we say component, it's vector quantity. So projection, how to calculate this length OM? It's quite easy. This is theta. We just have done. You see, what is OM? OM, can we say that this will be B mod of B into cos theta? Can I say that? Mod of B into cos theta, right? OM will be mod of B cos theta. So this OM will be equal to mod of B times cos theta. And what is cos theta? You see, what is cos theta? From here, can I say that if A and B cos theta, so cos theta here is what? Cos theta is A dot B divided by mod of A into mod of B, right? This is cos theta. If we have to find out angle between two vectors, we can go for this formula, A dot B divided by mod of A into mod of B, right? So what is it here? OM will be mod of B cos theta, and cos theta is what? Cos theta is A dot B divided by mod of A into mod of B. So this will cancel out, and you have A dot B by mod of B, which makes it, wait a minute, this is A dot B, this A dot B upon mod of A, right? Or we can write B dot A upon mod of A, which is B dot A cap. So that's all. This is what you need to remember. Projection of B on A B dot A cap. So if it is projection of, let's say if you find projection of A on B, so this will be the length, right? So suppose this is length n. So if you write projection of A on B, right, which is length vector on, right, that is length vector on, which is equal to A dot B cap, right? So you just relate it with the sound of on. A on B, A dot B cap, B on A, B dot A cap. And what is the projection? It's the length that we are talking about. Then there is one more thing called component. Now see, what is this OM vector? So this vector OM is component of vector B along A. We can say that. What is, if I make it a vector? So can I say that OM vector is component of B along vector A? So magnitude is known. We just need to give its direction. So can we say that is will be equal to magnitude of OM into what is the direction? Why, guys, what is the direction? Direction is given by unit vector A cap, right? OM vector will be magnitude is OM. What is the direction? It's in the direction of A. So it is A cap. So what is it? OM A cap, OM vector, A cap vector. What is OM? What is mode of OM? Mode of OM we already know. It is OM is projection of B on A. So it is B dot A cap multiplied by unit vector A. So this is projection of B along A. So this is component of B along A. Now if I want this vector, MB vector. Now what is this MB vector? Now MB vector is component of B perpendicular to A. I think it's very easy to visualize that this MB vector here, right here, guys. This MB vector is the component of B which is perpendicular to vector A. So by triangle rule, we can easily figure out that OM plus MB is equal to OB, right, in this triangle. Do you see? OM plus MB will be equal to ON. OM plus MB will be equal to vector OB. Do you see this? OM, MB, OB. And OB, everything is known. So what is that vector, guys? That MB, which is the component. So MB will be equal to OB vector is B vector, and OM vector we already have calculated. So B dot A cap multiplied by A cap. That's it. Right? So you don't need to mug up, because it's very easy to write. If you are able to understand the diagram, if you are able to draw that triangle, it's not a tough task to remember this result. Okay, I hope you have understood it. So from projection component, what do you need to know? The formula, guys. The formula first. If it is projection, it's talking about length. When you talk about component, we are talking about the vector quantity. So projection, in projection, what is the important part? The sound on. A on B, A dot B cap. B on A, B dot A cap. Clear? Okay. So what all just we have done in vector product, that A dot B is mod of A, mod of B cos theta is A dot B. This is how we find out angle between vectors. Let's see few more things in the properties, guys. Properties of dot product. So first thing, suppose if vector A is xi cap, yj cap, zk cap, and some vector B is, let's say, x1i cap, y1j cap, z1k cap. Very sasta information. You already have this idea that A dot B. What is A dot B? It is equal to xx1 plus yy1 plus zzz1. Right? Because when you take dot, I dot j, I dot k will be 0, because the angle between I and j is 90, I and k is 90. So this is how we give A dot B. Second thing, that if we have some constant multiplied, like lambda A dot B, or this is equal to lambda vector A dot B vector, or lambda B vector dot A vector, all of these are equal to what? Lambda times A dot B. Just keep that lambda outside, is the same thing, right? We already have written it here, so you can write it as something like this: A dot lambda B. So A dot lambda B or lambda A dot B or lambda B dot A, it's all of these are equivalent to A dot B. The constant can be always taken outside. Third thing is if we have vector chi square. So vector chi square is nothing but dot with the same vector. So A dot A will be what? Mod of A, cos 0 is 1. So it will be what? See, here it is not mod. When I say that I am squaring a vector, right, is a very important property. When I say that I am squaring a vector, so vector chi square will be equal to dot with the same vector. Now that will convert into modulus chi square. And this is one thing which differentiates between complex quantity and vector quantity, right? In complex also we keep talking about direction. In complex what happens? If you square a complex, it is not a mandatory thing that it will be converted into a real number or some constant value. Here, if you square a vector, it is going to be equal to square of its magnitude. Very important result. Okay, then the fourth property about vector which we should know is this, that when we use squaring a plus b square, so what is it? It will be a plus b dot a plus b. You see, dot you can treat like just a normal multiplication, right? The order will have no importance. A dot b or b dot a, it's same thing. So what is it? It will be a dot a, then a dot b, then b dot a plus b dot b. So what is it? This is mod of a square plus mod of b square and plus 2 a dot b. That's all. So we can say that mod of a plus b is equal to under root of mod of a square mod of b square plus twice of a dot b. Very, very important result. Okay, and this result we are going to see so many number of times, especially if we have any problem related to mod of some addition, subtraction, it's always squaring. Most of the times it's squaring. If it is mod of a minus b, then there will be only one change. It will be square root of mod of a square mod of b square minus twice of a dot b. Okay, so remember these results. Now from all these properties, what I want you to remember most is this, these two we are going to utilize so many number of times, we don't have any idea. So one thing, like suppose if cos theta, the angle between vectors, if we have to find out angle between vectors. So angle between vectors, if you want to find out, this dot product will help. What is this cos theta? Suppose vector A is x1 I cap plus y1 j cap plus z1 k cap. Some vector B is x2 I cap plus y2 j cap plus z2 k cap. So if this is given, so angle between these two will be cos theta will be a dot b divided by mod of a into mod of b, which is equal to x1 x2 plus y1 y2 plus z1 z2 divided by root over x1 square y1 square z1 square into x2 square y2 square z2 square. This is the angle between vectors. Easy to understand, right? Very, very simple to understand. Also from here we can say if A is perpendicular to B, so in that case cos theta will be 0, numerator will be 0, like x1 x2 y1 y2 and z1 z2 will be equal to 0. And if vectors are parallel, if A is parallel to B, if vectors A and B are collinear, we already have seen this case, then coefficient will be in proportion. So x1 by x2 will be equal to y1 by y2 is equal to z1 by z2. Okay. So in properties of scalar, scalar or dot product, this one I want you to specially practice these two, because you see now I am going to show you the PYQs, how numerous PYQs are going to be solved with help of this property. Okay, so I think now we'll use, let's start with the problem. What is it here? A and B two vectors such that this 2a vector 3b vector is equal to 3a vector plus b vector, and the angle between A and B is 6 degree. If 1 by 8 into A is unit vector, then mod of vector B is equal to. Okay, so let's calculate it. Now see, what did I tell you? Whenever you have this combination given in addition or subtraction, don't hesitate, just square. square it. Just square both the sides. So in the given relation, if I square both sides, what is it? 2a vector plus 3b vector is equal to 3a vector plus b vector. So if I square both the sides, so I know what is it? What is vector chi square? So 2a. So 4 into mod a square plus 9 into mod b square plus 2 to 4, 4 3 12, a dot b is equal to 9 mod of a square plus mod of b square and plus 6 a dot b. Right? What is being said? Angle between a and b is also given. We just have to find out mod of b. A and b be two vectors, is that angle between a and b is 60. Okay, so angle between a and b is 60. So what is a dot b? A dot b will be equal to mod of a mod of b into cos 60 degree. Right? Mod of a, yeah. So this is equal to how much now? So from here we will get some relation. You see, 9 minus 4, 5 times mod a square. This is minus, we take it this side, 8 times mod b square and minus, this is 6 minus 12, a dot b vector is equal to 0. Now a dot b we can find it from here. What is it? This cos 60 is 1 by 2. There is mod of a into mod of b divided by 2. Right? A dot b, the angle between is 60 degree. So we can use that. We can use it here. We can use it here. What is it? A dot b. What is it? And also guys, 1 by 8 into a is unit vector. So that means from here can we say that mod of a should be equal to 8. Right? This is sufficient to tell 1 by 8 into vector a is unit. So mod of a should be equal to 8. So just put it a here, a equal to 8. So 5 into 8 square, 64 minus 8 into mod b square and minus a dot b. So mod of a is 8, so 4b. So 4 mod of b is equal to 0. So I think if you satisfy with the options, it will satisfy. So 6 into 4. So if you check with 5, so this is 5 into 4, 20, and this is 320. What about these? What about these? B square, b is 5. So 25 into 8 will be how much? 200. And this is b. So it is only 220. Mod of a is 8. Is there any calculation error, guys? Mod of a 2a plus 3b. So 4a square 9b square, this is 12ab. This is 9a square plus b square plus 6ab. So this is 5a square minus 8b square minus, okay, this is 6 guys, this is 6. Here 6 was missing. 6 was missing. So 6 into 4, this will be 24. Right, now it is correct. This 320 minus 320 is 0. So this 5 is satisfying. Correct? Yes, this is 6ab, right? This 6ab minus 12ab, it will be this equal to 0. Clear? So very easy problem. Now again, see, this is the logic which you will see the use of this on repeat mode. The squaring part. This is what I want you to learn most out of this vector product problems. Most of the time, the questions can be solved by squaring. Right? By squaring, you will generate some relation between dot and the mod of vector. You will be able to solve it. Clear? Just blindly do it, guys. You will see something happening. Okay, next one. So the projection of the vector on the sum of the two vectors, right, is 1. Okay. Sum of the two vectors. So 2i, right question, 2i plus 4j cap minus 5k cap and plus minus lambda I cap plus 2j cap plus 3k cap. So what is it? So 2 minus lambda I cap plus 6j cap minus 2k cap, right? So we want projection of this vector on this vector, projection of this on this. Okay, we want projection on, right? I think you can relate with the sound on, projection on these vectors, right? So it will be dot of these two. So 2 minus lambda, then 2 plus 6, 2 into 6, 12, and then k minus 2 minus 2. A dot b divide by mod of b. So mod of this, what is that? 6 square 36 plus 4 plus 2 minus lambda square is equal to 1. You see it's given, it's 1. You just need to solve this relation here. What is it? 12 minus 2, 10. 10 plus 2, 12. So 12 minus lambda is equal to, let's square both the sides. So 36 plus 4 plus lambda square minus 4 lambda. So 12 minus lambda square, if you expand it, guys, what is it? 144 plus lambda square and minus 24 lambda is equal to 36, 4, 40, 44. 44 plus lambda square minus 4 lambda. 44, no, not that 44. Calculation is very bad. Which is going to cancel out? Lambda square will cancel out. So 144 minus 44, 100 is equal to 20 lambda. From here we get lambda equal to 5. This is the answer. Direct problem, guys. You see these type of questions have been there so many. Like, see, I have taken only one variety here, but such type of questions there were so many in the paper, and you can see the level. It's just the formula a dot b cap. That's all. Next one. So if a plus 3b is a perpendicular to 7 minus, again this vector sign. So a plus 3b is perpendicular to 7a minus 5b, and a minus 4b perpendicular to 7 minus 2b. And the angle between vector a and the angle between vector a and b in degrees. A plus 3b is perpendicular to this. So let's write the relations. So a plus 3b dot 7a vector minus 5b vector will be 0, right? A plus 3b is perpendicular to 7a minus 5b. So what is it? So it is 7 times mod a square. Then this is minus 15 times mod b square. Then this is 5ab, 21ab, right? A dot b. So minus 5a dot b and plus 21. So it will be plus 16 a dot b will be 0. So we get one relation from here. Okay. Then 7a minus 2b, a minus 4b. A minus 4b is perpendicular to 7a minus 2b. So this dot is also 0. This dot is also 0. We have to find out the angle between a and b. Okay. So this dot is also 0. So what is that? 7a. So 7 mod of a square. Right? 7 mod of a square. Then b will be plus 8 mod of b square. And also, what is it? Minus 2ab, 28. So minus 30. 30a dot b is 0. This is equation number 2. I hope, guys, the equation which I am framed is correct. Minus 2a dot b, 7 into 4, 28. Right? We have got two equations. I want angle between a and b. Right? I need to have angle between a and b. So first of all, can we derive some relation between some relation? Okay. So if I want angle between a and b, certainly only one thing that needs to be done here. We need to find out relation between mod of a and mod of b. That's all. We need to get some relation between a and mod of a and mod of b. So this is 16, this is 30. So from these two I can definitely get relation between a and b, right? So in this one, in the second one, okay, or in the first one, 7 mod of a square minus 15 mod of b square plus 16. Now a dot b, I am going to replace value here. What is a dot b, guys? It is 7 mod a square plus 8 mod b square and divide by 30 is equal to 0. Right? I got a dot b from here and I have substituted it in this equation. Right? What is it? 7 mod of a square, 8 mod b square, and then by 30. So here I'll get some relation between a and b. A mod of a and mod of b. So what is it? 2 into 8, 16, 15. Is there any further calculation possible? I don't think so. So 15 into 7. That is 105 mod of a square minus 15 to 15. So it is 225 mod of b square, then plus 56 mod of a square and plus 64 mod of b square is equal to 0. So clearly we have some relation between a and b. So 105 and 56, that is 161 mod of a square is equal to now 225 and 64. So 54, I think, what is that? That is also 161. 161 mod of b square. You see, this is the game, right? 415 and 6612, 12. That's all. So this 161 will cancel out, and clearly we have mod of a equal to mod of b. Okay, so now that we have mod of a and mod of b equal, we can use this relation in this or in this also. So 7, let's say this is equal to something k. Let's say this is equal to k. So k 7k square minus 15k square and plus this is 16 a dot b. So mod of a is k, mod of b is k. So 16k square into cos theta. 16k square into cos theta is 0. So what is cos theta then? Cos theta is coming out to be how much, guys? This is 7 minus 15 minus 8, 1 by 2. Cos theta comes out as 1 by 2. Fantastic. So theta is 60 degree. Understood? This is something better, right? Not that great, but still better than the other problems that we have done. Right here we have to understand that we need to get relation between mod of a and mod of b. Our job will be over. Clear, guys? So I hope you have understood this. Okay. Move to the next one. So let A, B, C be three mutually perpendicular vectors of the same magnitude and equally inclined at an angle theta with the vectors A plus B plus C. Then 36 cos square 2 theta is equal to. Okay. So this vector ABC, this is equally inclined. Now what exactly that mean? Equally inclined. So can I say that cos theta is equal to A dot A plus B plus C divided by mod of A into mod of B A plus B plus C, right? This is what it means. Cos theta, which is angle between these. So now see, this is equal to B dot A plus B plus C divided by mod of B into mod of A plus B plus C, right? This is given, and their magnitude is also equal. Their magnitude is also equal. So what do you see from here? What do you see from here? The magnitude is also equal, guys. So this is P dot A plus B plus C divided by mod of C into mod of A plus B plus C. So these all are equal. These are mutually perpendicular vectors. Okay, and A dot B, B dot C, these are mutually perpendicular vectors. A dot B, B dot C, A dot C, all these things are 0. So we are going to take help of what? We are going to take help of vector A plus B plus C. How do we take that help? How we are going to take help of that? You see here, what is cos theta being equal to? You see, this is mod of A square. A dot B, A dot C is 0. So mod of A square by mod of A. So we have to figure out how this A plus B plus C ka magnitude. So this A plus B plus C square, this will be equal to mod of A square, mod of B square, mod of C square. If you have not remembered this as a formula, you should be remembering now. Twice of A dot B plus B dot C plus A dot C. If this was not written before, remember this as a result. So all three are equal, right? It's already given that mod of A, mod of B, mod of C are equal. Mod of A, mod of B, mod of C are equal. So here what is happening then? This is equal to what? Mod of A square, mod of B square, mod of C square. This will be 0. So it is 3 times mod of A square. So can I say that A plus B plus C, the magnitude is only root 3 times mod of A. Now I'm going to use this result. And where? Here. See what is cos theta now. So cos theta will be A dot A will be mod A square, A dot B and A dot C will be equal to 0. So in the numerator it will be only mod of A square divided by this mod of A, and what is A plus B plus C? It is A plus B plus C is what? Root 3 times mod of A. So guys, you see, this gets cancelled out. This is coming out to be 1 upon root 3. So cos theta comes out 1 by root 3. What do we want? 36 cos square theta. 36, what is cos square 2 theta? Cos square 2 theta will be, what? This is cos square theta or 2 theta, guys? 36 cos square 2 theta. So fine. If it is cos square 2 theta, we know that cos square 2 theta is, we can write it as cos square theta minus sin square theta whole square. So cos square theta is how much? Cos square theta will be 1 by 3 minus, what will be sin square theta? If cos theta is 1 by 3, 1 by root 3, what will be sin square theta? Or sorry, we can write it as, why do we need sin, guys? Why do we need cos and sin both? Even though we can find out, it's cos 2 theta is there, no? So cos 2 theta is 2 cos square theta minus 1 whole square. So 2 cos square theta will be how much? So 2 by 3. So 1 by 3 whole square. So 1 by 9. So this is 4. And that 4 is the answer. Clear? So in this question also you have seen the power of squaring. I squared this. See, initially when I wrote this, this was clear that I need to think of mod of A plus B plus C, because the rest were helpful. It was only up to mod of A plus B plus C to decide. When I calculated that by squaring, I got it by root 3 mod A, and from there we got the angle. Clear? Hoping that you must have understood something. In fact, everything, guys, this was not difficult. Okay, so for P positive, vector V2 is obtained by rotating the vector V1 by an angle theta about origin in counterclockwise direction tan theta. So this question, I think I can leave it up to you. Obviously, they are not talking about modulus, so mod of V2 and mod of V1 is going to be equal, right? And angle between vectors, then you can find out, right? V2 is V1 is equal, so we have 4 plus P plus 1 square is equal to V1 is root 3 P pi square plus 1. So 1. So from here, you can find out P, and it's given that P positive. So if we have some extra P, it will be eliminated. After that, you see, we can find out cos theta. We can find out, like from here, you see, this is 4 plus P square plus 2P plus 1 is equal to 3P square plus 1. So we have 2P square and minus 2P minus 4 equal to 0. So that is P square minus P minus 2 equal to 0. That is P minus 2 into P plus 1 equal to 0. So guys, P will be equal to 2 because P is positive. So the moment we got P equal to 2, you see, so V2 and V1. So V1 vector, right? V1 vector will be root 3 P. P is 2. So 2 root 3 I cap plus j cap. And what is V2 vector? V2 vector is 2 I cap plus P plus 1. So root 3 plus 1 j cap. Right. After that, it is the use of dot product. Right. The angle theta, you see, what is cos theta? Cos theta will be V1 dot V2 divided by their magnitude. So you can find out cos theta now, guys, very easily, because everything is known. Everything is known to you. So you can find out cos theta, and from cos theta you can find out tan theta. So do it on your own. From cos you find out tan, and then you compare it. So this is going to be calculative but not difficult. Don't term this question as difficult. Slightly calculative. You okay? Oh, in triangle ABC, side BC, let's draw the triangle. ABC. Okay. In triangle ABC, mod BC is 3, mod C is 5, mod B is 7. In the projection of the vector BA on BC, you see, BA on BC, right? BA on BC. Projection, we need BA on BC. What is that? BA dot BC cap, right? So that is BA mod of BA mod of BC cos theta, like BA dot BC, divide by modulus of what? BC. That is mod of B into cos theta. Correct? Mod of BA into cos theta, which is nothing, right? Which is nothing. Mod of B into cos theta, where theta is the angle between these two, B and BC. So, mod of B is how much? It's 7. Now, to find out cos theta, you can simply use cosine formula. That's all. What is cos theta? Cos theta is 3 square. Cosine formula, minus 3 square, 7 square, minus 5 square, divide by 2 into 3 into 7. That's all. So, cancel it out. So, what is it? This is equal to 7 square, 49. 49 plus 9, 49 here, right? And plus 9, 58. 58 minus 25, what is that? 58 minus 25. So, that will be 58 minus 25. This is how much? 33 by 6. So, this will be 11. This comes out as 11 by 2. This comes out as 11 by 2, and that is the answer. Right. Quite easy. The data was framed very easily, and obviously even vectors also, like when you are doing this in even in boards, cosine formula is being proved in by vector logic. So I think this formula should strike definitely. Okay. Vector is not only about vector concepts, guys. This you should understand. Let the vectors A, B, C be such that mod of A is mod of B, mod of C. Okay. Mod of A is 2, mod of B is 4, mod of C is 4. If the projection of B on A is equal to the projection of vector B, they have skipped vector sign. Vector B on vector A is equal to the projection of C on A, and vector B is perpendicular to vector C. Then the value of A plus B minus C is okay. Mod of A is 4. If the projection of B on A, so B dot A cap is equal to projection of C on A to C dot A cap, and B is perpendicular to C. B is perpendicular to C. So B dot C is 0. Right? B dot C is 0. So if you expand it, you see, guys, this is what? Mod of B, mod of B, mod of A into the angle between these two. Right? What is that? Let's say cos theta 1 divide by mod of A is equal to C dot A cap. So mod of C, mod of A, cos theta 2 divided by mod of A. So we have mod of B and mod of C also known. Mod of B and mod of C, these two are equal. Guys, mod of B and mod of C are equal. So we have angles equal. Cos theta 1 equal to cos theta 2. Right? The angle between B and A and C and A. The angle between BA and CA are equal. Okay. The angle between BA and CA are equal. Fine. So if I square it here, what is A plus B minus C square? It will be mod of A square, mod of B square, mod of C square. Then it will be plus 2A dot B minus 2 B dot C minus 2A dot C. This will be the result. Minus 2 B dot C minus 2 A dot C equal to mod of A square. Now mod of A square, A is known 4. Mod of B square, what is B? 16. This is 16. 2AB, 2BC. Now see, B and C are perpendicular. So this will be gone. A dot B, A dot C. Since AB and AC have equal angles, so this is what? Mod of A. You see, mod of B and mod of C are what? Mod of B and mod of C are equal. So what is will be this? This 2A dot B cap, A dot B, A dot C. These two will also cancel out. These two. Why? Because they have equal angle. Mod of A, mod of B cos theta. Mod of A, mod of C cos theta. Mod of B, mod of C are equal. Cos theta is equal. It will cancel out. And this is already 0 because B is perpendicular to C. So only this is remaining. Guys, that's all. Khatam. So what is mod of A plus B minus C? Square root of 36. 6 is your answer. So one more question where we have used the power of squaring, and this will be used. If it is about modulus, no, I'll use it. Okay. If A and B are unit vectors, if A and B are unit vectors, then the greatest value of root 3 mod of A plus B minus B. So guys, see, if A and B are unit vectors, so what will be mod of A plus B? Mod of A plus mod of B will be under root of mod of A square, mod of B square 2A dot B. So that is 2 cos theta. That is twice of 1 plus cos theta. What is that? 1 plus cos theta is 2 cos square theta by 2. So it will be 2 cos theta by 2. Correct? Using the formula, right? And what will be mod of A minus B? It will be equal to 2 sin theta by 2. Because here it will be 1 minus cos theta, and 1 minus cos theta is 2 sin square theta by 2. So from here we'll get it. So the expression here, f theta is equal to root 3 times 2 root 3 times, right? Take 2 out. So root 3 cos theta by 2 plus sin theta by 2. And what do we need? We need greatest value. So we know that A cos theta plus B sin theta, root under A square plus B square is the maximum. So what is f theta maximum? Twice of root under A square plus B square. That is what? 2 into 2. 4 is their answer. It's not given. 4 is the answer. Clear? Quite easy, quite easy. Only these two. In fact, you can remember also, guys. See, this result you will see in multiple times. You can remember this is standard thing. Mod of A plus B is 2 cos theta by 2 if A and B are unit vectors. And if it is A minus B, 2 sin theta by 2. Okay, guys. So let's start with vector product now. So suppose we have been given with vector A and B. So A cross B is given by mod of A into mod of B into sin theta, then n vector, where n vector is the unit vector. This is unit vector which is perpendicular to the plane which is containing vector A and B. Right? This is just to give the direction. This n cap is there to give the direction to this value. Right? Like here, this is the magnitude. What is magnitude of A cross B? Magnitude of A cross B is mod of A mod of B into sin theta. This is the magnitude. The job of n cap is give it the direction. Now direction is extremely important in case of A cross B. You see, when we were dealing with A dot B, that was a scalar value. So you write A dot B or B dot A, it doesn't matter. But here it does matter. Suppose this vector B and this vector A. The direction is given by right hand thumb rule. Like this is A. So you move from vector A to vector B. The order in which cross is written, A cross B. So move A to B. That will be the direction. So from A to B, this is theta. So A to B, you move it there. This will be the direction of A cross B. This is direction of A cross B. So this n cap is a unit vector in direction of this A cross B. N cap is unit vector in the direction of A cross B. If it is A cross B, and you see this will be B cross A, right? Because then we'll move from B to A. So if you go B to A, it will be downwards. It will be pointing downwards. So you can clearly see this vector here is perpendicular to the both, right? This A cross B. This very important point to understand that A cross B is a vector which is perpendicular. It's perpendicular to A and B both. So whenever in the problems this something like this is mentioned, let's find a vector which is perpendicular to two given vectors, which is perpendicular to given two vectors. So it is definitely cross of it. Definitely it is cross of it. Okay. Order is also important. So here A cross B and B cross B are completely different thing. So A cross B is equal to negative of B cross A. Right, these 2 points. What is unit vector? Unit vector which is perpendicular to the plane. Right, unit vector. Unit vector is the third thing which you should know. Unit vector which is perpendicular to plane of AB. Perpendicular to the plane of A and B. A and B. Now see, we want unit vector which is perpendicular to the plane of AB. So it could be A cross B or B cross A. That is why I'm writing it plus minus A cross B. This is A cross B divided by mod of A cross B. Right? A cross B divided by modulus of A cross B. That will be the unit vector which is perpendicular to the plane of A and B. Clear? Right? So let's see some more properties about it. You see A cross B. In A cross B. So if you write A cross A, obviously it will be 0. A cross A will be 0. One thing you can see that A dot B whole square plus mod of A cross B whole square will be equal to mod of A square into mod of B square. Like this is also an identity which you should know. And it's quite easy to prove, guys. A dot B will be mod of B sine theta. Mod of A cross B is mod of B sine theta. Sorry, A dot B is A of B cos theta, sine theta, cos square plus sine square 1. This will remain. So this is very important. You have to remember it. So A dot B square, A cross B square is equal to this. Then anything else, the constant part, right? If there is any constant, suppose M is a constant value. So M times A cross B, this will be equal to M A cross B is equal to A cross MB. Just mind it one thing, that the A and B are in the same direction. You are not changing the order. A cross B cross A will be completely two different things. So that you should keep in mind. So anything else which is important for cross? I think A cross B. So these are very basic. These are very basic results about it. So the geometrical application of vector product, that is something, the results are the something which we should know of. Starting with this, the area of triangle. Area of triangle. Okay. So suppose we have this. Okay. Or let's say area of quadrilateral first. Area of parallelogram. Let's start with area of parallelogram. Parallelogram. Area of parallelogram. So okay, so these are known thing. Okay, we have adjacent sides A and B, and this is theta, right? You can start with triangle or parallelogram, doesn't matter. But some of you are like, sir, why parallelogram first? Okay, do one thing. Let's write area of triangle first. No load in life. I wrote triangle first, so I'll write area of triangle. Let's write it here. Okay, so suppose we have a triangle. We have a triangle and the adjacent sides are vector A, vector B, this is theta, right? So we have adjacent sides and angle between them known. Now we know that area of a triangle delta, what is delta? Delta is half by cosine for like the area of triangle using sine formula. What is that? It's half mod of A, mod of B into sine theta, correct? This is the area of a triangle, mod of A, mod of B sine theta, and this we can write in form of cross product. What is it? Half of modulus of A cross B. What is that? That's all. This is the area of triangle. This area of this triangle is equal to half of modulus of A cross B. So now if it is parallelogram, guys, if it is area of parallelogram with adjacent sides A and B, suppose this is side A, this is side B. So obviously there will be two such triangles which will have equal area. So what is the area here? This area will be equal to mod of A cross B only. Mod of A cross B. This area will be equal to mod of A cross B. Clear? Now if we have any random quadrilateral, okay, if we have any random quadrilateral with diagonals known, suppose this is D1 and this is the other diagonal D2. Let it be any random quadrilateral for any quadrilateral. If diagonals are known, if we have the information about diagonals, so area will be equal to half of modulus of D1 cross D2. This is it. Area is equal to half D1 cross D2. And if it is a triangle with position vectors for each vertex known. Suppose this is A with position vector A, B with position B, and C with position C. So when you do AB cross BC, so this is the formula which we'll get. This area here, area will be equal to half of mod of A cross B plus B cross C plus C cross A. That will be the area. A cross B, B cross C, C cross A. It basically what happens that you write no that BA cross BC. You'll write BA cross BC. So B minus C cross B minus A. Right? You do B minus C cross B minus A. B minus A. So what is it? B cross B 0. Then minus B cross A will be A cross B. Then this minus C cross B will be plus B cross C. And then this will be plus C cross A. That is the formula. And half is there. Okay, so we have this area formula in terms of this also. And when this thing is given 0, that means we have collinear points. ABC will be on a single line, there will be collinear vectors. Okay, so before we go for these things, I think you should know already that if we have like vector A, x1 I cap plus y1 j cap plus z1 k cap, and there is a vector B which is x2 I cap, y2 j cap, z2 k cap, then I hope you know how to calculate. Obviously A cross B will be equal to determinant of I j k. This is x1 y1 z1 x2 y2 z2. This is how we calculate A cross B. Is that clear? So I hope you are already well known with all these, especially these area results are important, guys. If you are good with all these area results, you are good to go. Okay, moving on with the problems. The first question here, P is given, Q is given, be two vectors. If a vector R is perpendicular to each of the vectors P plus Q and P minus Q, right? So the vector is perpendicular to P plus Q and P minus Q also. So now remember, guys, one thing. This you will see very soon, that if P and Q vectors are in the same plane, then can I say that P plus Q and P minus Q will be also in the same plane, right? This P plus Q and somewhere here P minus Q, correct? So P and Q are on the same plane, then P plus Q, P minus Q are on the same plane. So if I want a vector which is perpendicular to them, so P cross Q is going to be perpendicular to all of those vectors. Either is P, Q, P plus Q or P minus Q, correct? Right? Is that clear? So what is that vector? What is that vector? What is the vector? So I'll find P cross Q first. So that is I, J, K. Then this is 2, 3, 1. And then 1, 2, 1. So it is I cap. This is 3 minus 2, 1. Minus J cap. 2 minus 1, 1. Plus K cap. 4 minus 3, 1. So this is I cap minus J cap plus K cap. Now this is P cross Q. Each of the vectors, and magnitude is given, guys. Magnitude is given R root 3, right? So if magnitude is known, so we know about the vector which is perpendicular to the plane now. So the required vector, let's say R vector is lambda times the unit part lambda by root 3 I minus J plus K, right? And from here lambda can be calculated as it's given that mod of R is how much? Root 3. Mod of R is root 3. So lambda has to be equal to how much? Lambda has to be equal to 3, right? Lambda has to be equal to how much? Mod of R is root 3. So if I take mod of R here, it will be how much, guys? Mod of R is root 3, no? So how much is this? This is root 3. This is also root 3. So this will be root 3. So lambda is also. So from here we can say that lambda is also how much? Root 3. Lambda is also root 3. So R is equal to only I cap minus J cap plus K cap. So what is being asked? Alpha. Then mod of alpha, mod of beta, mod of gamma. So 1 plus 1 plus 1. The 3 will be the answer. Quite simple. And what is the funda that we had used? We have used that P and Q are, if they are forming a plane, obviously two vectors will form a plane. Then P plus Q, P minus Q will be on the same plane. So instead of finding P plus Q cross P minus Q, just find out P cross Q. It's the same thing because that vector is perpendicular to all four of them, right? So then you adjust the magnitude and the game is over. A, B, C is a vector such that A dot C. A dot C is mod of C. and see A vector. Again, they have missed vector sign everywhere. A, B, A dot C is equal to mod of C. C minus is equal to root 2, right? And the angle between A cross B and C is pi by 6. So A cross B cross C is equal to. So what is that? Let's calculate. So A cross B and C angle is given. So this will be equal to mod of A cross B into mod of C into sine pi by 6, right? Sine pi. The angle between them is, the angle between A cross B and C is pi by 6. So this, it is about modulus. Unit vector is not required. It is pi by 6. What else is known? Mod of C. Mod of C is not there. Mod of A cross B, we have only A cross B here. Like we can find out A cross B pretty easily, right? So you can see one thing, guys. You can see one thing. If I find out A cross B, it is fine. Mod of C. Now you see here, if I square both the sides, mod of C minus A is given 2 root 2. If I square both the side, mod of C square, mod of A square minus 2A dot C is equal to 8. A dot C is given equal to mod of C. A dot C is given equal to mod of C. So mod of A is known, right? What is mod of A here? Mod of A is 44893. So mod of A is 3. So mod of C square plus mod of A square will be 9 minus 2 mod A dot C is mod C is equal to 8. So we have mod of C square minus 2 mod of C and plus 1 equal to 0. How beautifully they have framed it. You see, we have got mod of C equal to 1 because this is a perfect square. So we got mod of C also. Now everything is known. A cross B we can calculate. A cross B. What is A cross, right? Now it's up to you. A cross B you can calculate. Mod of C we have got 1. So sine pi by 6. So now you can calculate. Your final answer is up to you. You can calculate on your own. Understood? A cross B ka mod you can calculate now because vector A and vector B is there. So everything can be calculated very easily. Understood? Let's solve next one. So it was only the use of this which helped us to find out magnitude of C. Okay. So what is here? Mod of A is 2, mod of B is 5. A cross B is 8. Now direct formula. Direct formula, guys. A cross B. Again they have missed vectors. What to do, guys? They have missed vectors. So A cross B. What is the formula? A cross B square, A dot B square is equal to mod of A square, mod of B square. That's all. Just substitute the values. So A cross B is how much? 8. So 64 plus A dot B is how much? It's required. So let's say this is X. X square is equal to mod of A square, mod of B square. So 21 into 4, 100. So X will be equal to 6 or minus 6. 6 is the answer. Moving on. Let A and B be two non-zero vectors perpendicular to each other, right? A dot B is 0. This is the first info. A dot B is 0. And mod of A is equal to mod of B. Very fine. So mod of A cross B is also A. Again, there is no vector sign. So mod of A is equal to mod of B. If A cross B is equal to vector A, then the angle between the vectors A plus B plus A cross B and A is equal to, right? So it looks lengthy. Let's see. Mod of A, mod of B is given equal, right? We want the angle between the vectors A plus B and A cross B, and A is equal to. Okay. Okay. And A and B are given. What is next? A cross B is also equal to mod of A. Now what exactly that mean? Mod of A cross B is given at mod of A cross B is also is equal to mod of A. Now see, angle between A and B is given that A dot B is 0, so A is perpendicular to B, right? So if you expand this A cross B, you will write mod of B sine theta. You will write mod of A, mod of B sine theta, it will be sine pi by 2 is equal to mod of A. So congratulations, we got mod of B equal to 1. We got mod of B equal to 1. So mod of B, mod A are equal. So mod of A is also equal to 1. Fine. But this is not we are interested in. We want angle between. We want the angle between the vectors this and A. So what is cos theta? Let's use cos theta here. So cos theta will be equal to is A dot. A dot A plus B plus A cross B, right? Divide by A dot plus B plus A cross B and divide by mod of A and mod of A plus B plus A cross B, right? Again, you are terrified that, sir, how to solve this? Is very easy. It's very easy. See, A dot A cross B, this will be 0 because see, A cross B. Now A cross, if this is A and this is B, obviously A cross B will be out of the plane and perpendicular to both. So A dot A cross B will be 0. A dot A cross B, this will be 0. So we have to solve only this. A dot A is mod of A square. A dot B is 0. Divide by, this is mod of A into, now everything is up to this, mod of this, right? So treat it like this. This is vector P and this is vector Q. P is A plus B, so let me solve it here. Okay, so P is A plus B, Q is A cross B. So I need mod of P plus Q. So what will be mod of P plus Q? It will be under root of mod of P square, mod of Q square, and twice of P dot Q, which is 0. P dot Q is 0 by A plus B dot A cross B. So A cross B is perpendicular to A as well as B both. So dot will be 0. A plus B dot A cross B. This is going to be 0 because A cross B is perpendicular to A as well as B also. So it is going to be 0. So this is equal to under root of. Now what is mod of P? Mod of P is what? About A plus B. So A plus B will be equal to how much? What is mod of A plus B? It is A and B if you calculate it. So it is under root of A square B square and those are equal to 1. So it is 2. This is 2 and that is also 1. So it is root 3. This is coming out to be root 3. Use that. So it is equal to this root 3. So everything is else is 1. So this comes out equal to 1 upon root 3 and that is the answer. So again the data was such that you might have felt some uneasiness while starting, but you see A cross B and A plus B, don't be terrified. A plus B and A cross B, A plus B, A cross B is perpendicular to A and B both. So the calculation is going to be easy and it was easy. Oh, okay, next question. So here we have vector A, vector B given, R cross A is equal to R. Again there is no vector sign. Life is very tough and these things make it tougher. So R dot and R dot. Okay. So vector A, B is given, R cross A is equal to R cross B. Now this type of expression, I've seen this at least 10 times in JEE main problems. R cross equal to R cross B because there is one information, important information hidden in them. What is that? When you write R cross A is equal to R cross B, it basically R cross A minus R cross B is 0. So I can take R common. So R cross A minus B 0. From here I want to tell you one thing, two things in fact. First thing, you can take common if order is same. Like here R is pre-cross, R is pre-cross. If it was B cross R, you could not have taken it common. We need to have same order. Either it is A cross R, B cross R, then R would have been taken from the post part. If R is in the pre part, it can be taken common like this. Now, cross of two vectors are 0 is a null vector. What does it mean? Where they are parallel vectors. So R is parallel with A minus B, or R vector and A minus B are collinear vectors, right? These two are collinear. So vector R should be something lambda times vector A minus B, correct? That's it. The game is over. And vector A and B is known. So, and one more thing is given to find out that value of lambda, right? So let's simplify it. So R equal to, now R equal to, what is A minus B? So A minus B, 2 minus 7. minus 5 I cap, minus 3 minus j, minus 4 j cap, plus 4 minus 6, plus 10 k cap, right? So this r equal to this, and r dot this is 0, right? So if I simplify that, what I get? What will I get? So lambda times minus 5 minus 4 plus 2 minus 8 10 equal to minus 3. So 8 5 13 minus 3, guys, we get lambda equal to 1. We get from here, you see, lambda we get equal to 1. Moment lambda is equal to 1, so r is equal to how much? R is equal to minus 5 I cap minus 4 j cap plus 10 k cap. This is r. So we have got r vector, so you can calculate this. We can solve next question now. Right, the important part in that problem was understanding the application of r cross a, r cross b. Okay, let's solve this. What is the question here? Let C be a vector perpendicular to the vectors a and b. So C is a vector which is perpendicular to both a plus b. So game is over. C be a vector which is perpendicular to the vectors a as well as b. Right? C dot a cross b. Okay. C is perpendicular to a cross b. So yeah, okay. So we can find out C very easily, right? C is given perpendicular to a cross b. So okay, that is what I was missing. That is why I was thinking there is something wrong. There is again not, there is vector sign is missing. Every time, guys, they have skipped vector. This will unnecessary will increase lecture length. Okay, fine now. So it's given that C is perpendicular to two vectors. So clearly that C will be something lambda times a cross b, right? So lambda times. So I, j, k. Find out what is a. 1 1 minus 1. What is b? 1 2 1. So lambda times I cap. This is 1 minus 2 3. Minus j cap. 1 plus 1 2. Plus k cap. This is 2 minus 1 1. So it is equal to lambda times 3 I cap minus 2 j cap plus k cap. We got vector C, right? There is one information about vector C given. What is that? C dot this is equal to 8. So utilize that. So C, so lambda times. Now 3 dot I cap. So that is 3 minus 2 k 3 is equal to 8. So from here, lambda is how much? 3 minus 2, 1, 4, lambda is 2. So we got vector C now. Vector C is equal to 6 I cap minus 4 j cap plus 2 k cap. So guys, we have got vector C, right? So C dot a cross b. So if you have to calculate that, now it can be done very easily. How to do that? You see C dot a cross b. So first of all, for now that we have not done STP, but we should know that this is scalar product, right? This C AB box is being asked. That STP, see, for some students who have no idea what is this box product, I'm about to teach. The next topic is this box product, STP, scalar triple product. We'll do that, okay? Have patience, we'll do that. Okay, but for now, but since this is a crash course, I assume most of you already know. What is this box of CAB? So C first. So 6 minus 4, 2. What is vector A? 1, 1 minus 1. And vector B? 1 2 1. So just calculate this, that will be your result. Here, let's solve next question. Okay, let A, B and C, again there is no vector sign. Let A, B and C be three unit vectors such that the sum of vectors is 0, lambda is equal to A dot B, B dot C, C dot A, and some vector D is A cross B, B cross C, C cross A. In the ordered pair, lambda comma T. Okay. A, B, C are what? They are unit vectors. Fine. So So A, B, C are unit vectors. So I think lambda is pretty easy to find out, because see, if A plus B plus C is 0, so I can say its square is also 0. A plus B plus C square is also 0. So if you square it, is equal to mod of A square, mod of B square, mod of C square plus twice of A dot B, B dot C, A dot C will be also 0. So this is how much? Since all are unit vectors given, that 3 unit vectors. So each of them will have magnitude 1. So from here we have A dot B, B dot C, C dot A is equal to minus 3 by 2. Right? So one of them we got very easily. It is minus 3 by 2. This is what? This was lambda. Right? Lambda is minus 3 by 2. Now let's solve the other part. The other part is about A cross B, B cross A, C cross A. Okay. Fine. A cross B, B cross A, C cross A. Fine. So A plus B plus C is 0, right? It's given that A plus B plus C is null. A plus B plus C is a null vector. So if I multiply here by B, right? I multiply, I take, sorry, not multiply. If I take cross with B, post cross, right? So it will be A cross B, then B cross B will be null, C cross B is equal to 0. So can I say from here that A cross B is equal to minus of C cross B, which is A cross B comes out equal to B cross C. So we have B cross C and A cross B equal, correct? B cross C and A cross B equal. Now, so we had taken with B. Now if I take cross with A again, right? In this, if I take cross with A again, and this time pre-cross, so A cross A plus A cross B plus A cross C will be null. So A cross A what? Right? Basically I have taken A cross with whole thing. So A cross A will be what? Again null. So A cross B is equal to how much? Minus of A cross C. And minus of A cross C ko we can write C cross A. So guys, did you observe that C cross A is also equal to A cross B? Can you observe? C cross A is also A cross B. B cross C is also A cross B. So here we can replace B cross C with A cross B and C cross A again with A cross B. So basically this D will be equal to 3 times A cross B. Again, there are no vector symbol here. Please don't mind. Got the point, right? It was not difficult, right? Not a single problem is there where we have to think, we have to stop and think. It's just like you see the question and you spot and you can start solving. There's nothing left to think. Okay. Alpha B for some real X. A cross B equal to R is possible if. So I'll tell you the logic, I will not solve. A cross B is R, okay? So what is A cross B? What is mod of A cross B? It is mod of A, mod of B into sine theta. Correct? So we have mod of A, mod of B, sine theta equal to R. So can we write from here that sine theta will be equal to R divided by mod of A, mod of B. Correct? And what else? What else? What else? So A is there, B is also known, right? So it is possible if, where is R? R has to be between minus, right? This R has to be from minus 1 to 1. So this R upon, since R is positive, right? This is mod value. So this R upon mod of A into mod of B has to be less than 1. So if you simplify it, you will have your answer. Right now you will be thinking that how to calculate X. Now see, they have said that X is any real value. So when you find out this sine theta, right? When you find out this sine theta, from there you will have X value, and then from there you can calculate this. Slightly lengthy, but it's manageable. Okay, moving on guys. This is less than equal to 1 also. Let A, B and C be vectors is that mod of, again there is no vector sign. So vector A, vector B and C be a vector such that mod of C minus A is 3 and mod of A cross B cross C is 3. And the angle between C and A cross B is known. So A dot C is equal to. So it's quite similar question, right? It's quite similar to what we had done previously. So like here, this is mod of A cross B, mod of C, and the angle between them is given. It's 30 degree, right? C cross A cross B. So this is a mod sine, so sine 30, right? Sine 30 will be 1 by 2 is equal to 3. So mod of A cross B into mod of C is equal to 6. This we have. So what is A dot C has been asked. So we have only information about mod of C minus A. So what is that? Mod of C minus A square will be equal to 9. Square it. Mod of C square, mod of A square minus 2A dot C is equal to 9. So we have mod of A cross B also, right? We can find out mod of A cross B. It's very simple to find out from there. Can we find out? Yeah, everything is known. No, we can find out A cross B. So A cross. I think the data is also the same problem. No, this is not the same problem, guys. Right. So see, A dot C is required. So mod of A is with us. This is mod of C square. What is mod of A square? Mod of A square is 3. So 339 minus 2. A dot C is equal to 9. This 9 will cancel out. So we have mod of C square is equal to twice of A dot C. So we need to figure out mod of C, and that is not a tough job. We can figure it from here. What is mod of A cross B? See, A cross B. What is A cross B? It's ijk 2 1 minus 2 and it's I plus j. So 1 1 0. We can figure out this is 0 minus minus plus 2. Right, 0 plus 2 minus j cap is 0 minus minus plus 2 and plus k cap, this is 2 minus 1 1. So this is 2i cap minus 2j cap plus k cap. So what is its magnitude, guys? You can clearly see it's 3. Magnitude of mod of A cross B is 3. So use it here. This is 3 into mod of C is 6. From here we get mod of C is equal to 2. So by the time we get mod of C, we can use it here. So mod of C square will be what? 4. So A dot C will be equal to, right? I hope you understood, because everything has been used. The product, the dot part, the cross part, and these type of questions have been in more numbers in JEE Main. But again, it is not difficult because the method we are using is, it's like we are using again and again, right? So it should not be any problem in solving them. Moving on to the next topic, which is scalar triple product. Okay guys, so let's do our next topic, which is STP. Now what is scalar triple product? You see, when we have three vectors A, B, C given like this is called STP, A dot B cross C. Now here dot and cross are interchangeable. We can write it A dot B cross C or A cross B dot C. And the reason behind calling this is scalar, it should be clear to you, because it's a scalar value. A dot B cross C or A cross B dot C is a scalar value. So it's not always like that we have to calculate dot and cross. It is mostly the use of determinants, guys. The why it is determinants? You see, when we have vector A, suppose vector A is equal to A1i cap plus A2j cap plus A3 k cap, A3 k cap, and vector B something, let's say B1i cap plus B2j cap plus B3 k cap, and vector C is C1i cap, C2j cap, C3 k cap. So for this system, if we calculate ABC ka box ka dot, that is determinant, guys. A1, A2, A3, B1, B2, B3, C1, C2, C3. Right. So if you have to calculate box, you have to just calculate the determinant of the coefficient. Why? That is clear from this. If you calculate b cross c, it will be b1 c2 minus b2 c1, right? And then you take dot with a. So for that it will be I cap. So I cap will remain same. So this quantity can be expressed in terms of determinant. So that is why the properties of this box product, of this scalar product, is also related to the properties of determinants. So I'll write some properties. I'll write some properties here. So let me write the properties. So the first property I will write is about the order. You see, this box of ABC is equal to box of BCA. If you follow the same order, it will be equal, or it will be equal to CAB. But if you disturb the order, it will be negative sign. Let's say if you write ACB, this will be negative of ACB, or it will be negative of, suppose you start with BAC like this. And why it is so? Because of that determinant. You see, in the determinant, you see, from ABC to BCA, we have to do odd number of interchange. How? First, A will be interchanged to what? A will be interchanged to C, and then B and C will be interchanged. 2 times interchange. But to get ACB from ABC, we have to only interchange BC. So when odd number of interchanges happen in determinant, then negative sign occurs. The same logic here. Okay. Then property number 2 is that if we have constants multiplied, let's say lambda A mu B into C, so we can just take constant outside, lambda into mu, and this is vector ABC. We can take constant outside always. Then property number 3 is that these are very basic properties. Okay, the property number 3 is that if it is like if we change the order, if we add it, or let me say, like if we have something like this, A plus B, B plus C, C plus A, so this will be equal to twice of box ABC. And if we have box A minus C, B minus C, C minus A, this will be equal to 0. You can remember it. A plus B, B plus C, C plus A, twice of ABC, 0. Now I'll tell you one shortcut also, that why exactly this happens. You see, when you have ABC as non-collinear vectors, just like IJK, right? So you think of this as written in terms of components of ABC. Just think of A as I cap, B as J cap, C as K cap, and then calculate the determinant. See, what is box of IJK? It is 1. I dot J cross K, it is 1. So here if you treat it like this, like AB, so coefficient of A 1, like I'm trying to tell you that you imagine this, system like this. You imagine this system like this. 1A plus 1B and plus 0C. And the second one is 0A plus 1B and plus 1C. And the third one is 1A plus 0B plus 1C. So if you calculate box for it, so it is 110, 110, then it's 011, 011, then 101. So if you calculate that, that will come out 2. This will come out as 2, and then ABC. Right. So this is a kind of shortcut, right? If we're, and this is important, that ABC should be non-collinear. Because in case of collinear, sorry, not non-collinear, my mistake, non-coplanar. ABC are non-coplanar vectors. Right? Because what will happen if they are coplanar? That also we should remember. And in fact, the most used property here, is property number 4. That if vector A, B, C are coplanar, if A, B, C are coplanar, okay, if vectors A, B, C are coplanar, in that case, the scalar product ABC will be equal to 0. And why it is equal to 0? Why is it equal to 0? But you see, you are finding A dot B cross C. So if A, B, C are in the same plane, suppose this is A, this is B, and this is C, A, B, C. So if A, B, C are in the same plane, so A dot B cross C. Now B cross C will be what? Out of the plane. So A and B cross C will have 90 degree between them. So what will become A dot B cross C? 0. So if vectors are coplanar, their STP, their scalar product will be 0, and one of the most used property. We don't know how many times we are going to use this. Property number 4, the most important property. Then property number 5 is that box of ABC square. Box of ABC square will be equal to, this will be determinant of A dot A dot B, A dot C. It will be B dot A, B dot B, B dot C. It is C dot A, C dot B, C dot C. And if you want to ask like why exactly this, you can figure it out from multiplication of determinant. Remember it. Then property number 6. If it is said that if STP ABC, if ABC is left-handed system, if ABC forms left-handed system, then STP will be negative, less than 0. And if this system of vector ABC is right-handed, if this is right-handed, then in that case, the STP will be positive. The STP will be positive. So these 6 property will have like in general use. Okay, starting with the determinant part, then all these things. Okay, this is square thing, right, left-handed, right-handed. Then there is some geometrical application also. Geometrical application. And what is that geometrical application of STP? The first result is that volume of parallelopiped. Volume of parallelopiped. Parallelopiped with co-initial or co-terminus, both we can say. Let's say with co-initial edges. With co-initial edges as ABC is given by box of ABC. This is the first thing. And the volume of tetrahedron, volume of tetrahedron with vectors ABC as co-initial or co-terminus, both we can use. Co-initial edges is given by 1/6 of box of A, box of B, box of C. Okay, so these 2 results will be used. I hope you are familiar with the parallelepiped and tetrahedron. See, for tetrahedron, the shape looks like something like this. So you join it. Suppose this is A, this is B, and this is C, like this. This is A, this is B, and this is C. This is tetrahedron. And for parallelepiped, hey guys, I hope you should know. This is the parallelepiped, right? So here let's say this is A, and this is B, and this is C. This is the co-initial or co-terminus. You can consider co-initial or co-terminus for both. The result, these are the 2 results which you should remember. Volume of tetrahedron 1/6 box of ABC, and volume of parallelepiped will be exactly equal to box of ABC. Right? What else? What was the other important point? That if this again, that if vectors are coplanar, the STP will be always equal to 0. Okay. So with based on these information, let's solve problems. So the first question here, let the vectors 2AB are coplanar. Okay. So then which of the following is true? Yes, so obviously here A and B are scalar values. So this is 2 plus A plus B. Then next one is A plus 2B plus C. Then minus B minus C. Then 1 plus B, 2B. Let me correct, this is C. 2B minus B. And then 2 plus B. 2 plus B, 2B. And then 1 minus B. Right? This is 0. So basically, this is properties of determinants that we have to use. Right? Properties of determinants. So to simplify it, what I can do, I can subtract row 1, row 3. I'll replace row 1 as row 1 minus row 3. If I do that, this 2 plus b, so only a will remain, right? So I will replace row 1 as row 1 minus row 3, and then row 2 also I'll replace row 2 minus row 3. So with these transformation, it will be only a. This will be a plus c, and this will be minus b. So it will be minus 1 minus c, right? If I subtract, minus b plus b will be gone, minus c minus 1. Now here, row 2 is also row 2 minus row 3. So 1 plus b minus 2 plus b minus 1. This is 0, and this is only 1 minus 1. And this is 2 plus b. This is 2b and 1 minus b. Now I think we can expand it easily. We can expand this very easily. We can expand it through second row or first row. So if you expand it, you'll get this as answer. Right? After this, you can expand it through second row. Just expand it, guys, through second row, and you will get your answer. So this is how they can use STP related to determinant problems. Okay. So moving to next question. Let three vectors A, B, and C such that, again there is no vector sign, A, B, and C be such that A cross B is equal to C, B cross C is equal to A, and mod of A is 2. Then whichever one of the following is not true? Okay. A cross B is C, B cross C is A, and mod of A is 2. So we have 4 options to check. Okay. Let's check, guys. Let's check. In the options also, guys, this vector sign is missing everywhere. I don't know what to do for that. This is so frustrating every time. Okay. So starting with what? With what we should start? A cross B plus C cross B minus C. So this is, let's check with option A first. So option A cross. So A cross. Now this is B cross B is 0. So this is minus B cross C. Then, right, this is minus B cross. Then C cross B plus C cross B. And then this is what? This is minus C cross C, that is 0. Is correct? B cross B 0, minus B cross C, C cross B, and minus C cross B. So this is equal to A cross, and this is what? This minus B cross C is C cross B. So C cross B with 2. This is twice of A cross C cross B, right? And what is it? C cross B is minus A. So 2 A cross minus A. What is that? 0. Right? B cross C, guys. B cross C is A. So C cross B will be minus A. So A cross minus A will be automatically 0 because this is A, this is minus A, the angle is pi. So sin pi is 0. So option A is true. Now let's check for option B. Projection of A on B cross C is 2. So projection of A on B cross C. So what is that? A dot B cross C cap is equal to A dot B cross C and divide by mod of B cross C, which is equal to, now A dot B cross C, guys, A dot B cross C. B cross C is again given what? B cross C is again given what? A vector. So this is basically A dot A divided by, and B cross C is also equal to what? B cross C is A. So this is what? Mod of A. Right? Is it correct? Mod of A is given already. So this is mod of A square. So it is only mod of A remaining. So that is equal to 2. And we have that 2 as the answer. It is fine. So option B is also correct. Let's check with option C now. ABC plus CAB. So CAB. Now guys, see. ABC and CAB. Now that is of the same order. Right? ABC and CAB. So what is ABC value? What is value of ABC? ABC is nothing but A dot B cross C or A cross B dot C. Now B cross C is vector A. So that is A dot A. This is mod of A square, which is 4. Right? So CAB is also in the same order. CAB. So CAB, like CAB will be also equal to ABC. So option C is also 4. That will be equal to 4. So C is also correct. So I think only D is incorrect, guys. 3a plus b minus 2c. So only this thing is incorrect. So what we can do here, a cross b is c, b cross c is a cross b is c, right? So can we say from here that c is perpendicular to a, c is perpendicular to b, and from we can say that a is perpendicular to b. So all of them are mutually perpendicular to each other, right? All of them are mutually perpendicular to each other. So if I square it here, so basically it will be only, since all of them are perpendicular to each other, so it will be 9 mod of a square plus mod of b square plus 4c square. Rest all will be 0. So mod of a is 2. So 9 to 4, 36. What about b? So to find out b, I can say that from here mod of a into mod of b is equal to mod of c. Now see, all of them, the angle between them is 90 degree. From here we can say. So mod of a into mod of b is equal to mod of c, and mod of b into mod of c is equal to mod of a. So if I multiply them, so I'll get from here that, like if I multiply them, so guys, what is it? Mod of b square, so mod of b will be equal to 1. So mod of b will be equal to 1. So if mod of b is 1, then what will be c? C square. What is mod of c? Mod of b is 1, right? A is 2, so it is only 2. So 4 into 4. So 36 plus 1, 37, and 37 plus 16, 53. So this comes out as 53, but it's given 51. So this is the only which is not true. So D is the correct option. So much calculation here, and you see the option was also 4th. So I don't know, like in exam, if I am student, this is my approach, that I'll always start with last option, because the examiner can do that. I'll always check first and last option. First and last option, that will be my first priority. Okay, because if only first one is wrong, then there is no sense of giving these type of questions. They want you to fight with these other options, right? Use your brain. Solve last option first. Here. So let A equal to ijk, and B and C are the vectors such that A cross B is equal to vector C, and A dot B is 1. If the length of the projection of the vector B on the vector A cross C is L, then 3L square. Okay. So projection of B on A cross C. So it will be B dot A cross C cap. It will be B dot A cross C divided by magnitude of A cross C. Correct? Correct. A cross. Now B dot A cross C can be also written as, right? B dot A cross C can be also written as B cross A dot C divided by A cross C. And I think B cross A is known. See, B cross is how much? It's C. So B cross A is minus C. So it is minus of C dot C divided by mod of A cross C. Which is equal to what? And B and C, everything is given. So what is the need then, guys? Right? If everything is given, B and C are equal to this A cross C. So C dot C, so mod of C square. So what is mod of C square? Mod of C square will be equal to 112 root 2. So it is 2 minus 2 divided by mod of A cross C. What is A cross C? What is A cross C mod? A cross C mod we can find out from here, right? A cross C will be I j k. This is 1 1 1, and this is j k. So 0 1 minus 1. Correct? So this is I cap minus 1 minus 2 minus j cap. This is the I cap minus 1 minus j cap minus 1, and the other one is 0, and plus k cap. This is 1. So that is minus 2 I cap plus j cap plus k cap. That is A cross C. So what is the magnitude of A cross C? It's equal to 4 root 6. That's it. Minus 2 divided by root 6. This is value of L. So what is 3L square? L square will be, this is 3 into 2 square 4 divided by 6. So answer will be 2. That is what we have here. So it's about the direct question. There was nothing to think. Everything was already known. You just have to keep on finding the relevant result. It is just only about calculation. They are not checking our any analytical skill. It's only about whatever they are asking, keep calculating. Clear? Okay guys, let's solve next. So question is A is given, B is given, A cross A dot C. Similar question. So similar question. See, A dot B cross is asked. So this A dot B cross C, that we can write as, since we have given about A cross C. So this is minus A dot C cross B, right? So I can write it as minus of A cross C dot B also. And A cross is given B. So minus it will be B dot B. So that is nothing but minus of mod B square. So A dot B cross C is minus mod B square. Right? A dot C is 3. A dot C is 3. Right? C is a vector such that A cross C is B. A cross C is B. So we have got this. Now A dot C is 3. Okay. Then A dot B cross C is that. So mod of B square. So A dot B cross is only mod of B square. No, minus of mod of B square. There is nothing left to solve. So this is equal to what? B, this mod of B is equal to minus 2. That's it. We don't even need anything. You see, A dot C was given 3, something else was given, not required. No, game is over. A dot B cross C. A dot B cross C, we got it equal to minus of mod B square. Mod B is root 2. Game is over. Clear? You might fall in the trap here that why is it the other way? You might try to find out vector C in the previous problem. You'll be completely a fool. 1 pi lambda what? These are what? Are coplanar. You see, suppose this is point A, B, C, D. So if these are coplanar, so can I say that AB, AC, AD? I'll form 3 vectors. This will be 0, right? If AB, CD are in the same plane, so I'll frame 3 vectors out of them, and the coplanar, if they are coplanar, their STP will be 0. So that is what I've done. AB, AC, AD equal to 0. So just solve it. What is AB? What is AB? AB will be equal to, I think I'm not going to solve it, guys. You know, you are expert in that, right? That's it. You have 4 points. So just frame 3 vectors and just put them equal to 0. You will have it. Volume of a parallel pipe. Direct formula is there. What is the volume parallel piped? 1 by 4 box ABC, right? Sorry, volume of parallel pipe is no. So it is box of ABC. What is box of ABC? It's 1 1 n, then 2 4 minus n, 2 4 minus n, and 1 n 3. This is equal to how much? 158. So you calculate it, right? And there is a mod sign also. The mod of this is equal to 158. You calculate and find it out. That's all. Just calculate it, find it out, you will have your answer, whatever they are asking. Then the next part is vector triple product. So till now we have been doing problems related to STP. Now we'll do VTP. What is VTP, guys? VTP denoted by A cross B cross C is equal to A dot C into vector B minus A dot B into vector C. You just see the order, guys. Just see the order here. It is exactly like we have here. A, B and C is there. So B and C is here. So obviously since it is vector value, so B cross C cross A will be a completely different thing. A cross B cross C will be a completely different thing. What you must know that A cross B cross C, A cross B cross C, this is a vector. This is a vector which is which lies in plane of B and C, vector which is lying in the plane of B and C and perpendicular to vector A, and perpendicular to vector A. Now this is the most important statement about STP, because in the problem they'll not give you to calculate A cross B cross C, they'll give you this. The question will be something like that. Let us find a vector which lies in the plane of P and Q and is perpendicular to R. So what is that? R cross P cross Q, like that. And you just see the pairing, guys. Okay. Now you will understand like why it is this, because this is like lambda B plus mu C. So if some vector is lambda B plus mu, so that is made of combination of B and C. That means it is lying in the plane containing B and C. Right? And how it is relevant, like how exactly we can show that, we'll see very soon in the linear dependent independent part. Okay? So for now, this is what you have to know, that if I'm writing A cross B cross C, this is the value. But this will be a vector which is lying in the plane of B and C and is perpendicular to A. This is the result which you have to know. Right? Because in you will be directly asked to find out, and this will be the language. Okay? So now if you want to know the properties, I think there are not much properties related to VTP, right? Except this thing. This result has been there, has been asked at least 2-3 times. It is A cross B, B cross C, and A cross C. This is equal to box of ABC square. This result has been asked at least 2-3 times. And it's not difficult to prove. See, I'll show you. I'll show you how it is ABC square. I think it is C cross A. I'm not sure. I think it is C cross A. Guys, will prove it. See, I want you to show this how it is box of ABC square. See. So I'll write this as A cross B dot this cross this, B cross C cross C cross A. Now there are 4 vectors, but we don't know the formula for 4. We know the formula for only 3. So for instance, let's say that, okay, let's assume, for instance, let's assume that B cross C is some vector P. Okay, so this will be A cross B dot. And this is P cross C cross A, right? And now expand it. A cross B, now we have the VTP formula, dot. This is P dot A into vector C minus P dot C into vector A. Now guys, just tell me one thing. P is B cross C. So B cross C dot A, what is that? BCA. That will be ABC. This is A cross B dot. This P dot A, you see what is P? P dot A. So what will be P dot A? P dot A. So P dot A or A dot P will be what? A dot B cross C. That is what? Box of ABC. Correct? So I'll write it here. Box of ABC into vector C minus. What is P dot C? What is P dot C? What is P dot C? P dot C. So that is equal to P. P here. P is what? P is B cross C. So B cross C dot C. Now, isn't it 0? Why? Because B cross C is perpendicular to C. So if you are taking dot with C, it will be automatically 0. That is 0. So this is 0 here. So now what is it? This is box of ABC. Then again A cross B and dot with this vector C, which is again ABC. So this is ABC, ABC, which is equal to box of ABC square. So if you don't know the proof, there is no problem, but you have to remember the result. In the VTP part, this result has been seen many number of times. Okay, definitely remember it. Then let's keep moving, guys. So in VTP, this is the one result, the expansion of A cross B cross C. The second thing about this thing, A cross B, B cross C, C cross A. Now VTP is not there in detail. It's only about this few properties that they have been asking. It's not that in detail given in JEE main. So that is why I'm going to start with the problems directly. Okay. So here the first problem. Let A, B and C be 3 vectors which are mutually perpendicular. Again, vector signs are missing. So A, B and C with 3 vectors mutually perpendicular to each other and have same magnitude. Fine. So if a vector R satisfies A cross R minus B cross A plus B cross R minus C cross B and plus C cross R minus A cross C equal to 0, then vector R is equal to, okay. Now everywhere this vector sign is missing, everywhere. Please don't mind guys, if anyone is watching this lecture, so I am really sorry for this, that the signs are missing, but I hope you will understand. So ABC be the three vectors which are mutually perpendicular. So this is given 0. So let's solve one of them. Let's solve one term. So one such term. So this is A cross R minus B cross A. Okay. R minus B cross A. So R minus B cross A. Right. That's all. A cross R minus B cross A. Right. So ABC are three mutually perpendicular to each other. Okay. They have magnitude also similar. So this will be what? This will be A cross B minus R. I can write it like this also. Why? Because if I write it as minus of A cross R minus B, so there will be one negative sign. So that I can write it this. Now if I take this, if I expand it, so A dot B minus R into vector A and minus, okay, then A dot A into vector B minus R. So A dot B minus R will be what? A dot B is 0. A dot B is 0. So minus A dot R. So this is A minus of A dot R into vector A, and this is minus mod of A square into vector B minus R. This is what we'll get. Right? Or now if similarly, if you see the other parts also. So what is this going to be? If I write the other ones also similarly, so what is it? The final value will be, if I write the other parts also, the other one, the following the same pattern. So what is it? A dot R A. So it will be minus of A dot R into A plus B dot R into vector B plus C dot R into vector C, and this will be what? This will be equal to, so this will be equal to B minus R. So this will be equal to, minus sign will be gone, and B minus R. So mod of A square, mod of B square. So since magnitude is equal, so let's say mod of A square times, so A plus B plus C, vector A plus B plus C minus 3R. This will get 3R minus A plus B plus C. It will be opposite. It will be 3R minus A plus B plus C. 3R minus A plus B plus C. Okay. This we know that all these vectors are perpendicular, right? A dot R A. So they have same magnitude, right? Now what about A dot R into A, B dot R into B, C dot R into C? What is this? What is this? A dot R into A, B dot R into B, C dot R into C. So can we expand it, guys? Can we expand it? Now what is ABC? What is ABC? What is ABC? We don't know about that, right? What is ABC? So can I say that R is nothing but, it can be a combination of ABC. Like vector R will be equal to lambda A plus mu B plus something gamma times C, or lambda 1 times C vector. So if I take dot with A here, so R dot A will be equal to lambda mod of A square, rest all will be 0. So lambda comes out to be R dot A divided by mod of A square. So that's all. That is the good thing. This right here guys, this right here mod of A square, if you divide it here in the LHS, So A dot R A, B dot R B, C dot R C will be equal to what? This will be equal to, this will be equal to vector R itself. If you divide it here, because magnitude is equal, so it is R is equal to 3R minus A plus B plus C. So from here we have 2R is equal to vector A plus B plus C. So from here we have vector R equal to A plus B plus C by 2. Right? So this is the answer. Now I understand. Like some of you are wondering what just happened. What just happened, sir? What is happening here? See, let me tell you. So this is the question which is based on linear independency, linear dependency. So this is the next topic for us. So I'll advise you that you first complete that topic and then get back to this problem. Just note down the timing of this question and then get back to the question. See, once you are done with linear independent dependent thing, I'm just explaining this thing. ABC are three non-coplanar vectors. R is the fourth vector in the plane. So this is the logic that if we have three or more non-coplanar vectors given, then any vector in this space can be written as linear combination of that. So I wrote R equal to lambda A, mu B, lambda 1C. Okay. And after that, now to calculate lambda mu and lambda 1, I have taken dot with this vector both the sides. So R dot A will be equal to what? Lambda A dot square, A dot B 0. So we got lambda value equal to R dot by A square. Then I'll take dot with B with dot C. Now mod A square will be there, then mod B square, mod C square, but ABC have equal modulus. So all of them will get replaced by mod of A square. So exact same thing will be there. This divided by mod of A square will be equal to vector R itself. This is not expected, guys. Like this is the finest problem that we did in vector, and this is not totally VTP. This is not totally VTP. Okay, I'll advise that you first complete linear independent, linear dependent, and then get back to this problem. I'm covering that particular topic in this session also, right? So, like I'll show you. It's right here. It's right here. Linear dependent, independent. So when I've explained this topic, then you can get back to this question and then you can solve it. So let's solve the remaining questions, guys. Okay. So let A is ij plus 2k, B is there. Vector product A plus B cross. What is it? A plus B cross. Then A cross. Then it is A minus B cross B. A minus B cross B and again cross B. Okay. So let's see what is this. So this is A plus B cross A cross. Now A cross B minus this is 0. So it is only A cross B. Again cross B. Right. So let's solve A cross B first. What is that? So A plus B cross. If I solve it, A cross B. What is that? A dot B into vector A minus A dot B into vector A minus A dot A. So mod of A square into vector B. This cross B. Now, do we have something about B? Are they perpendicular? You see, minus 1, 2, 3. No, they are not perpendicular. So we have to solve. The next is A plus B cross. When we take cross with B, so A dot B multiplied by A cross B, and B cross B will be 0. This is 0. So now this is A dot B just a constant. What is A dot B, guys? A dot B just a constant. What is A dot B? From here, if you calculate, A dot B is equal to minus 1. This is plus 2 plus 6, right? 3 to 6. 8, 7. So it is 7. So 7 times. This is A plus B cross A cross B. So what is this is equal to? 7 times. This is A cross B. A cross B plus B cross A cross B. B cross A cross B. Clear? So what will be next step? Now this is just formula, no? A dot B into vector A minus A dot A will be mod A square into vector B plus then this is b dot a into vector b minus this is b dot into vector b minus b dot b mod of b square into vector a. So just calculate it. Just calculate it. Now this is just left for your calculation. Put the values, calculate it, you will get this. Right. So this was looking slightly weird in the beginning, but you can see again and again we were getting b cross b. So it was reducing to only one simple term. Right? Okay. Moving on to next question. Let A, B and C be three vectors such that A is equal to B cross C. Again they are vectors, but there is not mentioned. Like sometimes it strikes is root 2. Angle between B and C is theta. Then the value of 1 plus tan theta. Okay. A, B and C be three vectors. A is given B cross C. Okay. And angle between B and C is theta. Angle between B and C is theta. Right. And the magnitude is also known, guys. So here, what is A? A is equal to, so this is B dot C. This is B dot C into vector B minus mod of B square into vector C. This is there. Now B dot C, do we have B dot C? Angle B and C is theta. We don't have anything else. Okay, we have magnitude of all of them. So B dot C, we don't know. So magnitude is there. So B dot, what is B and C? B and C are 1 and 2. And this is 2 cos theta. So 2 cos theta into vector B minus mod of B square. Mod of B is how much? 1. So C. Right. Now you know what to do. We have combination of B and C and we want angle between B and C. What is the best way? A square. Square it. So A square is equal to 2 cos theta into B vector minus C vector square. So vector square matlab modulus ka square. So mod A square is equal to mod of 2 cos theta into vector B minus C mod square. So it is mod of A square equal to, and mod of A square is known. Why will you write again and again? Mod of A. What is mod of A square? Mod of A is root 2. So 2 is equal to, so this is 4 cos square theta into mod B square, that will be 1. Mod C square, C is 2. So 4 and minus 4 cos theta, right, 2AB. So minus 4 cos theta B dot C into B dot C. So just solve it. 2 plus 2. 2 is equal to 4 cos square theta plus 4 minus 4 cos theta B dot C. What is B dot C? Minus 4 cos theta into B dot C is, guys, how much? B dot C is, what is B dot C? B dot C is, we don't know, mod of B into mod of C cos theta. So it is 2 cos theta. So the game is over now. What is it? 4 cos square theta, 8 cos square theta. So 4 cos square theta is how much? Minus 8 cos square theta. 4 is equal to 2. So cos theta comes out equal to how much? 1 upon root 2. So theta is equal to pi by 4. Right? So they are asking 1 plus tan theta. The answer is 2. Lovely problem. Right? So instead of this was the use of B cross C was only for the first step. After that, it is purely the use of the concepts we have done in vector scalar product, right? In the cross product part. You see, what is it? It was once we have arrived at this step that we have B and C and we need angle between B and C. So it's only square of that. Square karo bas. Keep squaring, keep getting answers. A and B are perpendicular. A cross B. Let's keep on solving. So this will be A cross, then A cross B will solve. So what is that? A cross B will be A dot B into vector A minus mod of A square into vector B. So A dot B will be 0 because A and B are perpendicular. This will be 0. So it is A cross B with minus mod of A square outside. Correct? Right? Again the same thing. So minus mod of A square So with the same thing, right? A cross will be minus mod of a square into b. This will be. I think there is some problem. Right? Okay. Let's do this. A cross b will be same thing. It will be exactly same. So a dot b will be 0. So it will be only minus mod of a square into b will remain. So it comes out as mod of a to the power 4 into b vector. This is the result. I think here by mistake this 4 is multiplication. This is power 4. Right? This is the answer. Mod of a power 4 into b vector. Again there is no vector sign. What to do, man? Vector a, vector b, vector, 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 vector. Okay, easy one. Easy one. Just use the formula. You see from VTP how easy problems have been there in exam. So moving on to the last segment of vector, which is linear dependency and independency. After that we'll start with 3D. So in linear dependency and independency, see what do we mean by linear combination? So when we write one vector, you see, when we write one vector r is equal to something a1 or less. So suppose one vector r is something like x1 vector a plus x2 vector b plus x3 vector c and so on. So if our expression is written like this, here we can say that vector r is linear combination of, where vector r is linear combination of vectors A, B, C and the others. This is linear combination. So with help of this linear combination we can define the linear dependency and independency of vectors. So starting with two vectors. So if we have vectors A and B, right? So if A and B are collinear, right? If A and B are collinear, so we write that A is equal to lambda b. Do we write this? If A and B are equal to, if collinear, so A will be equal to lambda b. So if it is true, then something xa plus yb will be 0. This will be also true, right? Because let's say minus x by y is lambda. So if A and B are collinear, so xa is equal to yb. So this means what? We can write one vector in terms of other vector, right? So I can write A in linear combination of B. B can be written as linear combination of A. So from here we can say that if A and B are collinear, then here A and B are linearly dependent. Here A and B are linearly dependent system, right? This will be true. This is true for x, y real. For some x, y real, this will be true, right? So if A and B are collinear, this was the first thing. So if A and B are collinear, so vector A and B can be written in terms of each other. So there we can see that this will be a system where A and B are linearly dependent on each other, right? But on the same side, if I this is the first part, let's say this is the A part, this is the first part, and if I do the second part here, if I say now that A and B are non-collinear, then what? If I say that vector A, B are non-collinear, then what is happening? What is happening now? So if A and B are non-collinear, then will this statement hold true? So xa plus yb equal to 0. Now this cannot be true for real. Now obviously xy is non-zero here. So xa plus yb is 0. Now will this be true? No, this cannot be true. Because A and B are non-collinear, I cannot write A in terms of B. Linear combination is not possible here. So this type of system here, this is true only if x is y equal to 0, and here the system is A and B are linearly independent. This will be true only if vector A and vector B are linearly independent, right? because they are non-collinear. So remember, non-collinear, linearly independent. Collinear, linearly dependent. Clear? Clear? Right? So here AB are non-collinear. So this xa plus yb equal to 0 will not hold true. It is true only if x and y both are 0 simultaneously. And this is a linearly independent system. This is linear dependent system. Now if we have, now this was about collinearity. Now let's see one more condition here. Okay. Suppose we have two vectors A and B given in the plane. Right? So if we have a plane given, so if I assume a vector r here, if I assume a random vector r, now I can definitely write this r by some means as a combination of A and B. How? You see, if this is B, so I'm highlighting this part. So this part here can be said something as y times B, and this part here will be something x times A. Right? So guys, you see the parallelogram is being completed here. So if A and B are in the plane, obviously two vectors will be in the plane. So can I say that if R, A, B are coplanar, if this is a coplanar system, then I can write R as something xa times yb. This is true, right? If vector R, A and B are forming coplanar system, then I can write R in terms of A and B. You can clearly see that it is true. So if we can write one vector in terms of other, what type of system is this? Linearly dependent. So here this is linearly dependent system. This is linearly dependent system, right? This is the part one, when coplanar. And in the other case, if some vector R, vector A, B are non-coplanar, in that case, right? If they are a non-coplanar, then XR plus YA plus ZB equal to 0. If it is given, then this is only true if all of them are 0, X, Y, Z is 0. And this type of system will be linearly independent, right? So basically linearly dependent when we can write one in terms of other. But if R, A, B are non-coplanar, if one vector is R here, like this is A, this is B, and R is out of the plane. Now I cannot write R in terms of A and B. I cannot write in terms of R. I cannot write R in terms of A and B. So this system here is what? This system is linearly independent, and for non-coplanar vectors, if this is given, this will be true. One thing I want you to write specially, that if three vectors are coplanar, if three vectors A, B, C are coplanar, then anyone can be written as linear combination of other two, only if they are coplanar. Now what do we mean linear combination? This, like it's written that A and B are coplanar with R, so R will be equal to lambda A plus mu B. Here it was R was coplanar with A and B, so R is equal to XA. Now the same can be written with B also. B will be lambda R plus mu A. A will be some constant times R plus new constant times B. So anyone can be written as linear combination of the other two. And we are going to use this point a lot. You are going to see that. And this is also very, very important. That if we have three vectors R, A, B, which are non-coplanar, and there are coefficients x, y, z such that this is given true, then that is possible only if all the coefficients are simultaneously 0. And this will be linearly independent system. Okay. So the questions have started. I need one more page, guys. You see, this is for linear. This we have seen for linearly dependent system for 2 vectors, then for 3. What if there are more than 3? Okay, what if we have more than 3? So I'll add one page here. I'll explain it to you right now. Okay, let me add a page where, yeah, let me add a page here. I'll explain. Okay. So what if we have 3 vectors, more than 3? So when we have more than 3 vectors, no, then we are talking about a space. Okay. So, or let's draw one other diagram. I'll explain it to you. The point in that problem which I had explained. How can I write R like that? You see. So this is y-axis. This is z-axis. This is x. Or let's say this is axis for, this is some vector A, B. This is some vector B. This is some vector A. Or wait a minute. Okay. So let's say this is some vector B and this is some vector A, and then we have some vector C, right? So now we have a space. We have a space here because we are using non-coplanar vectors A, B, C. Now consider a new vector, any new vector R. Consider any new vector R. So let's say this vector. Let's say this is vector R. So guys, you see, if this is C vector, so just focus here. Just focus here. This is R, right? So what will be this vector? So can I say that this length will be something x part A, because in the direction of A. This is in the direction of A. So to adjust the magnitude, I multiplied with x. So this is xa. What about this? This is in the direction of C. So let's say this is y, zc. So what will be this? This will be xa plus zc, where x and z are scalar value. So what about this? This is parallel to B. So this right here, I'm writing this as something y times vector B, right? So here we have a triangle getting formed. This plus this will be equal to this vector, right? So can I say from this system that vector R is equal to xa plus yb plus zc, right? So we have written R, okay? We have written any vector as a linear combination of the non-coplanar vectors A, B, C. So if you have formed a space, then any vector can be written as the combination of these. If we have 3 non-coplanar vectors given, we can write other fourth vector in terms of those. This is the main statement. Just write it down. If we have been given 3 non-coplanar vectors, then any fourth vector can be written as a linear combination of those vectors. So if ABC are what? If ABC are non-coplanar, right? If ABC are non-coplanar system, non-coplanar. Now this is what? This is linearly dependent. This system is now linearly dependent because we can write one in terms of other. So if ABC are non-coplanar, then guys A cross B will be also non-coplanar, right? Or A cross B, B cross C, C cross A, this will be also non-coplanar. So if we have given only with A and B, so can I say that for this system, any vector R can be written as something x vector A, y vector B plus z times A cross B, because A, B and A cross B have formed what type of system? Non-coplanar system. So we had 3 non-coplanar A, B, A cross B. So any random vector R can be written as a linear combination of those. And then with this also, we can say that R will be equal to x times A cross B plus y times B cross C plus z times C cross A. So if you have understood this, then you should be able to relate with the problem that we had solved in the VTP one, is this one. Right here you can see that ABC were 3 mutually perpendicular vectors. So what I did, I wrote that random vector R as a linear combination of A, B, C. You see, lambda A mu B, lambda 1 C. And after that, it's just dot product, and I'm playing with those determinant or those magnitude things. Clear? So I hope you should be able to relate this problem after we are done with this thing. You okay? Just mug it up. Just mug it up, right? And what all the things we are going to use in exam, this thing you can see, especially this thing. Most of the time you are going to see this, or the previous one, this, ye wala part, right? Sorry, ye wala part. When we have x and y both equal to 0. This you have in JEE main exam, multiple, at least 3, 4, 5 problems with the same concept in JEE main exam. Okay, let's solve few problems. The first one here is x be a vector in the plane containing vectors a and b. See, x is a vector which is containing a and b, right? So x, a and b are coplanar, correct? X, a, b are what? Coplanar. So I can write that x vector will be something lambda a plus mu b. I can write this because I know that these are coplanar vectors. What is next? If the vector x is perpendicular to this and its projection on A is this, okay, fine. So we can use these information to find lambda and mu. You okay? So vector x is perpendicular to this vector. So what is x? X dot 3i plus 2j. This will be 0. This will be 0. So what is x? This will be 0. So that means lambda a dot this thing will be 0. So let's calculate that. So lambda times what is a? So 2 into 3 6, then minus 1 minus 2, and this is minus 1, and plus mu times b dot this vector. So 3 2 2 4, then minus k, this will be plus 1. This is 0. So one relation we got 6 to 4 3. So 3 lambda 4 3 7 plus 8. 3 lambda plus 8 mu equal to 0. We got one relation from here. We need one more, and they already have given one. How to use the second one? What is saying? That its projection on A, right? The vector x is perpendicular to this, and the projection on A. So x dot a cap is 17 root 6 by 2. What is x? X is lambda a, right? Lambda a plus mu b a dot a cap. So dot vector a divided by magnitude of a is 17 root 6 by 2. So lambda into a dot a square. What is that? Root 2 square 4 5 6 root 6 plus mu times b dot a. Guys, what is b dot a? So the root 6 square will be only 6, no? Only 6. And b dot a, what is b dot a? 2 minus 2, 0, minus 1, right? 2 into 2 over 2, this is 0, minus 1. Divide by mod of a, what is that? Root 6 is equal to 17 root 6 by 2. Root 6 will be 3. So 6 lambda minus mu is equal to, guys, this is 6 3 51. So I think next step you can perform. So we have equation 1 and 2. So from 1 and 2 we can find lambda and mu. So by finding lambda and mu we can find out value of x because a and b are known, and then we can find out its magnitude. Understood? This is the use of LILD information. Okay, otherwise you just assume x anything random with 3 variables and you will keep on solving. Let's solve this question. So let a vector a be coplanar with vectors b and c. Same thing. A is equal to lambda b plus mu c because these are vectors coplanar. If a is perpendicular to d, so lambda b dot d plus mu c dot d will be 0. From this we will get one relation, and mod of a is equal to root 10, and mod of a, so mod of lambda b plus mu c is equal to root 10. This is the second info, guys. That's all. ABC plus ABD plus ACD. So this is easy. This we can solve. Lambda b plus mu. So from here, lambda and mu can be calculated very easily. How? B dot dc. D is given, B is given, C is given. So by squaring here, everything can be calculated. Everything can be calculated. So calculation I'm leaving up to you. Just calculate on your own. There is nothing to solve here. Let three vectors such that with the coplanar with A and B is perpendicular to C, where exact same relation, exact same thing. A dot C is 7, one extra information. This is one information, and B is perpendicular to C, second information. So with help of 1 and 2, you can find out the relation and you can solve accordingly. Same question. Let's solve next one. The same question. You see, the three questions have been asked exactly similar. Now here A and B. A, B, C, B, three unit vectors, out of which vectors B and C are non-parallel. Fine. If alpha and beta are the angles which vectors A makes, vector A makes with vector B and C, and A cross B is half B, right? Half of B. Then, okay. So A cross B cross C, guys, what is that? A dot C into vector B minus A dot B into vector C is equal to half of B vector, right? It's clearly given that B and C are non-parallel. But here, what is it happening? You see, A dot C minus half times B plus minus A dot B times C is 0. Now, when is this true? When is this true? B and C are non-parallel. Still, it's like XB plus YC is given null where B, C are non-collinear. So what is the logic from here? That X, Y will be equal to 0. So if you apply that, A dot C will be equal to half and A dot B will be equal to 0. What is A dot C? And all are unit vector. So A makes with B and C. So A makes with B. So here what is alpha and beta? So what is angle alpha? A makes with B. So alpha is pi by 2. Right, because A dot B is 0. And with C it is making an angle beta. So what is beta, guys? Because A and C are unit vectors. So mod of A is 1, mod of C is 1, cos it is 1 by 2. So beta will be equal to pi by cos 60 is half. So pi by 3. Right. So what is that? Alpha minus beta is how much? So 90 minus 60 is 30 degree. That is the answer. Understood? This is the use of LILD concept. What is it? This is the step. I told you that this is the step which gets asked a lot. So I hope you have understood this problem. Okay? Moving on to the next one. ABC with 3 unit vectors, that exact same question I am leaving up to you. You can calculate now very easily. Exact same question. You see, B, C, B, 3 unit vectors, that B is not parallel to C. Exact same concept. And they are again unit vectors also. Exact similar problem. We should not have a single % of problem in solving this. Okay, exact same question. This is also homework. You see, 3 questions back to back of the similar type. ABC with 3 non-zero vectors. If you are watching this lecture, you should not leave these questions blank, because you see, you have seen one. If you solve these 2, you will have full command on these type of problems. And see that repetition, guys. Okay, so now we'll start 3-dimensional geometry. Okay, guys, so we'll be starting now 3D geometry. So I'll write down all the important results. So for a 3D system, let's say this is X, Y, and this is the Z axis here. So clearly, when we have 2D system, X and Y, we deal with quadrant. But here we have octant. Like here we minus X, there will be minus Z, and there will be minus Y. So you can see the 4 compartments on the upper side and 4 in the downward. So this forms an octant system when we are dealing with 3D. Okay. So for this system, guys, suppose if I want to write equation of, this is the plane, right? XY plane. This XY plane, this is XZ plane, and this is YZ plane, right? Oh, this is YZ plane. Suppose if I want to write, obviously this is not restricted to this much. Plane is what? Plane is infinite. This is infinite length and width. The thickness is what? Negligible. The plane is called thin infinite sheet. So I'm just showing it just for the sake of understanding. So guys, if I want to write equation of XY plane, what will be equation of XY plane? Equation of XY plane, it will be Z equal to 0. right? If I want to write equation of yz plane, so on yz plane, x will be 0. And if I want to write equation of xz plane, it will be y equal to 0. Fine. So apart from this thing, this is very basic info. Now suppose if we have point P, x1, y1, z1, point Q, x2, y2, z2. So what is distance between P and Q? Distance between P and Q will be equal to root over x1 minus x2 square plus y1 minus y2 square plus z1 minus z2 square. Basically, these results are known to you. These results are very obvious, right? All the results which we have written for 2D system, like centroid. Now this time z-axis will be also involved. If you write in center, so that will be also involved, right? It will be x1, y1, z1 divided by 3 for centroid. Sorry, x1, x2, x3, y1, y2, y3, and z1, z2, z3 will be also involved. So this is distance formula. Now see, if I want to write distance of points, suppose, let me draw a proper system here. So guys, if I want to find out distance specifically from any axis, okay, so I'm drawing this cube just to have a better vision, right? Okay, so this is x-axis, this is z, this is y. So let's say here we have some point P, x comma y comma z, right? So I want to find distance of P from different axes. So for that point P, distance of P from x-axis, that will be root over y square plus z square, right? You will draw perpendicular. We'll draw a perpendicular. Okay, so if you see, it will be x square y square. What is this? This will complete a right angle triangle, right? So this is what? This is under root of x. This will be x square y square z square minus x square. So only y square plus z square will be left out. So distance from x-axis will be y square plus z square. Similarly, if you want distance of P from y-axis, now what is that? If you want to find distance of P from y-axis, it will be under root of x square plus z square, and distance of P from z-axis. So from z-axis, if you want to find out distance, it will be root over x square plus y square. These are the results, guys. Quite simple results, okay, but helpful. Now if you want to write section formula, the result is very, very simple. You see, in 2D, like many results from 2D, you can resemble it here. We can very easily remember them. So section formula, if you want to write, so suppose there is a point here, x1, y1, z1. So only that z-axis part will be extra added, nothing else. x2, y2, z2. And there is a point P which divides this in the ratio m is to n. What will be point P? This point P will be mx1, mx2 plus nx1 divided by m plus n. Then it will be my2 plus ny1 divided by m plus n. And for z, we'll just include it, mz2 plus nz1 divided by m plus n. This will be the result. Okay. So this might be something new for you, but rest all results are very obvious. You might have done them class 11th also. When you do the basic introduction of this 3D chapter, there you are acquainted with all these results. So let's move forward with direction, cosine and direction ratio. See. So let's say this is a plane here. This is a plane. Okay. This is a plane. I don't know why this plane is always looking bad. Okay. So let's say the 3D axis. This is x, this is y, z. So here there is a point P, x comma y comma z. Now this is making some angle alpha. Okay. Now this is also not looking good, guys. Okay. So okay. So let's say there is some vector P x comma y comma z. Now this is making alpha angle with x, this beta angle with y, and with z there is some gamma angle, right? Alpha, beta, gamma. Alpha with x, beta with y, gamma with z. So now this is x-axis with alpha. So what is that OP vector? Like OP vector will be, OP vector here, OP vector is xi cap plus yj cap plus zk cap, right? Now for this vector OP, if I want to find out cos alpha, so now this alpha is with respect to what? With respect to x-axis. So I can consider any vector in that direction. Magnitude is not a problem. So if I consider a unit vector, if I consider any unit vector in direction of OX, what is that? In direction of OX, the best possible will be I cap. So what will be cos alpha? Using cos alpha, it will be OP dot I cap divide by mod of OP and mod of I cap, that is 1. So what is that? OP dot I cap, so x, it is only x. So x divided by root over x square plus y square plus z square, right? Where alpha is what? Alpha is the cosine of the angle made with respect to x-axis. Similarly, we can say cos beta will be y divided by root over x square plus y square plus z square, and cos gamma will be, this will be z divided by this. So can you see we are getting one relation? Cos square alpha plus cos square beta plus cos square gamma is equal to 1. This is one relation which is very, very helpful. And also, like this is what? This is direction cosine. This cos alpha that we have calculated, this cos beta that we have calculated, cos gamma that we have calculated. What is this? This is called direction cosine. These all are direction cosines, right? Direction cosines. So this cos alpha also equal to L, cos beta equal to M, and cos gamma equal to N. So we can write one relation here also, that L square plus M square plus N square is equal to 1. So if any vector is known, you can write the direction cosine very easily. You just have to divide the coefficient of x, y, z with respect to what? Their magnitude. There is direction cosine. Direction cosine basically, you see, is giving you info about inclination. But what length they are considering? They are considering only unit length of that vector. Okay. Now, if we talk about direction ratio, what? Okay. For this is direction cosine. All these things are, what are these? These are direction cosine for that vector. So now, what is direction ratio? We say, what is direction ratio for any vector? So for that vector OP, if direction cosines are known, okay, direction ratio, suppose if L comma M comma N, this is direction cosine, and A comma B comma C is direction ratio, then the relation between these two is that L by A, or let's say this AL. So A by L is equal to B by M is equal to C by N. That's it. This is the relation between direction ratio and direction cosine. That's all. If ABC is dr of any vector, then this will be proportional with DC. So you're just multiplying that LMN with some constant lambda, right? So it's basically with DC we are constrained that Li, Mj, Nk will give us a unit vector, but with ABC it might be the overall magnitude of that vector also. So very important information, that if any vector P, suppose any position vector OP is x1 I cap plus y1 j cap plus z1 k cap, and any vector OQ is x2 I cap, y2 j cap, z2 k cap. So direction ratio of vector PQ. Now what will be vector PQ? PQ, right? Direction ratio of PQ, what is that? PQ is x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. this vector PQ. So dr of PQ will be the coefficient of their I cap, j cap, k cap, x2 minus x1, y2 minus y1, and z2 minus z1. That's all. This is dr of PQ. This is direction ratio of vector PQ. Right? Anywhere if they ask what is direction ratio of any vector, coefficient of I, j, k. That's all. Okay, that's all. That's all you need to know. X2 minus x1, y2. This is like here for this vector. For this vector, what is dr? Is dr will be x, y, z. Its direction ratio will be x, y, z. What is dc? For dc, just divide by the magnitude. Here, if I want dc, I'll divide this by magnitude. You can put plus minus sign also. Okay, you can just divide by magnitude here. You'll get direction cosine of PQ also. So if we have dc or dr known, then we can always find out angle between vectors. Suppose there is a vector A. There is a vector A, x1 I cap plus y1 j cap plus z1 k cap, and there is a vector B, which is x2 I cap plus y2 j cap plus z2 k cap. So we have vector A and B known, then the angle between. So dr of vector A, what is dr of vector A? Dr of vector A is x1 y1 z1, and dr of vector B is what? Dr of vector B is x2 y2 z2. So we have direction ratio of both vectors known, so we can find out angle between them. So angle between A and B, angle between A and B can be given by, this is cos theta. Okay, cos theta will be the dot of their dr. So x1 x2 plus y1 y2 plus z1 z2 divide by their magnitude, which is root over x1 square y1 square z1 square into root over x2 square y2 square z2 square. This is angle between them. So if they are perpendicular, in that case x1 x2 plus y1 y2 plus z1 z2 will be equal to 0, and if they are parallel, in that case x1 by x2 will be equal to y1 by y2 will be equal to z1 by z2. Okay, that is all. Right. So from the introduction to 3D system, like these all basic results are important. So for DC-dr, this is basic. The coefficient will be dr, and for DC you just need to divide by magnitude. What you need to know? What you need to know is this result also, that cos square alpha, cos square beta, cos square gamma will be equal to 1. So let's solve few problems on this. Okay. So if a unit vector A makes pi by 3, pi by 4 with pi by 3 with I, pi by 4 with j. So alpha is pi by 3. Okay. Beta is how much? Pi by 4. And theta with k. Then what is theta? So this is quite easy. Cos square alpha, cos square beta, cos square what? Cos square, let's say theta, is equal to 1. Alpha with x, beta with y, and with z it is theta. So cos square alpha, pi by 3 is how much? 60. So 1 by 4. Beta, pi by 4, it will be 1 by 2 plus cos square theta is 1. So what is cos square theta from here? 1 by 4 plus 1 by 2 will be how much? This is 2 by 4, 3 by 4. So it is 1 minus 3 by 4. So cos theta comes out to be equal to plus minus half. Right? So it could be how much? It could be 2 pi by 3. Right? If cos theta is negative, cos theta is plus minus half. So for minus half, we have that option 2 pi by 3. Right? Direct based on the DC result. Alpha be the angle between the lines whose direction cosine satisfy the equation. This. Now these type of questions are slightly calculative. So one relation is L plus M minus N is 0, and the other relation is L square M square minus N square equal to 0. Right? L, M, N are direction cosine. So from here we have to generate two different relations, or let's say we can find out here direction ratios also. Like we can find out this L upon something equal to M upon something equal to N upon something, basically dr, so that we can find out that that angle. So let's see what we can do. We can do. So L plus M minus N is 0. So L square plus M square, N square. So N is L plus M. So L square plus M square is equal to how much? L square M square plus 2LM. This cancels out. So guys, we got L into M equal to 0, right? So now from here, there are two cases possible. Case 1, there are two cases possible. Case 1, what if L is equal to 0? So if you put L equal to 0 here, then M will be equal to N. In that case, M will be equal to N, right? So if L is 0, M is equal to N, right? And if M is 0, right? If M is 0, then what we'll get? If M is 0, if you put M equal to 0 here, then L will be equal to N. So how can we write this in terms of something by which we can find out the angle? See, M is equal to N, correct? So if M is equal to N and L is 0, if L is 0, so how can we write this? This is M is equal to N. So M by N is 1 from here, we can say. L is equal to 0, so M by N is 1, right? M by N is 1. So M is equal to N. If you put M equal to N here, right, what we'll get? So this is not going to help. L is always 0, right? So we can do one thing. What we can do? We have this info about L square plus M square plus N square equal to 1, right? We have this info at L square plus M square plus N square equal to 1. So if M is equal to N, from here can we say that M is equal to N will be equal to 1 by root 2, right? And if L is equal to N, then from here we can say L equal to N equal to 1 by root 2. So basically we have two vectors. So from case 1 we can draw one vector as L is 0. So Li cap, Mj cap. So M is how much? M is 1 by root 2. So 1 by root 2 I cap plus 1 by root 2. This is j cap plus k cap, right? And what will be P2? P2 vector will be equal to, this L is equal to N. So 1 by root 2 I cap, M is 0. So 1 by root 2 k cap, right? So if I find cos theta here, so it will be L1, L2, M1, M2, right? So that will be J, this is J K. If I take dot product, so it's only K dot K, right? Rest all is, there is no meaning of that. So it is 1 by 2, it is coming out to be 1 by 2. So from here we can say that theta is nothing but 60 degree. And that is the answer, 6 cos power sine power 4 alpha. So theta is 60 degree, correct? So if theta is 60, so sine 60 will be how much? Sine 60 will be root 3 by 2. So root 3 by 2 to the power 4 plus 1 by 2 to the power 4. Now how much is that? Root 3 square, this is 9 by 4, 9 by 16, right? And plus 1 by 16. So it is 10 by 16. So the answer will be 5 by 8. So the answer is 5 by 8. C. Okay. So L, M, N will bear direction cosine. So we got two cases possible. So from those two cases we derived DC. We derived DC of those two lines. Right. I have just written a unit vector in the direction of that vector. You can see with help of LM. Right. I used this and I found out direction cosines for both the lines and I got the angle. Clear? Guys, so let's start with equation of line now. So to write equation of a line, what exactly we need? So first we'll do vector form. So see, to write equation of a line, just like we had done in a straight line, that we need particular slope and a point. So here we need direction, right? We need direction and a point. So suppose we have a fixed position vector given, vector A, and there is one more point given, vector B. So obviously through two fixed position vectors, suppose this is A and this is B, right? So from two fixed point, a unique line will pass. So A and B are the 2 points given, like this is the first one, 2-point form. 2-point form. So A and B are the two fixed points which are given on that line. These are given. So let's assume a general point R. You can assume R anywhere. Let's say R is the general point here. R is the position vector of a general point. So can I say that any vector like RB, that vector RB will be parallel to vector AB, right? Vector RB will be parallel to vector AB or BA, AB or BA, right? Or we can write, like this also, that vector vector AB will be parallel to vector BR. So what is BR? BR is R minus B. So BR is R minus B. So R minus B will be equal to lambda times AB, which is B minus A. Correct? B minus A. So we can see R is equal to vector B plus lambda times B minus A. This is the equation of straight line in vector form, right? Where what is this B? B is the position vector from which line is passing, and this is the parallel vector. You see, when you do B minus A, so you have framed a new vector. This is B minus A. So this is a parallel vector that we have framed. This is a free parallel vector we have got for this line. So even if two points are not given, if only one point and parallel vector is known, we can write equation of the line. Okay, so here instead of this, we could have written A also, R equal to A plus some mu times B minus A. Right? So this is how we write line in vector form when 2 points are given. So apart from this, we can have one more form. The second one, when a point and parallel vector is known. When a point and parallel vector is known. Parallel vector is known. Right? So say for example, there is a line which is passing through vector A, and it's given that it is parallel to some vector P. Line is passing through vector A parallel to vector P. So you can see, like, this is the parallel vector and this is the point through which it is passing. So we can directly write that the equation of this straight line will be R equal to point from which it is passing and some constant parameter times lambda P. So you will be dealing with these two types of the line, these two forms of the line. Quite simple. The point from which line is passing and the parallel vector. Point, parallel vector. Clear? So moving on. If you write this in Cartesian form, okay, suppose R is equal to A plus lambda P. If I write this into Cartesian form, so what is R? R is basically general point. Let's say this line is passing through point A. Now what is point A? Point A is x1, y1, z1, and it is parallel to vector P, where vector P is equal to something ai cap plus bj cap plus ck cap, right? Parallel vector P, dr is known. So how do we write equation? R will be what? R will be xi cap, because R is a general point, yj cap, zk cap is equal to vector A will be x1i cap, y1j cap, z1k cap, and plus lambda times P vector. So ai cap, bj cap, ck cap. Correct? Now guys, in this equation, if you compare I cap, j cap, k cap, so can you see one thing? If you compare, because ijk are what? Ijk are non-coplanar vector, so we can directly compare the coefficient. It's like written that x minus x1, like x minus x1 minus lambda a I cap plus y minus y1 minus lambda b j cap plus z minus z1 minus lambda c k cap equal to 0. So if it is like that, now can you see that we have sum of these vectors equal to 0, where ijk are what? They are non-coplanar, so they all will be individually 0. So x minus x1 will be equal to lambda a, y minus y1 will be equal to lambda b, z minus z1 will be equal to lambda c. From where we can see we have very beautiful equation: x minus x1 upon a, y minus y1 upon b is z minus z1 upon c. This is the equation of the line, guys. This is how we represent line in Cartesian form. So this is the form now where this is passing through. This is the line which is passing through x1, y1, z1 and parallel dr. this is parallel dr is ABC. These are the two information that you can have from this line. Also, we can always write a general point on this line. Like if I want to write a general point, if I have to write a general point, if I have to write a general point on this line, if I want to write general point on this line, just simply equate it to some value r. So general point will be equal to x1 plus AR, y1 plus BR, and z1 plus CR. Where for different values of r will have different points. For different values of r, you will keep on getting different points. So this was the equation of line in Cartesian form. Then angle between lines. Now this is quite simple. Suppose we have two lines, x minus x1 by a1 equal to y minus y1 by b1 and z minus z1 divided by c1. This is line 1. And line 2 is given by x minus x2 by a2, y minus y2 by b2, and z minus z2 by c2. So if we have two lines and we have to write angle between them, so guys, can we see that this theta angle can be written as like this? This will be angle between their parallel vectors p1 and p2, right? If we are finding angle between lines, we can just basically find out angle between their parallel vectors. What will be that? The cos theta. The angle between lines cos theta will be equal to this p1 dot p2 divided by mod p1 mod p2. So it will be a1 a2 plus b1 b2 plus c1 c2 divided by under root of a1 square b1 square c1 square into under root of a2 square b2 square c2 square. That's all. And if lines are parallel, in that case, what will happen? The drs will be in proportion. Like a1 by a2 will be equal to b1 by b2 will be equal to c1 by c2. If you are dealing with parallel lines, their drs will be also similar. Fine. Moving on. Now angle bisectors. Now this is very, very important, guys. The first part, the first type of angle bisector I am going to teach you when we have both lines passing through same point. Let's say the point of intersection is A. Suppose one line R1 R equal to. You are given two lines. So R equal to something A plus lambda P vector, and the second line A plus lambda Q vector. They are the two lines. Okay. They are the two lines which are given A plus lambda P, A plus lambda Q. For these two lines, okay, this is lambda P. So not only P vector, my bad. So we have direction P and Q, right? And we can see that both are passing through same point, vector A. So if I have to write the bisector, guys, if I want to write the bisector, now this is a bisector, right? There will be two bisectors, right? There are going to be two bisectors B1 and B2. There are going to be two bisectors. So for bisector also, we have that common point A, that these bisectors will pass through point A. Now there is one important information which is sufficient to finish this. That is, if you can form a rhombus, you see, in rhombus the diagonals are what? Angle bisectors. So can I form a rhombus here? I can. What to do? We have vector P here. So get a vector which is unit P cap and get a vector here in the same direction which is unit vector Q cap. Right? In the same direction I got Q cap, in the same direction I got P cap. So once that you have these two, now if I complete this rhombus here, so this diagonal, what is this diagonal then? This diagonal will be the angle bisector, right? The diagonal will be angle bisector, right? So this will be angle bisector, and even if you get this, the other unit vector minus Q cap, now their resultant will give you the other angle bisector, right? So can you see we have got the direction, guys? We have got the direction. So angle bisector B1. If I have to write angle bisector B1, it is R equal to A plus lambda times What is it? What is this diagonal? It is P cap plus Q cap. This is bisector 1 and bisector 2. If I have to write bisector 2, it will be vector R equal to A plus some mu times vector P cap minus Q cap. P cap minus Q cap. Understood? Is that clear? So it's very simple to write bisector. Now here there was one easy thing, that the point of intersection was easily visible, that it is A. In some cases, when point of intersection is not known, we'll calculate it. We'll calculate point of intersection and then we'll go for our calculation. Okay. Suppose if it is something else, if R is equal to something A plus lambda P, R is equal to something B, suppose some vector B plus lambda Q. And for that, if we have to write bisector for these, then what will be our first step? Find point of intersection. Right? Let's say point of intersection is vector C. Rest all will remain same. So the bisector B1 will be equal to R equal to vector C plus lambda times P cap plus Q cap, and the second bisector will be R equal to vector C plus mu times P cap minus Q cap. Now how to find out point of intersection? That is an easy deal. To find point of intersection, there is very simple thing. In Cartesian form, it's easier to find point of intersection. See, if you want to find point of intersection, suppose we have x minus x1 upon a1 is equal to y minus y11 b1, z minus z1 c4, and the second one x minus x2 by a2, y minus y2 by b2, z minus z2 by c2. And for these two, we have to find out point of intersection. So the idea will be write general point for one line and satisfy in the other line. Right? This is the idea, that write general point of on one line and satisfy it with the other one. Satisfy in other line. That's all. That will give you value where the point of intersection. So let's say if I equate it to R. So what is general point here? If I equate it to R, general point, what will be general point here? The general point for this line will be, it will be x1 plus RA1, this will be y1 plus RB1, z1 plus RC1, and I'll put this into the second one. So this will satisfy second line as well. So replace x with x1 plus RA. So x1 plus RA divided by a2 RA1 is equal to y will be y1 plus RB1 minus y2 divided by b2. So just solve this, find R from here, find R, and once you got value of R, you see that will give you find R, you put it here, and you will have that point of intersection. It looks complicated. When I'll solve a problem, it will feel very, very easy. In fact, it is easy. Let's move on. Now, skew lines. Now, you see what is skew lines. So, when we talk about lines in different planes, those are called skew lines. Now, what do we mean? See, we cannot say that two lines will be always lying in the same plane, right? If we talk about two vectors, they are always coplanar. Why? Because vectors are free vectors. We can translate them, right? We can translate. So you draw any two vectors, you can always get them coplanar. But if you get two lines, now obviously you cannot translate line. So there are cases where two lines will be non-coplanar, and those cases are called skew lines. The best way to understand it is from this type of diagram. Suppose I have drawn this system. So let's say this is some axis here, and this is some axis now, and this is the other axis. Where I'm going to show you two skew lines, which were the two lines which are not going to intersect, which are not parallel also, and those are these two lines. You see this line 1, let's call it line 1, and this is line 2, right? Now these two are skew lines. Line 1 and line 2, these are skew lines. These two, will they ever intersect? No. Because these two are completely lying in different plane. So these two lines are not going to intersect at all. Okay, so for such skew lines which are not coplanar, right? For such skew lines which are non-coplanar, for them there will be a shortest distance possible. You see, this is the shortest distance. For these two lines, there will be a shortest distance possible. The shortest distance, that is what we have to calculate for skew lines. Right? For skew lines, there will be always the shortest distance possible along a line which is perpendicular to both L1 and L2. That shortest distance we have to calculate. So let's write equation of the line. So suppose R1 is equal to something, let's say A1 plus lambda P, and R2 is equal to A2 plus mu times Q, right? A1 plus lambda P. So these two are given lines, and we have to write the shortest distance D, right? So obviously if they are skew lines, there will be some valid value of D. If they are not skew lines, D will come out to be 0, right? What are the possibilities? Either they are skew, or they are intersecting, or they are parallel. If they are parallel, it will be always coplanar, right? But if they are skew, they will be non-coplanar. If they are intersecting, they will be coplanar, and in that case D will be 0. So A1 plus lambda P, so here the distance is given by the shortest distance. The shortest distance D is given by mod of, this is A2 minus A1 dot P cross Q divide by P cross Q modulus. Just remember it. A2 minus A1 dot P cross Q. So this is box of that A2 minus A1 P and Q. This is box of A2 minus A1 P and Q. So if you write the lines in Cartesian form, right? If you lines in Cartesian form, this is what? This is vector form. This is vector form, right? Basically, what happens that A2 minus A1. Suppose there is a point A2, there is a point A1 here, there is a point A2 here, right? So we join these two, and then we have taken projection, right? We have taken projection of A2 minus A1 on this vector. And what is this vector? So if I take projection, suppose this vector D. So it is A2 minus A1 dot D cap. And what is D cap? D cap is a unit vector which is perpendicular to L1 and L2 both. So what is that unit vector which is perpendicular to L1 and L2 both? That is it. P cross Q divided by mod of P cross Q. That's all. That's all. That is the shortest distance. Clear? So this is the vector form, and if you would write in Cartesian form, so I hope you can understand that. Suppose lines are x1 minus x1 by a1 is equal to y minus 1 b1 z minus z1 divided by c1, and the second lines, this is the first line, second line is x minus x2 divided by a2, y minus y2 divided by b2, and z minus z2 divided by c2. So if lines are given, we can find out the shortest distance. The shortest distance will be equal to determinant of, it will be x2 minus x1, y2 minus y1, z2 minus z1. Okay, then it will be a1 b1 c1, a2 b2 c2, determinant, divide by under root of the magnitude. So what is it? b1 c2 minus b2 c1 whole square plus a1 c2 minus a2 c1 whole square plus then a1 b2 minus a2 b1 whole square. Right. So it's better to remember in the vector form because that is easier to understand. It's just like we are taking projection and then a whole mod. In the shortest distance result, one more thing you can understand, that we can talk about coplanarity of the lines. So can I say that if lines are coplanar, if lines are coplanar, so there will be two conditions, right? If lines are coplanar, then there will be two conditions. Either they are intersecting, right? So if they are intersecting, in that case, that shortest distance D will come out to be 0. If they're intersecting, shortest distance d will be equal to 0. So what is the condition of lines being intersected? You see this box of, or this determinant, right? This determinant of x2 minus x1, y2 minus y1, z2 minus z1, a1 b1 c1, a2 b2 c2, that will come out to be 0, right? So this is the first case. So if they are intersecting, this can be done. So if lines are coplanar, they will be intersecting, or the second case, they will be parallel. The lines are parallel. So when parallel lines are also coplanar. So for parallel, it's very easy to identify. What is easy to identify? The a1 upon a2 will be equal to b1 by b2, and they will be equal to c1 by c2. So identification of parallel is quite easy, but for intersecting, we have to go by the result. Okay. So if lines are parallel, now there will be one shortest distance possible again between them. Suppose lines are parallel. This is shortest distance d. So let's say this line here is line L1, and that is something a1 plus lambda p, and this is line L2, which is a2 plus mu times p. Right. So you can clearly see that both lines are being parallel to the same vector p. So these are parallel lines. So the shortest distance d, the formula for shortest distance d will be equal to, it is equal to mod of, this is a2 minus a1, a2 minus a1 cross p divided by magnitude of p. That's all. This is the result, guys. a2 minus a1 cross p divided by mod of p, that is the shortest distance. It's quite simple. You can basically form a triangle here and you can show it. Like this is theta, this is the shortest distance, right? It's quite simple. This is a2. Let's say this is a2 minus a1. Suppose this point is a1. This point is a2, right? Sorry, this is a2. So that d is what? The sine component. D is the sine component. That d is a2 minus a1 times. This will be sine theta. So if you replace it here, what is it? Does it what we get? It's quite simple, right? This is the result, a2 minus a1 cross p, the magnitude of that, divided by mod of p. Clear? So we can use the formula directly in questions. Let's start with the problems, guys. The first question here we have vectors A lies in the plane of the vectors this. So the bisector angle between B and C. If A bisects the angle between B and C. Okay. So A is bisecting the angle between B and C. So where is B and C? Okay, B and C are given, sorry. B and C are known. A is bisecting the angle B and C. So what is bisector of B and C? You see, vector B is what? Vector V is I cap plus JK, and vector C is I cap minus J cap plus 4K cap. Right? And A is bisecting the angle between B and C. So if A is a bisector, then A must be parallel to this B cap plus C cap. Right? We can say that this vector A should be parallel to B cap plus C cap or B cap minus C cap. We have just seen through the concept of bisector. So what is B cap plus C cap? If you find out B cap plus C cap, what is that? B cap plus C cap will be equal to, this is by root 2, and this is 16, 17, 18, right? This 16, 17, 18, so 3 root 2. So I cap plus J cap divided by root 2 and plus I cap minus J cap plus 4K cap divided by 3 root 2. So if you take 1 by root 2 common, let's take 1 by root 2 common. So this is 1 by 3, so 3I plus I. 4I cap, 3J minus J, 2J cap, and this is plus 4K cap. Right? So this is one B cap plus C cap. This is how it looks like. So now if I see this A vector, if I simply compare here, so can I say, right, what is vector A? Vector A is AI cap plus 2J cap and plus beta times K cap. right? So from here, can I compare that A upon this will be equal to this upon this equal to B upon this, correct? Right? Can I say that this should be parallel? No, this should be parallel. So can I say that this A can be 4 and beta can be 4? Alpha and beta here. Alpha and beta. This is alpha. So I can say that alpha and beta can be equal to 4 and 4, right? So if they are 4 and 4, for instance, I can assume since they are parallel, no, like B plus C, A is parallel. So here I can play with the magnitude. So I can say that vector A can be equal to, vector A can be this 4i cap plus 2j cap plus 4k cap, right? So does it satisfy? A dot I cap plus 3 equal to 0? No, because here everything is positive. What is the other vector possible? That will be, so this will not give any result. So let's go with B cap minus C cap. Now what is B cap minus C cap? If I subtract here, 3i cap minus I cap, that is 2i cap, right? 3i cap minus I cap, so it is 2i cap. Then 3j cap and minus j cap, that will be 4j cap. 3j cap and minus 4j cap, right? Then this is minus 4k cap divided by root 2. If I take 2 common, so this will be I cap minus plus, sorry, 2j cap and minus 2k cap divided by root 2. So now I can say that this I 2j minus 2k. So this A vector can be, now vector A can be I cap plus 2j cap minus 2k cap. This is quite possible, right? Because we have got direction. Now if you see, A dot k cap will be minus 2, right? A dot k cap will be minus 2 plus 2. So this B will come out to be true. Clear? Excellent question, guys. See, we have done the bisector. So we have idea that either B plus C is going to be there or B minus C. So from there we have seen that B minus C was doing the job, because B plus C was giving everything positive. So that could not be possible. So excellent question. I hope you understood it. Next question. So the equation of the line through the point and perpendicular to the line. Okay. The equation of the line through the point 0, 1, 2. You see, we want to write line from 0, 1, 2, which is perpendicular to the line, which is x minus 1 by 2. This is x minus 1 by 2 is equal to y plus 1 by 3 is equal to z minus 1 divided by minus 2, right? So to write a line, what do we need? We need parallel vector and a point. So to write this line, we have one point 0, 1, 2, but we don't have parallel vector, right? So we can find it out. How? You see, how can we find it out? See, if you want to find out parallel vector for this line, if you want to find out this parallel vector P, right? So see, I can assume a general point. Let's assume a general point on this line. What will be general point? It will be, let's put it equal to R. So it is 2R plus 1, comma, 3R minus 1 and 1 minus 2R. This is a general point. So after getting general point, we'll assume that this point of intersection is the general point. So suppose this is point P, this is point Q. So what is dr of PQ? From here we can calculate dr of PQ. What is that? We'll subtract 2R plus 1 minus 0. It will remain 2R plus 1, comma, 3R minus 1 minus 1, 3R minus 2. Then 1 minus 2R minus 2. So minus 2R minus 1, right? We got dr of PQ. Now we know that dr of PQ and this dr of line, okay, this dr of line, these two are perpendicular. So dot with dr of the line and this will be 0. So take dot, make it equal to 0. If we take dot here, it is 2 into 2R plus 1. That is 4R plus 2. Then plus 9R minus 6. Then minus minus plus 2. So 4R plus 2 equal to 0. So 4, 9, 13, 4, 17. 17R, 9, 4, 13. Yeah, 17R is equal to 2 to 4 minus 2. So 2. So R is coming out to be something 2 upon 17. Very unique thing. 2 upon 17. So if R is 2 upon 17, what will be PR? If you put it there. So this, if R is 2 upon 17, you just put it here. What is it? 2? It's 2 by 17, no? So 4 by 17. 17 plus 4, 21. 21 by 17. Then 6 by 17. Right? 6 by 17 minus 2. So 34. So that will be minus 28. Right? 3 to 6. 6 by 17. 6 by 17. So 7 to 34. Minus 28 divided by 17. And comma. This is minus 2. Minus 4. So minus 21. Umago. This 2 to 4. Yeah. So this is the DR. Now we know that DR can be manipulated. It is just a parallel thing here. So instead of this, guys, instead of this, can I write only, if I divide everything by 7, so 3, comma minus 4, comma minus 3, that's all. This will be the vector. 3, comma minus 4, comma minus 3. Is there any, or. We can write it like minus 3 or 4 or 3. We can manipulate. This is just DR. You write 2, 3, 4, or you multiply it by 2, or you divide it by minus 2. The proportion will not going to change. So you write this or this, it's the same thing. So this is the answer, guys. D is the correct answer. Clear? So what we did, we first assumed a general point, then we took the we used this, the dr of PQ, dr of line. These are what? These two parallel vectors are perpendicular. So dot of their drs will be 0. Here we made dot of drs equal to 0. From where we got value of r, we substituted it back to get dr of PQ, which came something weird. Now again we simplified it by removing that 1 upon 17 and dividing by 7. Clear? I hope you understood. Next point there. So let the position vector and 2 points P and Q be this. So P and Q are given. Let R and S be 2 points such that the direction ratio of PR and QS are given. Okay. Direction ratio of PR. What is PR vector? PR vector is 4i cap minus j cap plus 2k cap, and QS vector is how much? Minus 2i cap plus j cap minus 2k cap. So direction ratio of PR and QS are known. Let lines PR and QS intersect at T. So PR and QS, this PR and QS intersect at T. If the vector TA is perpendicular to both PR and QS, if the vector TA is perpendicular to TA, okay, so let's say this is TA, which is out of the plane. Let me draw again. So this is the plane where we have the intersect at T. This is P, this is R, QS. So this is some point A. Right? Okay. So the lines PR and QS intersect at point T. If the vector T is perpendicular to both PR and QS, and the length of vector T is root 5, then the modulus of a position of A. So we have to find position vector of A, guys. Right? We have to find position vector of A. We have to find position vector of A. Fine. So I think it's simple. It's very simple to write this. It's very simple to find out parallel vector for A, because it's simply PR cross QS. PR cross QS. PR is given 4 minus 1 2, and minus 1 minus 2 1 and minus 2. Okay, this is plus here. So for PR and QS, see, the direction ratio of T can be easily found out. What we have to do here, we need to find T here. And what is T? T is point of intersection of these two lines. So see, what is the equation of PR? What is the equation of line PR? What is the equation of line PR? So line PR equation will be, it is given that it is passing through 3 minus 1 2. So x minus 3 divided by 4 is equal to y plus 1 divided by minus 1 is equal to z minus 2 divided by 2. So this is the equation of PR. right? Because it is P is 3 comma minus 1 comma 2. Point P is given. Similarly, for this PRQS. For QS, we can write the equation. What will be equation for QS? It is passing through 1 to minus 4. X minus 1 is equal to y minus 2 equal to z plus 4. And what are their DRs? DRs is minus 2, 1, minus 2. Minus 2, 1, minus 2. So we have got these two lines. Okay, PR and QS. So T is their point of intersection. T is their point of intersection. So to find T is point of intersection. Let's find out. Let's find out T. T is point of intersection. So let's assume a general point on PR. So general point on PR will be what? General point of PR will be 4R plus 3. General point on PR is 4R plus 3 and minus R minus 1. Minus R minus 1 and 2R plus 2. Right? 2R plus 2. And will satisfy it in QS. Let's put that into QS. This is the general thing for the general process for finding PY. So let's put this into this. So 4R plus 3 minus 1 divided by minus 2 is equal to y is minus R minus 1. Minus R minus 1 minus 2 divided by 1. So we have 4R plus 2 is equal to, this is minus R minus 3. So plus 2R and plus 6, I think, right? Minus 3 minus 2 plus 6. So 4R minus 2R, this is 2R. From here we get R equal to how much, guys? This is the 2R equal to 4. So R is equal to 2. The moment we get R equal to 2, we have point of intersection. So what is point T now? Point T is, put 2 there. So 4 into 2, 8. 11, comma, minus 3, comma, 2 to 4, 6. We got point T. Now the job is still not done. Point A is at what distance? Root 5. Right? And see, this TA we can figure out with help of what? What will be parallel vector for T? Suppose this TA has parallel vector P. What will be P? What will be P? So P will be parallel to this PR cross QS. So PR is 4 minus 1 2. 4 minus 1 2 and minus 2 1 minus 2. Right? I am taking PR cross QS. We have parallel vectors for PR QS. Take their cross. You get vector P. Right? So what is that? Now this is equal to I cap. So this is 2 minus 2. This is 2 minus 2, 0. Minus J cap. This is minus 8 and plus 4. Minus 8 plus 4 will be equal to minus 4. And plus K cap, what is this? 4 minus 2, 2. So guys, we got parallel vector here. What is this? This is 4J cap plus 2K cap. 4J cap plus 2K cap. Now job is still not done. The job is still not done. We need a point at distance root 5, right? So now we can write equation of line TA. We can write equation of line TA. What is that? We have the point of intersection. So equation of TA will be x minus 11 by 0, right? Because that is 0 equal to y plus 3 divided by 4 and z minus 6 divided by 2. So this is equation of TA. Now the next step is up to you. Now you will assume a general point. Okay, you will assume a general point. Let's say general point A. A will be what? If you put it equal to some new value R1. So X will be equal to 11, right? Y will be 4R1 minus 3 and it is 2R1 plus 6. This is general point of A. Now you will equate this distance TA by distance formula. Like 11 minus 11, 0. 4R1 minus 3 plus 3. So 4R1. So this is how much? This is 16R1. Right? If you equate distance formula, so it will be this distance TA is equal to root 5. What is TA square? 4R1 minus 3 plus 3. So what is that, guys? What is that? 16R1 square plus 2R1 plus 6 minus 6, it is 4R1 square is equal to 5. So 20 1 by 4. So R1 comes out as plus minus half. So we got the value of R1. Now what does we want? Position of A. Position of A. The modulus of position of A. So now if this is 11, R1 is 1 by 2. So 11 square is 121. 121. If it is 2, so 122. And this is 7. So 122, 49. This B will be answer. Quite huge. There were so many things to do, but ultimately we got the answer. Because see, this is the thing with 3D geometry. The problems will have always clear-cut steps, clear-cut idea at what exactly you are supposed to do. And this question I'm attempting it for the first time. I had never solved this problem, but you see, I just kept on doing. I just kept with the information going. I got my answer. Clear? So hoping that you have understood everything. It was very simple. First I wrote lines. I found out T. After finding T, I wrote equation of TA. I assumed general point on A. Then I equated distance TA. I got that point A. Clear? This question has taught you a lot, guys. I hope you have understood whatever has been taught here. If the mirror image of the point A69 with respect to the line, now this is the line which is x minus 3 divided by 7 equal to y minus 2 by 5 equal to minus 9. So mirror image, this is the line ka equation. So mirror image, this is minus a minus 9, guys. Minus a minus 9, yeah. So mirror image of a comma 6 comma 9. Okay. So this is a comma 6 comma 9. Mirror image with this line is, so mirror image will be formed at equal distance is 20 comma b minus a minus 9. So their midpoint will satisfy line, right? What will be their midpoint? Their midpoint, see, this is mirror image of the line, so midpoint will satisfy line. What is the midpoint? 20 plus a by 2. Then b plus 6 by 2. Then minus a minus 9. So it is minus a by 2. So this will be on the line. The midpoint of these 2 points will be on the line, correct? Right. So just put it there. So 20 plus a by 2 minus 3 by 7 equal to b plus 6. So b plus 6 by 2 minus 2 by 5 is equal to minus a by 2. So minus a by 2 minus 1 divided by minus 9. You just solve it. You will get a and b from here. Quite simple to solve. You just solve this and this. You will get value of a. So let's solve it. What is it? 2, 3, 6. Right. This is 2 into 3, 6. 20 minus 6, 14. So 14 plus a divided by this 2 into 7 will be 14. Equal to, what is this? This minus a minus 2. So a plus 2 by 18. Right? Because minus sign will cancel out. A plus 2 by 18. So this is 2 into 7, 2 into 9. If I multiply 14 into 9, how much is that? 126 plus 9a is equal to 7a plus 14. So this 9a, 7a, 2a. So 2a is equal to 112. Right? So a is equal to 56. Right? I think with negative sign, right? Negative sign. A is equal to minus 56. Correct? So we got value of a. Similarly, we can get value of b also. So find out b and then find out what is mod of a plus b. Quite easy. The question which are very, very simple. What was the funda? Point and mirror image were given. Their midpoint will lie on the line. The midpoint will lie on the line L. Clear? So we got a. Similarly, by putting value of a, you can calculate for b and then you can find a plus b. Understood? Complete this solution on your own. Are coplanar, right? So if the lines are coplanar, what are the conditions? They are either parallel or intersecting, right? Parallel is not possible. We can clearly see through their DRs. It is 1 to 3 and it is 3 to 1. So clearly they are not in proportion, not parallel. So what is the other case? The other case is that shortest distance D should be 0. So that determinant, remember that. What is that? Determinant of this D2 minus x2 minus x1, or this is k. Like what are the points here, guys? K, 2, 3. What are the points here? Minus 1, minus 2, minus 3. So just subtract k plus 1, 2 plus 2, 4, 3 plus 3, 6. and then there 1, 2, 3 and 3, 2, 1. So this determinant will be equal to 0, right? This determinant will be equal to 0. So what is it? Just simplify. So this k plus 1 into 2 minus 6 minus 4, correct? This 2 into 1, 2 minus 6 minus 4. Then minus 4 multiplied by, this is minus 4, right? This is minus 4 multiplied by 1 minus 6 minus 5, right? 1 minus 9, sorry, 1 minus 9 minus 8, correct? 1 minus 9 minus 8. Then plus 6 times, this is 2 minus 6 minus 4 equal to 0. This is 6 times, this is 2 minus 6 minus 4, correct? So this is minus 4k minus 4 plus 32 minus 24 is 0, guys. So what is it? Minus 4k, 32 minus 4, that will be 32. So minus 4k plus how much? 8, 0. So we have k equal to 1. Quite easy. K is equal to 1. Right? 2021 problem, and the concept was quite simple. Lines are coplanar. That means shortest distance will be 0. Put that equal to 0. You will have your answer. Moving on to next question. The shortest distance between the straight lines is 1 by root 3. The value of lambda is equal to. So it's just about writing the formula properly. So write line L1. What is it? X minus 1 divided by 1 by 3 is equal to y. Remember, whenever you write line, you have to write line in its proper form. X minus x1 by a, y minus y1 by b, z minus c. Coefficient of x has to be equal to 1. Coefficient of y has to be equal to 1, z has to be equal to 1. The constant you have, the coefficient you have to make equal to 1. Rest all can be adjusted. Y minus 2 by 1 by 6 equal to z minus 1 divided by 1 by 2. So since 1 by 3, 1 by 6, 1 by 2 look very bad for calculations, so we'll rewrite. Just multiply everything by 6. So this is 2. Because these are DRs, they are in proportion. They should be in proportion, which is fulfilling, equal to z minus 1 divided by 3. So this is line L1. Okay. This is line L1 in better form. Similarly, line L2 also we can write. What is L2? L2 is x minus 2 upon 1 by 4 equal to y minus lambda divided by 1 by 2 equal to z minus 3. So again, this 1 by 4, 1 by 2 looks very bad for calculation. Make it beautiful by multiplying by 4 by all the terms. So x minus 2, this will be 1, y minus lambda by 2, and z minus 3 divided by 4. Now it looks fine for our calculation. It is L2. So we got L1 and L2. What is given? The shortest distance is given 1 by root 3. So apply the formula. Apply the formula. So apply the formula. So first say what is P1? Here what is P? So vector P will be 2i cap, 3j cap, sorry j cap, 3k cap, and vector Q. So vector P is basically P is parallel vector for line L1 and Q is parallel vector for line L2. So Q will be what? 1, 2, 4 I cap, 2j cap, 4k cap. So I'm finding P cross Q first. I'm finding modulus of P cross Q. What is modulus of P cross Q? To calculate it, modulus of determinant. This is ijk 2, 1, 3, 1, 2, 4. Right? So that is mod of. This is 4 minus 6. 4 minus 6. Minus 2 I cap. Minus j. 8 minus 3. Minus 5. So minus 5 k cap. Sorry, j cap. Right? 8 minus 3 and plus k cap. This is 4 minus 1, 3k cap. So the modulus is coming out to be 25, 4, 29, 38. Right? This is I cap 2, 1, 3, 1, 2, 4. So, right? 1, 2, 4. Yeah. So this is I cap 4 minus 6 minus 2 I cap, j cap 8 minus 3 minus 5. Okay, 2 to 4 minus 1, 3. So 4, 25 plus 4, 29. And 29, 3 square, 38. So root 38 is the mod of P cross Q. Root 38. So what is next? What is next, guys? So we need integral value of lambda. So I think now you can calculate what is it? the determinant of x2 minus x1. So this is 2 minus 1, 1, lambda minus 2, 3, 3, minus 1, 2. Then 2, 1, 3, divide by 2, 1, 3 divided by 1, 2, 4. Divide by root 38 is equal to, it's given 1 upon root 3. So from here you have to calculate. I think there has been some calculation mistake, guys. I don't know what is that. So you just see from your, or see on your own, x minus 1 by 1 by 3, y minus 2 by 1 by 6, z minus 1 by 2. So if I multiply by 6, 2, 1, 3, 2 lambda and 3. 1 by 4, 1 by 2, and this is 1. So 4, 1, 2, 4. Okay. So 2, 1, 3 and 1, 2, 4. 2, 1, 3, 1, 2, 4. So take I cap, j cap, k cap. So 4 minus 6 minus 2, 8 minus 3, 5, 3. So I think the rest calculation I'm leaving up to you. You see, there might be some data error. Otherwise, this root 3 should have been cancelled out. So just try to understand the logic. Okay, maybe some number is missing here. 4, 2. Maybe some number is missing here, because this root 3 should be cancelling if you want integral value of lambda. Fine. So I'm moving to the next problem. I hope the idea is clear, guys. This was the main thing which I wanted to teach here. This thing, that if you are dealing with lines, make sure that you write this in proper symmetrical form, right? In proper symmetrical form. You don't deal with these forms. No, don't deal with these forms. If you have got equation of line, you are supposed to write them in proper form first, and then you are supposed to do your calculation. Understood? Okay. The same problem, the shortest distance between the lines is 9, then alpha is equal to. So here again we have P and Q. What is P? P is 1 I cap minus 2j cap plus 2k cap. And what is the other parallel vector Q? It is 3i cap minus 2j cap minus 2k cap. So let's find out mod of P cross Q first. So mod of determinant ijk. This is 1 minus 2, 2, 3 minus 2 minus 2. Right, so determinant of what is it? I cap minus 4, right? This is minus 4 and plus 4. This is 4, no, only plus 4. 4 and plus 4, 8. So 8 I cap, right? 4 and plus 4, right? Then j cap minus 2 and minus 6, minus 8 j cap, then plus k cap. So this will be plus 8 j cap, no? Because minus is already there, minus 2, minus 6, k cap, minus 2 and plus 6, minus 2 plus 6, 4, 4k cap. So that is what? Take 4 common. So it is 4 into under root of, this is 2, 2, 4 plus 1, right? So 3, 12. So 12 is the modulus here. Mod of P cross Q, beautiful value 12, small beautiful value 12. Now you can find out shortest distance. What is it? What is it, guys? This is A2 minus A1. So it is minus 4i minus k. What are the points here? R1 points are like point A1. A1 is something alpha, comma 2, and A2. What is A2? A2 is minus 4, J is 0, minus 1. So A2 minus A1, what is the formula? A2 minus A1. So determinant of A2 minus A1. Or A1 minus A2 is also fine. So alpha plus 4, 2, 2 plus 1, 3, then 1 minus 2, 2, 3, minus 2, minus 2, right? So this determinant divided by the magnitude 12 is given how much? Is 9. So just simplify it, you will have value of alpha. And obviously there is one more modulus because this is distance. This is distance, so I am keeping one more modulus. So this is equal to 9. From here you solve it, you will have value of alpha. Clear? Again, so lines question related to distance are calculative. Don't get confused that, sir, do you always need to do calculation? Yes, you have to. You have to calculate like this always. Are coplanar. So just I'm telling you the value, guys. I'm telling you the logic here. What is it? The lines are coplanar. So write them in proper form. x upon 1 is equal to y minus 1 upon a divided by 1 by a, right? Because I'll take common a, y minus 1 by a, and this a will be numerator 1 by a, equal to z minus 2 divided by 1. This line L1, whatever line 2, x upon 1 equal to y minus 2 by 3 divided by 1 by 3 equal to z minus 2 by b divided by 1 upon b. So this is line L2. What is being said? The lines are coplanar, right? The lines are coplanar. So one case possible is what? They are parallel. So if I consider case of parallel, so 1 by 1, so 1 by a will be equal to 1 by 3. So a will be equal to 3, and 1 by b equal to 1. So that case is not there, right? So the other case, the shortest distance d will be equal to 0. So shortest distance, so determinant of a2 minus a1, 0. Then a2 minus a1, so 2 by 3 minus 1 by a. 2 by 3 minus 1 by a, and then 2 by b minus 2. Then this will be 1, 1 by a, 1, 1, 1 by 3, 1 by b. This thing should be equal to 0, right? This thing should be equal to 0. So from here you will have some relation in a and b, and then you can easily calculate from here, right? You just simplify this determinant and you will have some value from here. Like whatever is you have these options given, try to check with these options. You can calculate easily. Or if you feel that here you are facing some difficulty, you can instead of doing this, if you are feeling that this calculation might be difficult, so you change it. You don't keep it like this. Let me write a better version here. Instead of calculating like this, I told you initially that 1 upon something looks bad for calculation. So you can rewrite this. You can write x, let's multiply everything by a. So x by a, y minus 1 by is 1, z minus 2 by a. Now it is easier for our calculation. It's easier for our calculation, right? Equal here, multiply by b. X upon b, 3b. X upon 3b. So y minus 2 by 3. If I multiply 3b here, only b will remain. And z minus 2 upon b divided by 3, right? So for them, the shortest distance is how much? 0, because they are coplanar, because there is no scope of them being parallel. So determinant of, what is it? 0, right? 0. Then 2 by 3, 1 by a. 2 by 3 minus 1 by a, and 2 by b minus 2. 2 by b minus 2. Then now this is easy to see. A1a, 3b, b3. This is 0. So simplify it, and then just from the options you can check for a and b. It's like you have one equation, two variable. So whenever this case is there, one equation, two variable, we have to go for directly options, right? We can just check the value, which one is satisfying there. Clear? Okay. Like here, the direct substitution is not helping. Like a equal to 1, if I put a equal to 1, b equal to 2. No, it is not working. A equal to 2, b equal to 3. No, this will also not work. So you have to, the parallel case is not working, so we have to go for that. The shortest distance d equal to 0. This skew case will help here. So put that thing equal to 0, and then you can solve for AB. Okay, moving on to next problem. Solve this question now. So question is here, the foot of the perpendicular from the point on the line is 357. Then the shortest distance between the line L1 and L2. Okay, so in L1 you can see alpha is the variable. So see, foot of perpendicular is given 4, 3, 8, and from here foot of perpendicular, right? What is that? It is 357. Foot of perpendicular from the point 438 on the line L1 is equal to 357. Okay, so what is the line ka equation? It is x minus alpha by 1, y minus 2 by 3 is equal to z minus b by 4. So this question is all about finding this alpha a and b here, right? If we can find out a and b, then we can find out the shortest distance, because L2 is already known, right? L2 is already known. So to find out a and b, first of all guys, this point is lying on that, this point is satisfying that line. So 357 will satisfy equation of line. So put it there. So 3 minus a upon 1 is equal to 5 minus 2 by 3 is equal to 7 minus b by 4. So from here we have 3 minus a is equal to how much? 1 is equal to 7 minus b by 4. So we got a and b, guys, right? 3 minus a is 1. So we have a equal to 2. And 7 minus b is equal to 4. So b equal to 3. So we got value of a and b. Quite easy, because if it is put up perpendicular, obviously that will lie on the line, right? So this 438 was having no use at all. I don't know why they had given. So that is all. That is all for this. So now we have line L1. Line L1 will be x minus a is 2. So x minus 2 is 1, y minus 2 by 3, and z minus b is 3 by 4. So this is L1 and L2. What is L2? L2 is x minus 2 by 3 is equal to y minus 4 by 4 is equal to z minus 5 by 5. So now you have sufficient information. You can use the formula and you can find shortest distance. I'm leaving calculation up to you. I don't have time for calculation because the lecture is already too lengthy. So you got L1, L2. This question was only about finding a and b, that I have done for you. You use the formula, get the answer. Clear? Quite simple problem from 2021. If for some alpha, the line L1 and line L2 are coplanar. So there were so many problems from coplanarity. You see, coplanarity we have done. We have done it either parallel or what? Either lines are parallel or they are skew. Sorry, if they are intersecting, either parallel or they are intersecting. So here, see, if I choose the case of parallel, case 1, if they are parallel. If they are parallel, okay. So if they are parallel, so alpha upon 2, just make those coefficient this drs in proportion. So alpha upon 2 is 5 minus alpha upon minus 1 is equal to 1 upon 1, right? Alpha upon 2, 5 minus alpha upon minus 1 is equal to 1 upon 1. So do we have equal value of alpha from there? So from here, if from this and this, we get alpha equal to 2, and from this and this we get 5 minus alpha is equal to minus 1, so alpha is equal to 6. So clearly we don't have a common value of alpha, so this case will not be true, right? We are getting different set of alpha for different ratios, so this will not hold true. This is wrong. So the second case we'll do is for intersecting. And what do we mean by intersecting? The shortest distance d will be 0. So the box of a2 minus a1 p q will be 0. So what is it, guys? What is a2 minus a1? This is minus 2 minus 1. So it is minus 1. Minus 1 minus 3 minus 1 and again minus 1 minus 2. Right here point is what? Point is minus 1 comma 2 comma 1. And what is point here? Minus 2 minus 1 minus 1. So if you subtract minus 1 minus 3 minus 2 and then 2 minus 1 1 alpha 5 minus alpha 1. This determinant is 0. So now calculation is up to you. Calculate it. Just put this determinant it equal to 0. Calculate alpha. You will have your answer. Fine. Let's start with the next topic now, which is planes. Obviously from 3D geometry you have only these two things in detail, that is line and plane. So line problems you have seen, quite simple. Some questions were calculative, but mainly it is revolving about intersection of two lines or coplanarity. So all the types of question we have covered. Every type which has been asked there in JEE main we have covered it. So now we'll be covering equation of plane. See, plane there are so many forms given in different textbooks. I don't know what is the need. You see, for plane there is only one thing which is sufficient for any type. The most basic thing, to write equation of a unique plane, we need a point, a given point, and a normal vector. A normal vector, that's all. That's all we need. That's all we need. Just keep it in your mind. To write equation of a plane, what do we need? We need any one point on that whole plane, and we need a perpendicular vector, a normal vector for that plane. So this is sufficient, right? Only these two are required. If these two are not given, something else data is given. From that data, we'll try to figure out what is that fixed point, what is that normal vector. But there is no like thousand of varieties here. Every single form of the plane has been derived from here. If you have this thing in mind that only a point and normal vector is needed, you can write every time equation of plane easily. Just keep in mind you have to look for point, normal vector. So let's write this first in vector form. So let's say this is a general point R here, right? Right. So what do we require? What is required? What is required here? Required is a point, a position vector, and normal. And point is required and normal to plane is required. That's all. Every time. The required information is only one point and normal to plane. These two. Okay. For now here, you see, we have been given point is A and normal vector is N. Like normal vector is N. So can I say that if I make a vector R minus A, so this R minus A, now this will be a free vector. So if you put it here, clearly R minus A and N will be perpendicular. R is the general point on that plane. So R minus A dot N vector will be equal to what? 0. That is all. Finished. That's all. This is what you have to remember. Nothing else. Nothing else. If you have a fixed point, if you have a normal, R minus A dot N equal to 0, that will give you locus of R, which is the plane. Okay. So in Cartesian form, this is a vector form in Cartesian form. Let's say R is a general point, xi cap, yj cap, zk cap. A is a known point, let's say x1 I cap, y1 j cap, z1 k cap, and normal vector N is something A or let's say capital A. So normal vector is capital A, ai cap, bj cap, ck cap. So what is R minus A? X minus x1 dot N. So it will be A into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. That is all. Every time if they tell you to write equation of plane, only this information is sufficient for you. One point and one normal vector. Just figure it out from anywhere. Whatever data is given from that, extract the required part, which is a general point and a normal vector. Clear? So now there can be some other forms of plane. So the other forms of plane can be something like this. Like this is called the intercept form. Intercept form. Let's say the plane is cutting intercepts. Suppose this is the axis, right? And there is some plane which is cutting some intercepts. Let's say on x-axis, the length of intercept is a comma 0 comma 0. The length of intercept is b on y-axis, and length of intercept is c on z-axis. Like these are the lengths. So we have 3 points, right? So it's like we have 3 points. So from 3 points, how do we write a plane? How do we write a plane from 3 points? Obviously, if we have 3 points, guys, suppose if we have 3 points in the plane, if we have 3 points, right? So what do we need? Suppose we have 3 points, something A, B, C. If we have 3 points in the plane A, B, C, and we have to write equation of plane, our job is done, right? We can use any one point because it's 3, and we need a normal vector. No, that's all. B minus A, B cross C. Their cross will be what? Perpendicular to the plane. This is a normal vector. You have 3 points. From 3 points, frame any 2 vector, take their cross, that will be perpendicular to the plane. We got normal vector also. So by this calculation, the form that we derived is quite interesting. X by A plus Y by B plus Z by C equal to 1. This is the form which we derive. And guys, what is this? This is something what you can relate with straight line. And there are so many results in the plane that you can relate with straight line. Okay. So this is the intercept form of the plane. Intercept form of the plane. Right. So from here I explained you this thing also, that if we have 3 points given, what you can do, you only need to find a normal. What is that? Frame any 2 vector, like here normal for the plane. Normal for the plane will be equal to, it is simply B minus A cross B minus C. If you have 3 position vectors given, you can find normal. point is known already. Understood? Every single time. I am not going to explain like 1000 forms. Every single form, whatever information is given, I can write. Now suppose a plane is given, right? A plane is given. A plane equation has to be written, and this time what is given? We have been given suppose this plane is parallel to two vectors, right? Vector p, vector q, right? And there is a point known a. So can we write equation of this plane? This plane is parallel to p and q, and we have a one point also given. Easy, right? What to do? So suppose this is plane and this one vector, the other vector, right? It's like this. It's like this. See, right? Suppose this is the plane ka equation which we have to write, and here we have two parallel vectors, something p and q. So it's clear that if I take cross of that, it will be perpendicular to the plane. So if I take p cross q, guys, if I take p cross q, now that p cross q will be the normal for the plane. Job done. What is it? We needed point. The point is already known. Point is that vector A. And what is the normal vector? Normal vector. That normal vector n vector is equal to what? That n vector is equal to p cross q. So that's it. This is what we are supposed to do when we have different informations given and we have to extract the required part every time. 3 points, plane passing through 3 points, plane passing through a point and perpendicular to that. Or if we have a parallel plane given, suppose if two parallel planes were given, then what you do? If parallel planes are given, then obviously they both will have same parallel vector, right? Normal vector. We can use the normal vector for the other plane for the other the required plane also. So this is what you are supposed to do. Now by now you are well versed with so many properties of the DRs, direction ratios. You know that if you have two parallel planes, obviously they will have same parallel vector for the normal. They have same normal vector. So that's all. You will have give point. You can find normal vector. You can write equation of plane. Whatever is given, you are sufficient now to write equation of plane. Okay. So how to find out angle between planes? You see, if we have this. Now some of you, sir, you are not teaching that normal form of the plane. Why not required? This is crash course. In the normal form, what do you do? In the normal form of plane, you find out distance of plane from origin, right? Guys, just to avoid any confusion, let me write normal form of plane. Now, normal form of plane, this is normal form of plane. So, if it is r dot n cap equal to some value d, if plane is written in this form n cap, then d is distance of origin, d is from plane. This is called normal form. This is called normal form of plane. R dot n cap equal to n cap, not n. You see the first thing here we did, it is r dot n, right? Here if you expand it further, it is r dot n vector is equal to a dot n. So let's say a dot n is something d. So this is r vector is equal to d. But here it is r dot n cap. So when r dot n cap is d, this d will be distance of origin from plane. Now we have a direct formula also that will do. So if just to avoid any confusion. So if you have to find angle between planes, okay, let's say this is plane 1 and this is plane 2. So suppose these are intersecting like this. So what to find? This is the angle between them. So to find out angle between these planes, basically we are supposed to find out angle between, suppose this is theta. So we'll find out angle between their normals. This is theta, right? If you have to find angle between planes, we'll find out angle between their normals. So suppose plane 1 is a1x plus b1y plus c1z plus d1 equal to 0, and plane 2 is a2x plus b2y plus c2z plus d2 equal to 0. So we have these two planes known and we have to find out angle between them. So angle between planes means angle between their normals. What will be cos theta? It will be dot product of their drs. So it will be a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square b1 square c1 square into a2 square b2 square c2 square. This is cos theta. Quite simple. If planes are perpendicular, this will be 0. Planes are parallel, their a1 by a2 will be equal to b1 by 2 c1 by c2. Okay, easy. Then also angle between line and plane. See, this is slightly different. This is slightly different. Suppose we have a plane here, right, and this plane is getting intersected by some line. This plane is getting intersected by some line here. This line is intersecting this plane. Okay, so this plane is intersecting. So suppose the equation of line is x minus x1 upon a is equal to y minus y1 upon b, z minus z1 upon c. This is equation of this plane line, and the equation of the plane here is ax plus by plus cz plus d equal to 0. Right. So this is the normal for plane, right? And we need angle between line and plane, guys. So if this is theta, this is the required angle. So what is the angle between normal vector and the line? It is pi by 2 minus theta. Can you see that? Theta is the required angle, which is angle between line and plane. But pi by 2 minus theta is the angle between normal and line. It's very easy to calculate. We can calculate this pi by 2 minus theta very easily. What is that? Just use the dot formula. Like cos pi by 2 minus theta will be equal to what? There is their dot product, like AA plus BB plus CC divided by under root of A square B square C square under root of A square B square C square. That's it. So cos pi by 2 minus theta is what? Sin theta. Right? This sin theta is equal to, so in all the results, in all the other results, it is cos, but this time it is sin theta. That is the only difference you should know. If line is parallel to plane, in that case, what will happen? If line is parallel to plane, guys, now here will be sin theta. So sin theta will be 0. So AA plus BB plus CC will be 0. And if line is perpendicular to the plane, so you can imagine if line is perpendicular to the plane, so obviously the normal and those will become parallel. So if line is perpendicular, then A upon A, B upon B, and this will be proportion. These three will be in proportion. Clear? I hope these all informations are making sense to you. These are things. Now you see there are so many results in 2D that are exactly same. We can relate them with the 3D plane also, right? Starting with the position of point. Position of points. Starting with position of points. I'm just going to write the result, right? So suppose there is a plane A1 AX plus BY plus CZ plus D equal to 0. Okay. And there are 2 points P X1 Y1 Z1 and Q X2 Y2 Z2. So if you remember results for straight line, no, you can easily write them here for these system also. Straight line, what used to happen if we put those points into the equation of line, product positive, same side, product negative, opposite side, exactly same thing here. If this is the plane, right? So put x1. So if ax1, by1, cz1 into d into put second point ax2, by2, cz2 plus d. If this product is greater than 0, first is greater than 0, they will be on same side. And the second part, if this product is less than or equal to 0, it will be opposite side. Just like line. Guys, there are so many results I am going to write, and these all will resemble this straight line result. So there should not be any doubt at all. Then second result, I'll write perpendicular distance. Perpendicular distance. Perpendicular distance of one point x1, y1, z1 from the plane, from plane ax plus by plus cz plus d equal to 0. Remember the formula of straight line? Almost same. Just include the d part also. It will be ax1. So that perpendicular distance is ax1, by1, cz1 plus d, and divide by a square plus b square c square also. That's all. This is the perpendicular distance formula. Fine. Then the third result, foot of perpendicular. Foot of perpendicular, right? So for the plane ax plus by plus cz plus d equal to 0, we have to find out foot of perpendicular for the point x1, y1, z1. So let's say this is foot of perpendicular, alpha comma beta comma gamma, right? This alpha comma beta comma gamma is foot of perpendicular, right? Alpha comma beta comma gamma is foot of perpendicular. So how to find out that? The formula is exactly what you had written. What is it? Alpha minus x divided by a is equal to beta. Alpha minus x1 is equal to beta minus y1 divided by b is equal to gamma minus z1 divided by c is equal to minus times. Just put those points. So ax1 plus by1 plus cz1 plus d divided by a square, b square, c square. So this is the formula. Exactly what you had remember in straight line, right? So with foot of perpendicular, the same result, guys, is for image also. Like image of x1, y1, z1 in the plane. And the same plane ka equation I'm going to write. So it will be, let's say image here. Let's say image here is something new. Let's say image here is xi, yi, zi. Right? Xi, yi, zi. So one thing that foot of perpendicular will be midpoint. Alpha, beta, gamma is midpoint, or the formula is that xi minus x1 divided by a, yi minus y1 divided by b, zi minus z1 divided by c is equal to minus 2 times ax1 by1 cz1 plus d divided by a square, b square, c square. And mind it, all these results are going to be very, very handy while solving problems of the plane, right? Image of the plane. Then there are a few more. Distance between parallel planes. Distance between parallel planes. Right, distance between parallel planes. So parallel planes, suppose we have ax plus by plus cz plus d1 equal to 0, and the second plane is, obviously the planes are parallel, they will have same dr or proportional dr. So for distance between these two, d is given by mod of d2 minus d1 divided by a square, b square, c square under square root. That's all. This is the formula for distance between parallel planes. You okay? Moving on to the problems. Now guys, before that, there is one more result which I want you to remember. The bisector plane. Suppose if you write bisector for a1x, b1y, c1z plus d1 equal to 0, and the other plane is a2x, b2y plus c2z plus d2 equal to 0. So the exact same logic what we had in straight lines. It is a1x plus b1y plus c1z plus d1 divided by, it is a square, a1 square, b1 square, c1 square under root is equal to plus minus a2x, b2y, c2z, d2 divided by under root of a2 square, b2 square, c2 square. So if you calculate it, no, you will get what you need, right? And if you want to understand like which one is obtuse or acute, in case of planes, it's very simple, because you will have idea, no, at what is the exact angle between them. And the other logic is that in straight line we used to find out a1, a2, b1, b2. Here also you will find out a1, a2, b1, b2, c1, c2 also. So the sign of a1, a2 plus b1, b2 plus c1, c2 will be of obtuse bisector. That's all. whatever is sine of A1, A2, B1, B2, C1, C2, A1, A2 plus B1, B2 plus C1, C2, that will be sine of obtuse bisector. Follow that. You can write acute and obtuse simultaneously. We'll start with the questions now. So in this question, you see, we have to find out equation of plane parallel to the plane, which are at unit distance from the point 1, 2, 3. So if we have to write equation of plane which is parallel to this, it will be x minus 2y plus 2z plus some constant d equal to 0. And it's given that the distance of point 1, 2, 3 from this, the distance is given unit 1. So 1 will be equal to, put the points, 1 minus 4, right, plus 6 plus d divide by, then under root of, this will be 1 plus 4 plus 4, correct? 1 minus 4 plus 6 plus d. So 6 minus 4 is 2, 3. So modulus of d plus 3, guys, will be equal to how much? 6 minus 4, 2. This is 4 for 8, 9, 3. So d plus 3, if you remove mod, either is 3 or minus 3. So d is minus 6 or 0. So we have two possibilities. X minus 2y plus 2z equal to 0, or x minus 2y plus 2z minus 6 equal to 0. So these two are the possibilities. So positive values of k. So now you can figure out what is your answer. We have got it. B minus d, right? So you can compare now ABCD, right? You can compare ABCD and with the both planes, P1 and P2, and then you can figure out your answer. You see, the question is given positive values of k. So obviously there will be only one case. So you can calculate it. Next question. Let the acute angle bisector of the two planes be the plane P. Then which of the following points lie on P? See, acute angle bisector. So what is sine of A1, A2? What is sine of A1, A2 plus B1, B2 plus C1, C2? The sine of this will be the sine of obtuse bisector. So what is A1, A2? A1, A2 is 1 into 2. Then minus 2 into minus 3 is plus 6. And minus 2 into minus 6 is plus 12. So it is positive. So this is positive. So for acute, so this will be for obtuse. You see A1, A2, B1, B2, C1, C2 is positive. So acute will be, we want acute or obtuse? Yeah, acute. So acute will be with negative sign. Acute will be with negative sign. So what is it? X minus 2y minus 2z plus 1 divided by 3 is equal to negative of, this is 2x minus 3y minus 6z plus 1 and divide magnitude. This is 36, 945, 449, this is 7. So 7x minus 14y minus 14z plus 7 is equal to minus 6x plus 9y, right? And plus 18z minus 3. So 13x, 14y, 9y minus 5y, right? 14y, 9y minus 23y, no? Minus 14z minus 32z and plus 10 equal to 0. 13x, so you can check which one is true, right? From the options you can check 13x, 23y, 32z plus 10 equal to 0. Clear? Okay, so let's solve next question here. So let the plane is passing through the point minus 1, 0, minus 2 and perpendicular to the two planes. Okay. So see, the plane, the required plane P is perpendicular to two given planes. Let's say there is one plane and then we have the other plane, something like this, right? Let's call it P1, P2. So P1 and P, these two are perpendicular to the plane P. Point is given. So we need normal, right? Point is known, 1, minus 1, 0, minus 2. So somehow we can get, if we get a normal, job will be done. So it's easy, right? This is P1 ka normal. This is P2 ka normal. So their cross will be what? Their cross, right? The cross of normals of P1 and P2, guys, will give you the normal for our plane P. Can you understand it from the diagram? Right? P1 normal, P2 normal. So their cross of them will be 100% the normal for our plane P. So what is N? So that N is basically N1 cross N2. What is that? It IJK N1. What is that? 2, 1, minus 1. and then 1, minus 1, minus 1. This is I cap. This is minus 1, minus 1, minus 2. Correct? Minus 1, then minus 1. Then minus j cap. This is minus 2 and plus 1. Minus 1. And plus k cap. This is minus 2, minus 1, minus 3. I hope I'm right. Okay, this is minus 2, minus 3, j, minus 2, plus 1, minus 1. And I is right. So, minus 2i cap, plus j cap, minus 3k cap. Right? So, this is what? This is the normal we got. Point is also known. Write the plane ka equation. So, it is x plus 1 multiplied by minus 2. Then, plus 1 into y minus 0 and then minus 3. Minus 3 into z plus 2 equal to 0. So, what is it? Minus 2x minus 2 plus y minus 3z minus 6 equal to 0. So, if I take negative sign common, so 2x minus y plus 3z plus 8 equal to 0. And that is what is given, right? So, if we compare what is A is 2, A is 2, B is minus 1. We have A is 2, B is minus 1, C is 3. 3 to 5 minus 1, 4. The answer is 4. Quite simple, and this type of questions have been there in so many times. That plane is parallel to two given planes. So what to do for normal? Take cross of their normals. That will be the required normal for plane. Next question. Equation of the plane which contains the y-axis and passes to the point 1, 2, 3. Nice. See, y-axis is contained here in the plane. So y-axis dr will be what? The dr for y-axis will be? The dr for y-axis will be 0, 1, 0. Right? The dr for y-axis will be 0, 1, 0. So let's say equation of the plane. Right? The equation of the plane is something ax plus by plus cz plus d equal to 0. So let's say this is the equation of plane. Right? And the equation of the plane, this is passing through the point 1, 2, 3. The plane is passing through the point 1, 2, 3 and it contains the entire y-axis. So we have multiple ways. See, we can assume any 2 points on the y-axis and we can generate those. Okay, this is the easier way. Like since entire y-axis is contained, so can I say that write any 2 point on y-axis. So let's say 0, right? 0, 1, 0 will be 1 point, then 0, 2, 0 will be the other point. So we can generate 2 vectors from here. Let's say this is something vector A and vector B. Right? So what will be vector A? Let's say vector A will be what? Vector A will be I cap 1 minus 0 I cap 2 minus 1 j cap 3 minus 0 plus 3k cap. Right? 1 minus 0 2 minus 1, and let's say vector B is 1 minus 0 I cap plus 2 minus 2. This is j cap is 0 3k cap. Right? Something like this. So now A cross B, the normal will be what? Normal will be A cross B. Right? This A cross B will be the normal for the plane. What is that? I, J, K, 1, 1, 3, 1, 0, 3. So what is I cap? I cap into, this is 3 minus J cap into, this is 3 minus 3, it is 0, and plus K cap into, what is it? 0, minus 1, minus 0, minus 1. That's it. This is 3i minus k cap. This is the equation. What? This is the what? This is the normal 3i minus k cap. Now it is passing through 1, 2, 3. What will be equation now? What will be equation? So 3 into x minus 1, y part is 0. So minus 1 into z minus 3 equal to 0. So 3x minus z equal to 0 will be the equation of plane. This is the answer. Right? Choose wisely. Choose points easily. Right? We knew that y-axis is entirely contained. So I assumed 2 points on the y-axis. I framed 2 vectors. I took their cross. That gave me the normal vector n. That's all. Job done. Easy. Very, very easy. Next question. Next question. Suppose the line lies in the plane. Then okay. So the line is lying in the plane. Then you see what is general point here? General point. General point on the line. See what happens if the line is completely lying in the plane. Suppose this is the line which is lying in the plane, and this is the normal vector. So first of all, the parallel vector for the line and the normal vector will be 0. The dot will be 0. And every point of the plane will be contained in the, every point in the line will be contained in the plane. We can get beta very easily because you see, general point on line. So leave the general point. Can we say that the point here, what are the points, guys? The point which line is satisfying is 2, 2, minus 2, correct? 2, 2, minus 2. So this point will satisfy plane also. Will satisfy plane. Put it there in the plane. Patak the plane. So 2, 3, 2, 6 and minus 2z. So plus 4. So plus beta equal to 0. So we have beta values now. So what is beta? 4, 6, 10, 10 to 12, minus 12. We got value of beta. Once we got value of beta, now use the other one, that n dot p will be 0. N dot p will be 0. The parallel vector for the line and for the normal of plane will be 0. What is that? This is alpha I cap. What is normal, guys? 1, 3, minus 2. Normal is I cap plus 3j cap minus 2k cap. This is the normal for plane. Dot, what is p vector? It is alpha I cap minus 5j cap plus 2k cap is 0. To solve it, so alpha minus 15 minus 4 equal to 0, we get alpha equal to 19. So we got alpha and beta both, right? Alpha plus beta you can find out. What is this? 7. Next question now. The equation of the plane passing the point and perpendicular to the plane. So guys, so we already have done, right? What we need, the normal vector will be what? The normal vector of the plane will be cross of their normals. I, j, k, 3, 1, minus 2. 3, 1, minus 2 and 2, minus 5, minus 1. So this will be the normal vector of the plane. Point is also known. So you can write equation of the plane. Correct? We have done the similar problem already. So I am not doing the entire calculation. Point is known. We already have this normal by taking cross with these normals n1, n2. Job is done. Next question. So let the line L be the projection of the line in the plane. Okay. Projection of the line. So suppose this was the line. So if you take its projection, so basically you will put perpendiculars from any 2 points. Let the line L be the projection of the line L in the plane. If d is the distance of the point from L, okay, then d square. So what is it about that projection you see? Projection means, suppose this is the line and this is the projection line. L is the projection. So projection means what? We will just we'll drop foot of perpendiculars from any 2 point, and then we'll have 2 points and we'll have sufficient information to write, right? So see, we can find point of intersection of line and plane. We'll get 1 point from there. So let's find out point of intersection of line and plane. Line and plane, right? So what is general point? General point on line. What is that? General point on line. It is, let's put it equal to r. So 2r plus 1, comma, r plus 3, comma, 2r plus 4. So this will satisfy the plane ka equation. So put it in the plane ka equation. So x is 2r plus 1 minus 2y. So minus 2r minus 6 minus z minus 2r minus 4 equal to 3. So this 2r will get cancelled out. So minus 2r and minus 6 minus 4 minus 10 minus 10 minus 9 is equal to 3. I am correct? Minus 6 minus 10 plus 1, right? So minus 2r is equal to 12. R equal to minus 6. So we got this point of intersection, guys. We got point of intersection. What is it? R equal to minus 6. Put it there. So minus 6 minus 11. Right? Minus 6 plus 3 minus 3. And minus 12 plus 4 minus 8. We got this point. Right? We need one more point. We need one more point for that projection. So consider any point here. Consider any point. Let's say 1, 3, 1, 3 and 4. Let's say the known point on this line is 1, 3, 4. 1, 3, 4 is the known part. So drop perpendicular. That foot of perpendicular will give you the other point on that projection wala line. So let's find out foot of perpendicular. Let's find out foot of perpendicular. Foot of perpendicular From which point? From 134. From 134. So let's say foot of perpendicular is alpha, beta, gamma. So alpha minus 1 divided by 1 is equal to beta minus 3 divided by minus 2 is equal to gamma minus 4 divided by how much? Minus 1 is equal to minus times. Put points there, guys. So 1 minus 6 minus 4. So it is minus 11. Right? 1 minus 6 minus 4 and then minus 3 as well. 1 minus 6 minus 4. So minus 10, 1 minus 10, 13, minus 12, right? Yeah, minus 12 divided by a square plus b square plus c square. So 4156. So this overall will be equal to 2. So from here you can see what is the foot of perpendicular. Foot of perpendicular is alpha minus 1 is equal to 2. So alpha is equal to 3. This point here. Then beta minus 3 is equal to minus 4. So minus 4 plus 3 minus 1. Then gamma minus 4 minus 2, it is 2. So we have got 2 points on that line L. Now we can write equation of the projection of that line L. What is it? What is it? The dr. Dr of L will be what? Subtract it. This is 40 minus, this is 4, sorry 2. Right, 3 minus 11. So 14 minus 1 plus 3. So 3 plus minus 1, 2. And 2 minus 8, 10. Right, or we can say 7 comma 1 comma 5. So this is dr of that line. So we got dr, we have the points. So it is x minus 3 divided by 7, y plus 1 divided by 1, z minus 2 divided by 5. So this is the equation of that line L. Now what does it want? Distance of the point 006 from line L. Right? 0,0,6 from the line L. So if you want distance of 0,0,0,6, you see 006 and from that line L. So we need to find out that point here. So what is the general point here? It is 7r plus 3, comma, r minus 1. We are just putting it equal to r. So 5r plus 2. So this is the general point on line L. So you see just subtract it. So what is dr here? Dr of this segment will be 7r plus 3, r minus 1, 5r plus 2 minus 6. So 5r minus 4. So dr, now we'll take dot of dr is equal to 0. So 7, 7, 49r plus 21. Then r minus 1 and 25r. Oh my god, 0. So from here we'll have value of r. Then you will put value of r here and then you will find out distance. I don't know how it got so calculative. So maybe there might be some calculation error, but I hope the methodology is clear to you. Right? The projection here. Okay, the projection. Now 006, is it satisfying? No. Yeah. So this projection here, I hope the idea behind all this projection, how do we have taken projection, is clear to you. Clear? Okay. Just calculate the answer on your own. Moving to next part. The distance of the point from the plane measured parallel to a line. See, distance of a point 1 comma minus 2 comma 3 to the plane equal to 0, x minus y plus z equal to 5. Right? And measured parallel to a line. See. So suppose this was the line whose direction ratio is given. What is that? 2, 3 minus 6. Right? So we want distance parallel to that. Right? We want distance parallel to that. We want distance parallel to that line. So we can write equation of this PQ. Right? What is the equation of PQ? What is the equation of line which is passing through PQ? The line through PQ. Line through PQ, guys. We can write because we have point and these two will have same dr. So x minus 1 by 2, y plus 2 divided by 3, z minus 3 divided by 6. This is a PQ ka equation. 2, 3 minus 6, 2, 3 minus 6. Right? And 1 minus 2, 3. Clear? Then we'll write a general point here. General point will be, again put it equal to r. So 2r plus 1 3r minus 2 and 3 minus 6r. Now this general point will satisfy plane. We are trying to find out point Q. So this general point will satisfy plane. So let's simplify it. So x is 2r plus 1 minus y. So minus 3r plus 2 and plus z is equal to 5. So what is r, guys, from here? 2r minus 3r minus r minus 7r. Right? 2r minus 3r minus r 7r. 3 to 5, 3 to 5, 5 1 6 minus 1. So r comes out as 1 by 7. Right? This r comes out as 2r minus 3r minus 7 9r. Right? 2 1 3 3 3 6 minus. So r value is 1 upon 7. So if r is 1 by 7, what is that point Q? That point Q, which is the general point. So put r equal to 7. 2 by 7. Right? 7 to 9 by 7. What is this? 7 to 14. Right? 3 by 7, 11. So 14 minus 11 by 7. And again 3 minus 6r. So 7 to 21. 21 by 6, 15 by 7. Right? We have got this. Now we can find out distance PQ. What will be distance PQ? Equal to square root of 1 minus, so 4 by 49. Plus minus 2, so plus. So 7 to 14, 9 by 49. Then 7 to 21, 6, 36 by 49. So clearly this is 49 by 41. Distance is shortest. This distance D is 1. This is the answer. Right? See, this was something new, that we had to find a distance parallel to a line, because several distances are possible. In general, from point to a plane is perpendicular distance, but it is not perpendicular because it is clearly mentioned we have to find distance parallel to some line. Okay. Let P be a plane containing the line. Plane P divide the line segment. Okay, so P is the plane containing the line. So as you can see, so this plane is passing through 0, 0, 0. Right? And it is containing this line also. This line. So to find out equation of this plane, we need to figure out what is its dr. So for that, let's assume any 2 points on the plane. So 1 point is how much? 1 point is, this is x minus 1 by minus 1. Right? This is x minus 1. So 1, comma minus 4, comma minus 2. This is 1 point. Let's assume one more. If I put x equal to 0, right? If I put x equal to 0, so 1 is equal to y plus 4 by 2 is equal to z plus 2 by 3. So y will be how much? If x is 0, y will be how much? Y will be minus 2 and z will be how much? 1. Right? So to find if equation of this plane, now we need to just take cross of these two, PQ. Right? Suppose this is O. So we can find out P cross Q, I cap, then minus 4j cap and minus 2k cap, right? This is P vector. And what is Q vector? This is minus 2j cap and plus k cap. So the cross of these two will be the normal for the plane. So what is normal for the plane, guys? I, j, k, 1 minus 4 minus 2 and 0 minus 2 1. Calculate it. I cap, this is minus 4 minus 4 minus 4 minus 8, correct? Minus 4 and then again minus 4 minus 8. Minus j cap, this is 1 plus k cap and this is minus 2, right? So minus 8 I cap, minus j cap, minus 2k cap. That is the normal. So we have got equation of plane now, right? This is passing through origin. Since it is passing through origin, so we can write equation of plane. What is it? This is minus 8x minus y minus 2z equal to 0. Basically, it is 8x plus y plus 2z equal to 0. I think now you can simplify it, guys. Once we have got equation of plane, it says that there are 2 points. There are 2 points. Minus 3 minus 6 1 and 2 4 minus 3. K is to 1. So write any one, either x or y. So minus 3 right? Plus 2k divided by k plus 1, comma. So you can write x, y, z point and then you will satisfy them in this plane. You will have value of k, right? If this is dividing the case to 1, we can have x, y, z, and this is lying on the plane because this is divided by the plane. So that point you satisfy in the equation of the plane, you will have your value of k. Clear? Here, the main logic was finding normal for the plane, right? Clear? It was obvious that it is passing through 0, 0, 0. So one point was known. So I got two vectors. I took cross. I got the normal. I got equation of plane. Rest is simple. Okay. So consider three planes, 3x plus. So I can take 3 common. I can take 3 common. So P1 is x plus 5y plus 7z equal to 3. What is P2? X minus 3y minus z equal to 5. And what is P3? P3 is 2x. So take 2 common, x plus 5y plus 7z equal to 5 by 2. So you can see guys, P1 and P3 have same set of dr. So P1 and P3 are parallel. Okay. Now, the plane passes through the points, these ABC. If O is origin, then the projection of OP on this plane. So I don't think I need to simplify it. See, once you have equation of plane, right, OP, P is 2, minus 1. So suppose this is OP here. So I'll only tell you the method. After you have got equation of plane, so if you want projection of OP guys, so simply drop perpendicular from O, let's call it O1, and then drop perpendicular from P, let's call it P1, right? So you will find out foot of perpendicular from there, and then you will join it. So O1, P1 will be the projection, right? We need length, right? We need length. We need length of this. So length O1, P1 will be the projection length. What to do? Point O, point C. O is the origin, 0, 0, 0, and P is what point? P is 2, minus 1, 1, right? So we need projection of OP in the plane. So from point O and point P, you just draw perpendiculars, foot of perpendiculars by the formula. Then length O1, P1 will be the projection. Your answer will be length O1, P1. And calculating equation of plane is very easy here because it's given 3 points, right? Plane passes through 3 points. So if a plane is passing through 3 points, I told you already, right? Suppose this is A, this is B, this is C. So what to do? Just join any two, make two vectors, take their cross. The normal vector will be equal to B minus A cross B minus C. So from here you will have normal vector, right? You can choose any one point, you will have equation of the plane, and then do this calculation. Very calculative, but solvable. You can solve on your own. I have told you the logic. If the line meet the plane at a point P, okay, so it's like intersection of line and plane. Quite simple concept. So to find point of intersection of line and plane, you assume general point on the line satisfying the plane. So let's put it equal to R. So what is general point? General point on the line will be equal to how much? 2R plus 1. Then 3R minus 1. Then 4R plus 2. So this is general point. And this general point will satisfy this plane. So put it there. This general point will satisfy this equation of plane because the point is lying in the plane. So 2R plus 1 plus 2Y. So 6R minus 2 plus 3Z. So 12R plus 6 is equal to 15. So how much is that? So 12, 6, 18 to 20R is equal to. This is 6 minus 2, 4, 4 plus 1, 5, 10. So from here we get R equal to 1 by 2. If R is 1 by 2, now you can find out the distance, right? What is the general point? What is general, this point of intersection will be? Put R equal to 1 by 2. So 1 by 2, this is 2. Then 3 by 2 minus 1, 1 by 2. And then 1 by 2 to 4 to 6. So distance we want from origin. So from 0, 0, 0. Now you can calculate their distance t. Clear? So if it is about finding point of intersection line and plane, assume general point on the line and satisfy in the plane, you will have it. Quite simple. A plane which bisects the angle between two given planes, guys. So simple. Directly formula based questions are asked. Just write the bisectors. 2z minus 4 divided by how much? Under root of a square b square c square is 3 equal to plus minus. Plus minus, this is x plus 2y plus 2z minus 2 divided by, this is 3. So this will cancel out. So you will have two bisectors from here. Use plus and minus and then check which point is satisfying. The plane passes through this point and parallel to the lines, right? Pass the point. Guys, I have already explained this, that if the plane is parallel to two lines, so basically for both the lines we have their parallel vectors, right? Like for line 1 and line 2 we have parallel vectors. So to find the normal to the plane, what we'll do? We'll take cross of the normals, cross of those their parallel vectors P and Q, and that will give us the normal vector, right? The normal vector here, what will be the normal vector for the plane? It will be cross of P1, P2, the parallel vectors 3, minus 1 and how much? 2. And the second one 1, 2, 3. So this will give you normal vector and point is already there. What is point? Point is 4, comma minus 1, comma 2. So normal vector is there, point is there. You can calculate equation of the plane and you can check from the options which one is passing through it. So you see, most of the problems that we are dealing with were very, very simple. The plane part is exceptionally simple. Okay, slightly calculative in some problems, but easy peasy. Line of intersection of planes. See, when we write that P1 is equal to 0 equal to P2, like when we are writing this, so basically we are trying to find out the line of intersection of planes. So when two planes intersect, guys, you see, when two planes intersect, so you can clearly see there is a line of intersection for them. To visualize this, you can just open your notebook and you can see that when you open it something like this, so there is a one corner. So that corner there is what? That corner there is giving you the feel of that line. So when two planes intersect, they will have a line of intersection, right? So we have to find out this line of intersection. This line of intersection for two planes. The idea is very simple. What to do? See, this is normal for plane 1, normal for plane 2. So when you take their cross, okay, this is n1, this is n2. So the cross of the normals will give you a vector which is parallel to this plane, line L, right? So for that line of intersection, the DRs, the calculation of DRs is super simple, right? For that line L, for line L, the DR will be n1 cross n2. DR will be n1 cross n2. For line L, the direction ratio of parallel vector, DR of parallel vector. DR of parallel vector will be n1 cross n2. But only direction is not sufficient. We have to have a point also. To write, we need one point also. We need one point. We got the direction, right? We got the direction. Now what to do for that point? So for the calculation of point, for point on the line, put x or y or z equal to 0 in both the planes, and solve for the other two. That will give you the point on in the line. What to do? I'll write, I will have equation of two planes. I'll put x equal to 0 or y equal to 0 or z, anyone. Suppose if I put x equal to 0, I'll solve for yz. So 0, y, z will be point of intersection, right? And that will be the line in the plane. Okay. So like here, so lambda be an integer if the shortest distance between the lines, you see they have written, okay, I think this question by mistake they have written here. Okay. So let's skip it. This by mistake. L1 is the line of intersection of the plane 2x minus 2y plus 3z minus 2 equal to 0. Okay, so this time L2 is the line of intersection of the planes. Okay, then the distance of the origin from the plane contains lines L1 L2. Use calculations. So here I'll only show you that how to calculate line of intersection here for these two planes, right? So initially P1 is what? 2x minus 2y plus 3z minus 2 equal to 0, and P2 is how much? P2 is x minus y plus z plus 1 equal to 0, right? So I'll show you that how to calculate the line of intersection, which is also called, like, this is called unsymmetrical form. This particular expression, when you write it like this, this is called unsymmetrical form of the line. So from unsymmetrical, we convert into symmetrical form by finding the dr of parallel vector and the point of intersection. So here, if I have to find out their the parallel vector, so parallel vector P for the line, okay, their line of intersection, they say L1. So for L1, parallel vector P will be equal to ijk. This is 2 minus 2 3 1 minus 1 1. What is it? I cap. This is minus 2 and plus 3. This is 1, right? Minus 2 plus 3 minus j cap. So 2 minus 3 minus 1 and plus k cap. This is minus 2 and plus 2 0. Am I correct? Minus 2 and minus plus 2 0. Okay. So this is I cap minus plus j cap. So we got parallel vector for that line I cap plus j cap for line L1, right? For line L1, I cap plus j cap. Now what is next seen? Is it correct? 2 minus 2 3 1 minus 1 1, right? I, this is minus 2 plus 3. J, this is the minus 2 minus 3 minus 1, and k is minus 2 plus 2. Right. So we got parallel vector for line L1. I need point also. So what did I tell you? That put x or y equal to or z equal to 0. So in P1, P2, right, I got parallel vector. So for point now, for point, I'll put x equal to 0 in the planes, P1, P2. So put x equal to 0. So we get minus 2y plus 3z minus 2 equal to 0. And P2 will be what? P2 is minus y plus z plus 1 equal to 0. Minus y plus z plus 1 equal to 0. Now solve these two to get the point of intersection. So here I'll multiply it by 3, right? So if I multiply this by 3 and then if I subtract them, so minus 2y minus 3y, so subtract will be y, and 3z minus 3z, and this is 3, so minus 5, 0. I hope this is correct, right? This will be minus 3y minus 3, this will be 3z and 3. So if I subtract, minus 2y plus 3y will be y, this will be 0, and minus 2y will be 5. So y is 5. Y we got 5. What will be x then? X is 0. So what will be z then? Y is 5. So minus 5 here, minus 5 plus 1, minus 4, z is 4. Right? So line L1 can be written now. Line L1 can be written very easily. So this is how much? Line L1. This is line L1. So guys, line L1 we can write because we have now everything. So it is point of intersection is x minus 0 divided by how much? The is 1. Y is 5. Y minus 5 divided by the parallel vector j is also 1. Then z minus 4 divided by 0. This is line 1, the point of intersection of P1 and P2. Right? Similarly, you will find for the other pair also. Similarly, you will find, now this has to be the lengthiest question ever for that paper. In fact, for that paper at least. Because the job is not finished here. This is only the 30%. You will find out point of intersection of these two lines, planes also. After that, you will find out a plane which is containing these two lines, and then you will find out the distance of the origin. Right? So it's very calculative. The rest is up to you. You calculate on your own. I have just shown you that how do we find the intersection of planes, the line of intersection of planes. Clear? The parallel vector first by taking cross of normals, and then you can put x equal to 0. And sometimes what will happen when you put x equal to 0, maybe y and z will have same equation in the both one. Like the coefficient will become proportional. So don't put x equal to 0. Instead put y equal to 0. Okay. Ultimate aim is that we should be able to find our intersection. So distance of the point, line intersection of planes. So guys, what is it here? Plane 1. Plane 1 is 2x plus 3y plus 2z equal to 0. And plane 2 is 2x plus 3y plus 2z equal to 0. Plane 2 is x minus 2y plus z equal to 0. Right? So for that line of intersection, we can calculate the parallel vector P, that is equal to I cap, j cap, k cap. So it is 2, 3, 2, 1 minus 2, 1. So I cap, what is it? This is 3 plus 4, 7. Right? 3 minus plus 4 minus j. This is 2 minus 2, again 0. 2 minus 2, 0. And plus k cap. What is it? K cap minus 4 minus 7. Right? So we can say that 7 I cap minus 7 k cap, or we can simply say 7 I cap minus k cap, or we can simply say I cap minus k cap. That is the parallel vector. Right? Then we need point of intersection. So for point of intersection for these two planes, you see x, y, z. So I think it's very clear that the line will be passing through 0, 0, right? The line will be passing through 0, 0. Because if you put x equal to 0, you will have same equation in y plus 2z. So that will give you y equal to 0 and z as well 0. That line is very simple to find out then, like x upon 1, y upon 0, z upon minus 1. That is the equation of the line, and rest calculation up to you. They want distance from where? Minus 1, 2, minus 2. So just assume the general point and do the remaining thing, how to find a distance. Okay. I hope you know it, right? I hope you know it. What to do? We'll put it equal to r. So general point, right? This is, the point is minus 1, 2, minus 2. So general point here, what is general point? It will be r, 0, minus r. So what is this dr here? What is this dr? This dr will be, for this dr will be r plus 1, minus 2, and 2 minus r. Right? Subtract r plus 1, 0 minus 2, and 2 minus r. So after we're getting this dr, see, this and this are perpendicular. So we can get r here by taking dot equal to 0. So r plus 1, this is 0, and minus 2 plus r equal to 0. This is minus 2 plus r. So we can see here 2r. So r is equal to 1 by 2. So put it here, 1 by 2, 0, minus 1 by 2 is the point. Then you find out the distance. So 1 by 2 minus 1, so it is 3 by 4. Then this is 2 only, so 4. And then again, this is minus 2. Yeah. So you have clear idea here how to figure out. This will be the answer, guys. Understood? Moving to next question, which is the last part of our topic. Next part, family of planes. Just like family of lines, if we have planes intersecting, right? Suppose this is two planes are given, P1, P2. So obviously we'll get a line of intersection. So if I have to write equation of plane which is passing through P1 and P2, now see, several planes can be there which will pass through intersection of P1, P2. We can draw infinite planes. Right? We can draw infinite planes which will pass through intersection of that P1, P2. Getting my point? Right? So this family will have one thing common, that line of intersection being common. So the family of planes, we can write that family of planes passing through intersection of P1 and P2 is given by P1 plus lambda P2 equal to 0. Right? And that's it. The sufficient information. And for calculation of lambda, there will be always one extra condition given. So use that condition, find value of lambda. For example, you see, this is 2021 problem. Equation of the plane at distance from the origin which contains the line of intersection. Now see, line of intersection does not mean we calculate directly line of intersection. You see, so the required plane will be what? It will be x minus y minus z minus 1, right? And plus lambda times 2x plus y minus 3z plus 4 equal to 0. This is the required plane, right? What information is there? That from distance from origin, the distance is root 2 over 21. So write it in proper form. It will be 1 plus 2 lambda times x minus 1 plus lambda times y, then minus z minus 3z. So minus 1 plus 3 lambda times z, and then minus 1, 4 lambda. 4 lambda minus 1. So this we have got in the equation of the plane form. Right? This is P1 plus lambda P2. And what's given? The distance from origin is 2 by root 21. So we can get value of lambda. So put 0, 0 here. Use the formula. So under root of square of all these. 1 plus 2 lambda square, 1 plus lambda square, then 1 plus 3 lambda square mod. This is given equal to 2 by root 21. Root 2 by 21. Right? So with calculation of this, from here you will get value of lambda. From here you can get value of lambda, and then put back here you will have equation of the plane. Right? And the calculation looks difficult here, but once you square both the sides, it will be very easy. Multiply, half of the terms will get cancelled out. Fine. Let's solve next problem. Similar problem. Equation of the plane passing through the line of intersection of the planes and parallel to the x-axis. Now this is even easier. Okay, the equation is parallel to x-axis. So see, what is the one plane? This will P will be like this is x plus y. Replace r with x, y, z. So x plus y plus z minus 1 equal to 0. This is one plane, and this is 2x plus 3y minus z plus 4 equal to 0. So our plane will be, this is 2x plus 3y minus z plus 4, p1 plus lambda p2. So p2 is x plus y plus z minus 1 equal to 0. So write it properly. 2 plus lambda times x, 3 plus lambda times y, then lambda minus 1 times z, and plus 4 minus lambda equal to 0. So this is the plane ka equation, right? Now what do we need? What do we say? That the plane is parallel to x-axis. So if plane is parallel to x-axis, guys, this is x-axis. So for x-axis, what is dr? Dr is 1, 0, 0. So the dot will be 0, right? The normal of plane and the dr of that x-axis, the dot product will be 0. What is it? It is only 2 plus lambda into 1 should be 0. So from here lambda is equal to minus 2. We have lambda equal to minus 2. We put back here, you will have equation of the plane. Plane P will be equal to, put lambda equal to minus 2 here. So y minus 3z, and this is 6, 0. You can then match your answer, guys. Okay. The similar question, plane P contains the line and is perpendicular to the plane. Same question, exactly same question. Write P1 plus lambda P2 and then just put the dot equal to 0, you will have lambda. Right? Exact same question. Right? The plane equation, plane passes the line of intersection of this and the point is this. So write the equation of the plane and let it pass through minus 2, 1, 3. You will have your answer. That is all. All 4 questions I have shown you is from 2021 and all are super simple. What was there? The concept P1 plus lambda P2, and to find out that lambda, use the condition. Clear? So guys, this has been a really lengthy lecture, but I have covered everything in vector and 3D. So I assume that whatever things you have, if you have watched this entire lecture, you are going to do brilliant in vector 3D, guys. The next lecture will be coming up with probability. Till then, keep learning. Bye bye.